On behalf of the organizing committee of SCM 2025, being organized by Atomic Minerals Directorate of Exploration and Research (SR), it is my great privilege to extend a warm and heartfelt greetings to this distinguished gathering to the workshop on strategic and critical minerals, challenges and future prospects on the date of 27th May 2025. We are honored to host the esteemed guests from different organizations and all who are connected online with us on this beautiful and pleasant morning in Bengaluru, the city of gardens. It is my sincere honor to extend humble and respectful greetings to the Chief Guest, Shri B. Sharvanan, former Director and Outstanding Scientist, AMD. I also warmly greet our guest of honor and patron of this workshop, Shri Dheeraj Pandey, Director, AMD. A warm welcome to our additional directors, R&D, Shri K. L. Mundra, who is connected to us online. Extending my respectful welcome to our Regional Director and Chairman of today's workshop, Shri C.B.K. Varghese. My respectful greetings to our former Additional Director, Dr. S.A. Pandit, and also a very respectful greeting to Shri P. Krishnamurthy sir, Dr. P. Krishnamurthy sir, who was former Regional Director of AMD, and also other distinguished speakers. A special mention goes to the Director, GSI, Shri Rajesh Durai, Shri Harish, Deputy Director, DMG Karnataka, Dr. Ravi Kumar, Director, Geophysics, RSS, DSI, Bengaluru, and Shri Kannan, Director, UCIL, including our beloved Tirupati sir, former in charge RMRD, to this enthralling workshop. I request our convener, SCM 2025, and our Deputy Regional Director, Shri P. Jagdishan, to accompany our chief guest of the day, former Director, Shri B. Sharvanan sir, Director, AMD, and guest of honor, Shri Dheeraj Pandey, and Regional Director, Shri C.B.K. Varghese sir, to grace the dais with their presence. Thank you, sir. As a gesture of gratitude, I request our Regional Director to kindly present a sapling to our Chief Guest, Sharvanan sir. Ashwati, please. I also request sir to present a sapling in gratitude to his acceptance of our invite to our Director, Shri Dheeraj Pandey. I request our convener of the workshop and Deputy Regional Director, Shri Jagdishan, to present a sapling to our Chairman of the workshop, Shri C.B.K. Varghese sir. I now request Shri Nandkishore, Officer in Charge Chemistry, to present a sapling to our convener of the workshop, Shri Jagdishan sir. Now there will be some presentations of bouquets in the virtual mode, which I think it's not visible. Okay, Dr. P. Krishnamurthy, I'm sure he is connected online. I request a bouquet to be presented on virtual mode. K.S. Mundra issued an R&D AMD, again a book on the virtue book because he's connected to us online. I request Shri Bala Subramani to welcome Shri P. Rajesh Durai with the bouquet. I request Shri Christopher to welcome Shri Harish with a bouquet. I request Shri Sudhakar to welcome Shri Ravi Kumar with the bouquet. I request Srimati N. Rupa to welcome Shri Dinesh with the bouquet. I request Dr. Krishna Kumar to welcome Tirupati sir with the bouquet. I request Sri Pachamuthu to welcome Pandit sir with the bouquet. I request Sri Parashar to welcome Dr. Krishnamurti Desai with the bouquet. I request Debashish to welcome ma'am from JSI with the bouquet. Thank you, dignitaries on the dais. Thank you, speakers, and thank you all the delegates and everybody who have participated in welcoming the guests. In this pursuit of knowledge, let us dispel all darkness, darkness of ignorance, and spread the knowledge of wisdom by lighting the lamp. I request all the dignitaries on the dais to come forward to light the lamp, lighting the workshop as a shared journey of learning and discovery, also of growth and forward thinking, which truly the workshop aims to ignite. I request APO Madam Mrs. Pushpa Vakte to please assist.
या कुन्तेन्दु तुषारहार धवला या वीणावरदं या श्वेतधर्मासना या ब्रह्माच्युतशङ्कर प्रकृति प्रेमैकदान्तिका सरस्वती भगवती वीणा पुस्तकधारिणीं भयदा जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थिता वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदा
Thank you, sir. As India accelerates its journey towards becoming a $5 trillion economy and a global leader in clean energy and advanced manufacturing, at the heart of this transformation lies a group of minerals that are anything but ordinary. Critical and strategic minerals such as lithium, cobalt, rare earth elements, graphite, uranium, thorium, to name a few, are at the focus of the global shift towards renewable energy as well as clean and green energy, digital technologies, and sustainable development. From powering electric vehicles, enabling wind turbines and high-tech manufacturing, to minimizing carbon footprint, these minerals are essential to our economic and environmental future. For India, ensuring a secure and sustainable supply of these resources is more than just a mining concern. It's a national priority which encompasses uncompromisable national security also. The path to Atmanirbhar Bharat runs through the rocks and terrains which you explore every day. Exploration geologists are the starting point of this value chain. Without reliable data, targeted surveys, and scientific explorations, we cannot hope to build domestic capabilities or reduce our dependence on imports. Although the government of India has already taken key initiatives, yet there is much more to be done, from motivating exploration to securing strategic partnerships and building value chains within the country. Therefore, this workshop is designed to bring expertise into focus, not just to understand the current geological potential, but also to discuss how we can overcome challenges such as limited domestic reserves, complex geology, environmental sensitivities, and the need for new exploration techniques. It's a platform to share knowledge, align with national priorities, and discuss how we can strengthen our domestic resource base through science-led sustainable exploration. With this bird's-eye view of the concept on which the workshop proceedings have evolved, I request our chairman of SCM 2025 and our regional director to welcome the August gathering. Sir, please.
Namaskar. Good morning to one and all persons. Respected Chief Guest, outstanding scientist, and former Director, AMD, Sri Ceremonial sir. Guest of honor, Director, AMD, Sri Girish Pandey sir. Former Regional Director, Dr. P. Krishnamurthy sir. He is joined online. Additional Director R&D, Sri K. Mundra Saab, all joined online. Dr. S.A. Pandit sir, former Additional Director, AMD, Sri Tirupati Saab, former in charge, Army Environmental and Urban Elements, distinguished scientists from GSI Bengaluru and DGM Karnataka, UCAM, esteemed colleagues from AMD, ladies and gentlemen. I also welcome all the esteemed members of AMD family who have joined the workshop on virtual mode. It gives immense pleasure to welcome you all on the occasion of one-day workshop on strategic and critical minerals, challenges and future prospects being organized by AMD Southern Region, Bengaluru. Atomic Minerals Directorate for Exploration and Research is the oldest constituent unit of Department of Atomic Energy, entrusted with the responsibility of exploration of mineral resource of uranium, thorium, rare metals like niobium, tantalum, lithium, beryllium, zirconium, titanium, and uranium thorium during REs in order to support the nation's nuclear power program. Besides its mandate of carrying out mineral exploration and allied research activities, this directorate also plays a critical role in formulation of the country's mineral laws and their amendments in general, as well as overseeing the regulatory aspects of atomic minerals in particular. As AMD celebrates its diamond anniversary, India is looking ahead towards self-reliance and technological advancement in the sectors of clean energy, manufacturing, medicine, as well as defense to cater to the national security. At this juncture, the role of strategic and critical minerals towards fulfilling the vision of Atma-Nirbhar Bharat, that is economic self-sufficiency and national development, is the paramount significance. Besides far-reaching aspects of geopolitical strategies and international access to mineral resources, global supply chains pertaining to strategic and critical minerals cannot be overlooked. Against this backdrop, workshop on strategic and critical minerals is being organized here in order to comprehend the current exploration status, challenges faced, and the way forward. The aim of this workshop is to bring together eminent scientists and experts from the geoscientific community, explorations, and policymakers for contemplating on the aspects of strategic and critical mineral exploration, with a special reference to southern India. As all of us know that southern India hosts the largest and richest uranium deposits of the country, and in its special program for inauguration of its Monolith of the largest and richest deposits of the country would be there, and I have welcomed you all for that function also. In fact, this southern India hosts the single lithium deposit of the country, that is Marragalla, and a good RE deposit is coming up in Pakanadu also. It is also important here to probe into the recent amendments of the mineral laws and rules pertaining to forest clearance and aspects on the emerging trend in the extraction of strategic minerals. On behalf of the Southern Region, Bengaluru, I express my sincere thanks and welcome to all the esteemed guests, speakers, and young minds gathered here today and online for accepting our invitation and participating in the workshop. I am absolutely certain that the event will be an insightful and enriching experience for all. I once again welcome one and all with the hope that everyone present today will have a great time ahead. Dhanyavad, Jai Hind.
Thank you, sir, for such an insightful and elevating introductory welcome address. Your perspective has set an inspiring tone for the workshop. Your words, as always, has set a positive and energizing tone for the audience, and your unstinted guidance has always inspired us with confidence and hope for the best. Next, we have an exciting moment, formal release of the abstract volume by dignitaries on the dais. Ashwati, please bring it on. Thank you, sir. And now I may request our guest of honor of the day, our revered director, Shri Dheeraj Pandey, sir, to address the August gathering. So,
Namaskar and good morning to all. Last year on July 29th, KFT celebrated its diamond jubilee, and at that time we had decided that we would have year-long celebrations, including arranging one team meeting or a workshop in headquarters as well as all the 7 regions of AMD. So this is a part of that series, and today's workshop on strategic and critical minerals, challenges and future prospects at Southern Region AMD. We'll be focusing on these aspects of the criticality of minerals and their availability in our country, and the steps that have been taken to ensure a steady supply of these minerals. If you talk of critical minerals today, it is a buzzword. Every country in the world today is focusing on these minerals. But it's not that the criticality of these minerals has been realized in the past 2 decades. Maybe for the industry today, for the newer technologies, the minerals may have been, the minerals are critical. But if you see from the point of view of critical sectors like the space, defense, or atomic energy, these minerals have always been critical for this high-tech industry. If you take the example of the Department of Atomic Energy, specifically AMD, we have been exploring and augmenting these minerals, although they were not earlier known as critical minerals. Many of these minerals were clubbed under the Atomic Minerals list that was defined under Indian India Act of 1957, the Part B of First Schedule. And this importance of these minerals for these high-tech sectors like, as I said, nuclear, defense, and space was always known to the world. It is only during the past 2 decades that the industry has realized that they are much more important to the present setup of the technology. And of course, once the government of India and the governments all over the world, they focused on achieving net zero. This realization came that these particular minerals, especially the rare earths, lithium, and other so-called rare metals, they have a very important role in bringing about this kind of energy transition. So this is the fact, and this is what paved the way for Ministry of Mines to include these minerals in a separate list of critical and strategic minerals in Part D, a newly created schedule, the NDRI. And for that reason, only 6 minerals which were earlier classed as atomic minerals, they were removed from the atomic minerals list and then put in the critical and strategic minerals list. The primary reason being, the atomic minerals as of now, they are not open for the mining concessions to private sector. So the Ministry of Mines,
it felt that probably if these so-called critical minerals would be removed from the list of atomic minerals and placed under a different category, which was now open to the private sector, perhaps the exploration and the augmentation of these critical minerals would go at a faster pace. So this is the primary reason for creating this list of strategic and critical minerals by the Ministry of Mines. And in this context, I would like to say that the Department of Atomic Energy in general and mainly in particular, we have a certain expertise in the exploration of these critical minerals. And in the recent past, you all may be aware, my colleagues in India, that we have stepped up our exploration in for these minerals, especially the rare earths and the lithium. And that's the reason that we was talking about to resources in Tamil Nadu and Karnataka. So Southern India as such has a huge potential for both the rare earths as well as lithium and other critical minerals like neodymium, tantalum, beryllium, zirconium, etc. So this workshop, it's apt that we have chosen this topic for today, today's team meeting. And there are dignitaries from GSI, from DMG. So it's a good gathering and a nice platform for interacting among ourselves. And once these interactions with bear fruit, probably Southern India is going to become one of the leading states in the country where many of the critical mineral deposits will be proved. And of course, that will also help the Ministry of Mines in undertaking various the auctioning of these blocks, which already I think Southern India is taking the lead. And in this context, again, once again, I wish this workshop a huge success. And probably after the conclusion of this workshop, we will be continuing the interaction between different departments like the DA, GSI, and especially DMG. And let's all work together and take this movement forward, especially the National Critical Mineral Mission, which have been announced by the government last year. So we should each be playing our role in seeing the success of this mission. So thank you all, and we are in.
Your words, sir, have not only set the stage for the workshop, but have also provided invaluable perspectives that will guide our ongoing discussions. We are deeply grateful for your time and for sharing your invaluable inputs with the August gathering. Thank you, sir. It is with great respect and honor that I invite our chief guest and outstanding scientist, former director, Shri B. Sharvanan, sir, to kindly address the distinguished gathering. Sir, please.
Good morning to all. Dignitaries on the dais, today's guest of honor, Sri B. Pandey, Director MD, Sri Varghese, Regional Director Southern Region, Regional Director Generation, and dignitaries in the audience, Dr. S.A. Pandit. He was our ex-additional director R&D, and our friend Sri Tirupati. Our friend from Geological Society of India, Geological Survey of India, DGM, and all my ex-colleagues of AMD and the family of Southern Region. First of all, I'm very thankful to the AMD management to invite me as a chief guest for this inaugural function of workshop on strategic and critical minerals challenges and the future prospects. It's a very hot topic. In fact, it's a really challenge. Exploring for strategic and critical minerals. It's a really challenge at the moment because the list of critical minerals which was released by the Ministry of Mines maybe about a year back, it consists of 30 minerals, critical minerals. So they are in different stages of exploration, different stages of utility for our country. So it is not a simple thing that you explore particular element and bring it into the production line to use for its use in the industry. It is not like that. It's a very complicated path one has to take. And also, other aspect I would like to emphasize here is that the difference between the strategic and critical mineral. You know, I don't really don't understand what is critical and what is strategic. So for all, I think it is interchangeable. What is they are important because they are mostly they are important, and it depends on the foreign exchange. It is useful in high-tech electronic industry, and as our director Dinesh told, it will be very useful in low carbon emission economy. That is going to be very important for the future. And also renewable energy technologies. So these are all going to be very, very important. These critical minerals, particularly minerals like lithium, cobalt. As far as lithium is concerned, the industry is very dynamic because now the world is looking for sodium ion batteries. Once that comes into the industrial level and from a day-to-day usage level, the use of lithium and requirement of lithium will go down. So these are all very dynamic systems. So it is going to be very, very tricky thing in the future to explore these minerals. So on this occasion of the workshop on strategic and critical minerals conducted by Ceremonial ALD, I welcome this initiative, and as Director told, there is a series of workshops and seminars being held all over the AMD offices. I welcome this initiative, and I wish all success for the successful completion of this workshop. Thank you very much.
We are truly honored and inspired by the distinguished address delivered by our esteemed Chief Guest, Sharwan himself. His words have not only enlightened us, but also added immense grace and significance to this occasion. We remain deeply grateful for his presence and invaluable contribution to this memorable event. Thank you, sir. As we approach the end of this inaugural session, I request convener of the workshop and our Deputy Regional Director, Sri A. P. Jagdishan, sir, to deliver the vote of thanks.
Thank you, madam. Very good morning to all. Dignitaries on the dais. The surroundings of outstanding scientist and former director, MD, chief guest of this program, Sri Dheeraj Pandey sir, director AMD, who is the guest of honor of this program, chairman of the SCM 2025, Varghese sir, Sri Varghese sir, regional director, Southern Region, Dr. S.A. Pandit sir, former additional director, AMD, Sri P.V. Tirupati sir, in charge RMR investigations, former in charge, and Sri Harish, joint director, Department of Mines and Geology, Sri P. Rajesh Surai, director, GSI, State Unit, Karnataka and Goa, and his colleagues, Dr. C.H. Ravi Kumar, Director GSI, RSAS GSI, and Sri J. Dinesh Khanna, Chief Superintendent, Uranium Corporation of India Limited, and Rajendran Saab, Journal of Geological Society of India, and all my colleagues of Southern region. Once again, a very good morning to all. It gives me immense pleasure to stand before you to deliver vote of thanks on the momentous occasion of workshop on strategic and critical minerals, challenges and future prospects being held today on the commemoration of Diamond Jubilee celebrations of AMD. We are greatly indebted to Sri B. Surroundings of outstanding scientist and former director AMD, who has kindly consented and graced this occasion as a chief guest. We express our gratitude to Sri Dheeraj Pandey of Director AMD for having given his permission to organize this prestigious workshop at Southern Region, Bengaluru, and his gracious presence, in spite of his very busy schedule, has elevated the ambience of this program. We extend our sincere thanks to Additional Director Research and Development, Sri K. L. Mundra Saab, and Dr. T. Krishnamurthy, former Regional Director AMD, who has joined this workshop through virtual mode. And we are also grateful to Dr. S. A. Pandit Saab and P.V. Tirupati Saab, former in charge RMR investigations, and Muralidharan Saab, who are physically attending this program. We are thankful to Sri Rajesh Durai Saab, Director, State Unit, Karnataka and Goa, Geological Survey of India, and Dr. C.H. Ravi Kumar, Director Geophysics, RSAS, Geological Survey of India, and his colleagues, who are taking out time in attending this workshop physically. We also extend our thanks to Sri H.S. Harish, Joint Director, Department of Mines and Geology, and his colleagues who are gracing this occasion. Thanks are also due to Sri J. Dinesh Khanna, Chief Superintendent, Project South, Uranium Corporation of India Limited, for undertaking this workshop physically. We also extend our deep sense of appreciation to Sri S.K. Sharma, Regional Director, Western Region, Sri S. Mandanwar, Regional Director, Central Region, Sri Bhaskar Basu, Regional Director, Northeastern Region, Sri S.K. Das, Regional Director, Eastern Region, Dr. J. Dixon, Regional Director, Northern Region, Sri A.R. Mugundan, Regional Director, South Central Region, and all their colleagues for witnessing this event in virtual mode. And we are also very thankful to all the former directors, additional directors, and all our senior colleagues who are witnessing this the prestigious event through online mode. We are also thankful to Sri CBK Varghese, Chairman SCM 2025 and Regional Director Southern Region, for his guidance and constant support in organizing this workshop. Our special thanks also to all the officials of Engineering Services Group, Southern Region, who worked tirelessly day and night for making these entire arrangements of the workshop and also the installation of Monolith. Our sincere thanks to Sri Rajesh Singh Ji, who have come from MD headquarters for overseeing the installation of Monoliths. Our sincere thanks are also due to all the persons who have worked behind the screen for the wonderful arrangements and the successful conduct of this workshop. Last but not the least, I sincerely thank all the organizing committee members of SCM 2025 for their contributions who worked tirelessly in the successful conduct of this workshop. Once again, I wholeheartedly thank one and all for the active participation and for making this workshop a grand success. Thank you. Jai Hind.
A few announcements before we conclude. Following the inaugural session, we shall proceed towards the monoliths which are placed outside the C block, which will be unveiled by our respected director, Shri Dheeraj Pandey sir. And this will be followed with high tea, and we should all assemble back in the hall for the next session, which will commence in another half an hour. Now we shall raise for the national anthem, after which we shall have a good photo session.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Okay.
Good morning once again, all of you. Our director, respected Shri Dheeraj Pandey sir, will be unveiling the monoliths in front of this August gathering, a very unique event indeed. The monolith on your right is a Tongarpalli monolith, represents a stromatolitic 30-line stone from Tongarpalli uranium deposit, which is the largest uranium deposit in India, with around 2.2 lakh tons of uranium oxide, that's about 60% of India's uranium reserve. This carbonate phosphatic dolostone hosted stratobound type of uranium deposit is unique in the world. The deposit is spread along 22 kilometers in length with a width of 3 kilometers and maximum depth of 1,000 meters. These stromatolites are one of the earliest visible signs of life on Earth. The one to your left represents Halkal monolith of vitiated limestone of Shahabad Formation, Bhima Basin, Yadgir district, Karnataka, which holds India's highest rate of uranium mineralization in vitiated limestone of Shahabad Formation, 1,200 million years old. Sir, please.
Highest, richest.
This is the largest, this is the highest.
This is the richest deposit and the highest in India.
So welcome back once again to this morning session. A very good morning once again. Before we start the morning session, which contains the most strategically and critically important deliberations follow, we have a short video on the limits of every SR, the journey from Patnagavan to the C block. memories recalled, emphasizing the long, tedious but exciting and thrilling journey of AMDSR, underlining the motto, those who search, find, and they shall move on with the blessings of all stalwarts and their own quest to know more and dream big. Paying homage to Dr. Syed Zakullah and Sudha of AMD family who have left us for their heavenly abode, we move on with the next session. It is my privilege to invite a remarkable geoscientist to the dais, Shri B. Sharvanand, former director AMD, outstanding scientist, and a seasoned field geologist whose contributions have significantly shaped the course of mineral exploration in the country. With decades of hands-on experience and visionary leadership, his insights are invaluable to this gathering. Sir, we are honored to have us today. Have you with us today. I'm deeply honored to have the opportunity to share a brief overview of his illustrious career before he addresses his directions. Shri B. Sharvanand joined Atomic Minerals Directorate for Exploration and Research AMD in 1986 in northeastern region Shillong after obtaining master's degree in geology from Madras University. He has been actively associated with the exploration and research for atomic minerals in different geological domains of southern, eastern, western, and northeastern parts of India, spanning over 38 years in different capacities. In his initial years, Shri Sharvanand has carried out reconnaissance surveys in Assam, Arunachal Pradesh, and Andhra Pradesh. Subsequently, as a team leader, he was involved in developing some of the AMD's thrust areas in Kalarki, Bhima Basin, Karnataka, Tumilapalli in southwestern part of Kadapa Basin, Singhbhum Shear Zone in Jharkhand, North Delhi Fold Belt of Haryana and Rajasthan, wherein his skillful and innovative exploration strategies resulted in large-scale augmentation of atomic minerals. Shri Sharvanand has the credit of bringing out the economic significance of alkaline complexes of Dharampuri Shear Zone, Tamil Nadu, Shivana Ring Complex, Rajasthan, and other types of Ambadongar for uranium, rare metals and rare earths. RMRE, Shri Sharvanand was shouldering the responsibilities as Director AMD since December 2022 to 2024 April, with overall planning, supervision, guidance, and execution of uranium and other atomic minerals exploration programs in different parts of the country. Shri Sharvanand was deputed by BAE to attend international events, PDAC in Canada, mining in Daba in South Africa, and IAC in Vienna, Austria, and Paris, France. Shri Sharvanand is a life member of Geological Society of India, Bangalore, Mineralogical Society of India, Mysore, and Indian Nuclear Society, Mumbai. Shri Sharvanand is the recipient of BAE Group Achievement Award for the year 2018 for the augmentation of uranium resource in Kanchankai uranium deposit and its environments and group leader. Shri B. Sharvanand has published and presented over 50 research articles in national and international journals of repute and in national and international scientific forums. I now invite Sir for his talk on short and long-term strategies for locating medium to high-grade uranium deposits in India. Sir, please.
Good morning, Mr. My talk is on the strategy for uranium exploration, particularly the high-grade deposits. We are interested in high-grade deposits. It is in fact a very memorable and happy occasion for me to come back to Southern region and deliver this lecture, because Southern region is very close to my heart, because I have been here for more than decades or so, and 2 stints I was here. Of course, I was working in Tumilapalli, and when Tumilapalli was coming up, and we had to establish the reserves. And also I worked in Bhima Basin, Godi, where Dr. Pandit, who has discovered the Bhima Basin mineralization, it was a huge promise. I will discuss Godi in detail. So Southern region as such very, very fruitful, and it is one of the hosts for uranium deposits in India as such, because it is a host for Tumilapalli. There is the largest uranium deposit in the world. Somebody told it is in India, but as such, it is the largest deposit in the world in terms of tonnage. So, my topic is the strategy for high-grade uranium deposit. Of course, the topic here, what I given in my abstract is identifying the medium and high-grade deposit, but I emphasize more on high-grade deposit, why it is important, and we have a lot of potential in India. Geologically, we are endowed with very right from Auckland to the recent geology is available in India. We also in some countries only few geological stratigraphy is available, but in India it is huge sequences available. So we have a lot of opportunity here. In India, if you see the list what is there in the screen, we have deposits which have been given by AA classification. We have 7 such deposits. Strata-bound carbonate deposit in Andhra Pradesh. Actually, this carbonate hosted cumulopathy type deposit was not there in IAEA scheme of classification, but later on it has been included as a separate class itself, because it's very unique in the sense that the limestone, the dolostone, is hosting uranium deposition. It's very, very rare and it is not known earlier. So, metamorphic type in Jharkhand and that Sindoom, Siazon, and a group of deposits. There is another IAEA classified deposit, sandstone in Meghalaya, stratiform fracture control unconformity. This is one of the important type of uranium mineralization in India, because it is the type of mineralization which will give high grade uranium deposit. So likewise, metasomatite in Rajasthan, granite related in Karnataka, there is Bhima and then group of Holy and Kanchankai, all those deposits. Of course, we were discussing in the morning with Dr. Pandey, QPC, cost per conglomerate, is the first oldest sediment known in the earth. So that we have in Karnataka, and a lot of work has been done, but economics comes in the way, so we have to lead that investigations. So in if you see the future prospective areas, if you see, other than those 7 those type of deposits, we have other areas like Keynote basin is again sandstone type uranium mineralization. Monolith basin is again sandstone type. Single cell zone, that is metamorphoid. That is also very important because presently we have about 6 provincial mines there. So now the productive geological setting there, single cell zone, and we have a lot of prospects also in future. So of course, this is a sort of I cannot say it is low grade. It is a say medium grade in Indian context, but there is a huge scope for discovering more and more deposits in these areas. Of course, CGGC is another geological setting. It is favorable, but we are able to strike something. What? So next is North Kadapa basin in Telangana and Andhra Pradesh. Again, here is unconfirmed related mineralization is and of course there are some small deposits are already proved because of various socio-economic reasons. They are not being taken up for mining. The Southern Kadapa basin, yes, we have this our Kamalapalli, and also there is one more geological setting that is virtual quasi. Very, very important, but at the moment ALD is not doing any investigation there because of again socio-economic reasons and forest cover, there is forest cover in that area. Again, I will come back to it in detail. Kalaki Basin is another very, very important geological setting where we can expect high grade uncontained type granite deposit. So Gondwana Basin, then Arvali Fold Belt, of course, we are investigating that, and the NDMB, we have some strong deposits. So okay, then why do we need uranium, high grade uranium deposits? Because our nuclear power program, it is envisaged that is about 2050. We are envisaging a large scale nuclear power production, and also as Mr. Girish Pandey told, net zero emission. That is also played very important role, and the country has to take nuclear route for achieving that net zero emission by 2070. So we have to, a lot of things are coming that Western Mass, small modular reactors, and all those things, but you need fuel. Fuel for that you need one of the very, very important, I don't know whether we should call it strategic or critical mineral, but it is required. So presently India is having a moderate uranium reserve, which is medium to low grade. When compared to the Canada and Australia, where the grades goes up to 25%, like that. But in India, we don't have such deposits. We have Gogi is one of the good grade. I cannot call it rich grade. It is good grade deposit, up to 0.1, 0.2% the grades. So our present day exploration strategy involves looking for concealed uranium deposits. Instead of conventionally searching the surface uranium anomalies, we should look for concealed uranium deposits where we have geological settings. We have all means to explore such deposits. Why again high grade deposit? Usually high grade deposits are small in extent, say about 10,000 tons, 30,000 tons, not in lakhs. It will be very small, but it will be very high grade because we have to handle very small quantum of ore. So thus we will be disturbing the environment very less, and also processing all those things will become easier. So we'll get a good amount of uranium. Whereas medium grade and low grade deposits should take up for mining, we have to handle huge quantum of ore. But there will have impact on the environment. So our objective should be to look for high grade deposit. So for that we have some of the geological settings that is conceptualized, also with some already existing uranium mineralization as well as deposit. So the first one will be the Lodi Antanakali Rastal deposit. It is a granite collected uranium deposit. We have some geological guides we have established, like nose-shaped geometry associated with reverse fault. So it occurs around the southern margin of the river basin. And then when you come to geophysics, of course we have airborne as well as ground geophysical data, moderate to low instability and zones with even anomalies. So these are the some of the exploration guides we have formulated. What we have to do is that we are having only the margins. We have the mineralization associated with this structure, the guides. What we should focus on is inside the basin. There is always, I used to tell that there are a lot of possibilities to strike a deposit, a deeper part of the deposit, where we can we have to look for structures through geophysics. So we have the airborne data And of course, we can always do the ground physics that identify these geological guides, exploration guides. Of course, our aim also is, at the present we are following this exploration guides and we are following them. And also, this for high grade, we should have a very long-term strategy. We should not leave it. If you don't intercept any good memory, we should not leave it. We should go on doing it. Maybe after 10 years, we may strike a big deposit. We are not going to get. So, Bima Basin is one of the very important areas. Of course, we are now doing this modeling, geomodeling, and other components. So another, of course, Bima Basin, we have some evidences for the high grade uranium mineralization. But when we come to Kalaki, Srisailam, Kannur, and Palnadu Basin, of course, Kalaki is one of the very important basin in terms of identifying the high grade uranium deposit, because the geology of Kalaki Basin resembles that of Canada. It is the lower Proterozoic and the middle Proterozoic cracks in between the unconformity. It's very typical of Canadian deposit. So similar, the geological setting is available in Kalaki. Of course, we have identified some of the signatures. We have identified like the structures, particular structures in Kalaki Basin, and of course, extension of the mineralization was not that good. But even then, with the help of geophysics and EM data, of course, we only is mainly focusing on collecting the electromagnetic data. That is very crucial for the locating such concealed. We are again concealed concept. We have to take it and we have to look for that. So, that as I told, identification of the slopes, one bounded basement along the basement sediment contact. So, these are all some of the exploration guides. They are very, very important for locating deposits. So, of course, we have input from Inaugural ground geological data over the geological element. It should be. We have already the whole data we have. We should review it. In fact, in my tenure, we are trying to re-look into those data by hiring some foreign agency or the Indian the experts can look into that, and we can have some collaboration like that. We can do that. So, apart from these targets, we have also some of the Proterozoic basins like Sunrise. So, we should go on looking for that. We should not leave it. So, there are a lot of scope for encountering high grade uranium. I will come to the southern part of the Kadapa basin. The uranium mineralization associated with Goichara corridor, that is the area Gandhi, Bengaluru, etc. Who are presently working in those areas, they may know these locations. Here, we encounter very high grade intercept, mineral intercepts, the borers. Some of the values were up to 20% of uranium. So, and the geologically, the Goichara corridor is overlying the basement, Arcane basement. So, it is also typically unconformity model we can. Of course, we cannot take it as analogy of Canadian, but it is setting is similar, and of course, we have the indication of 30% grade. So, it is very, very important, and we have established a small deposit And the problem was that forest and the red sanders, the area is fully covered by red sanders, very sensitive. So these are the problems. But geologically, if you see, the Stigapalapaya fault zone is a very important structure in the southern Kapa basin. So there are a lot of scope that we should have a model, develop model, and we should go for a large scale drilling in these areas. So that is all about the high grade deposits and their identification. When it comes to the medium and low grade, we have so many other geological settings are available in here, and it will give a large tonnage deposit compared to high grade deposits, and it will involve, as I told earlier, heavy large scale pool and mining beneficial more impact can be. So when you see geological settings available for this medium to low grade is our common step and potential business like Monolith. Other areas are like Kadrahat limestone, Indian supergroup, then dolomite rotas limestone, there is another part of Indian group, Alkar limestone, there is another part of Indian supergroup, then Chamakotra formation. So these are the geological settings available for these loading deposits. Then comes another important that single phase type, that is metamorphite type. We have there's a mineralization along with copper. Here the major copper deposits are also having uranium. Earlier, the UCL was operating the processing plant where they were recovering uranium also from the copper tailings of SCM mining activity, but presently probably it is not there. So all those continuous areas of the Gadaguda, discovered deposit. We have so many other areas like Puran Dungri, Ram Tapa, Kejuardari, all these areas, and our objective is to work out these deposits, and we are going to establish a good amount of uranium resources from this area. So conceptual modeling of global lake deposit was discovered a few years back from that is post-serpentinized peridotite, post-multimetallic uranium, thorium, lithium, was established in Udana, that is one of the achievements of UAE, but it is also a part of simulation. Then another important target geology for medium to low grade is NDLD, metasomatite type deposit. Already we have deposit in Rohit, the deposit of the UCL also is taken up from the area from here. And we are strong small deposits from Jahar, and there are other prospect areas that are nothing of the one sinking than the right in the name of that. There are other areas they are also targeting. So again, here also the uranium condensation is associated with geological anomalies. Again, exploration gates are available. We should keep on working in these areas. Particularly the fuzzy logic, like that, new techniques can be utilized for narrowing down the targets. Then, as I told, CDBC, of course, we are still working in this area. Here also, again, some of the geological signatures are available with us, and we should look for the such geological signatures in new areas, and we should try to drill those. Yeah, to conclude, this my talk. Geological settings, particularly tropospheric age, we are having in our country, where it has got a potential for great development projects. And also, we should look for concealing the uranium deposit by way of identifying the target areas by geophysical signatures and integration of surface geology as well as geophysical data with artificial intelligence and machine learning. And we have some collaboration with DIAS also on these techniques. But definitely, we should continue this work. And particularly those three areas I told for high-grade the deposits, we should have a long-term strategy, terminal for 20 years. Of course, low-grade deposit is will be coming on heavy. But for high-grade deposit, we should not lose heart. And, we should keep on working on it, even if you don't get particularly presently, we not necessarily for the example. But I am sure that from the other thing that we are missing and collaboration is going to be of high grade and rich performance. Thank you.
The talk is open for any sort of discussion, any questions, please, any queries. If there are none, then we proceed with the program. Thank you, sir, for the comprehensive presentation on India's evolving uranium exploration strategy. The emphasis on targeting concealed high-grade deposits, particularly with protein terrains, marks a significant shift from traditional surface anomaly-based methods. The integration of airborne geophysics, subsurface modeling, and advanced tools like AI and machine learning demonstrates how our exploration capabilities are both modern and forward-looking. These insights are particularly relevant as we strive to meet our future nuclear energy requirements and net zero commitments. Thank you very much, sir. Once again, I request our director, sir, to offer a memento to Ceremonial, sir, as a token of our gratitude for accepting our invite. It is with great honor that I invite our director and outstanding scientist, Atomic Minerals Directorate for Exploration and Research, Dr. Neeraj Pandey, a distinguished field geologist and guiding force for all young exploration geologists, for his keynote address, prior to which it is indeed a privilege and an honor to present a brief account of his distinguished career to this august gathering. Shri Neeraj Pandey is an outstanding scientist and eminent exploration geologist in Atomic Minerals Directorate for Exploration and Research, Department of Atomic Energy. He has more than 35 years of experience in exploration and research for uranium and atomic minerals in various geological domains of the country. He obtained an MSc degree in geology from University of Lucknow, Uttar Pradesh in 1987 and joined the prestigious Department of Atomic Energy as scientific officer in Atomic Minerals Directorate for Exploration and Research at Hyderabad in December 1988. Since then, he has served in various capabilities in regional centers at New Delhi, Jamshedpur, Jaipur, Bengaluru, and headquarters Hyderabad. He has made noteworthy contributions in prospecting and development of local uranium deposits in Rajasthan, Kuramti group of uranium deposits in Jharkhand, and Kanchankai Halkar uranium deposits in Karnataka. Shri Neeraj Pandey was conferred with the Department of Atomic Energy Group Achievement Award 2016 in recognition of his immense contribution to the nuclear power program of India. He was also conferred with the National Geoscience Award 2019 by the Ministry of Mines, Government of India, for his significant contributions to the discovery and development of Rohil uranium deposit in Rajasthan. Shri Pandey visited Advanced Scientific Institutes in Germany in 2013 as a part of Advanced Techno-Management Program for middle-level scientists, sponsored by Department of Science and Technology, DSC. He has represented the inter-ministerial delegation of Government of India at International Mining and Resource Conference, IMARC 2024, and other related engagements at Sydney and Perth, Australia. As a nominated representative of Department of Atomic Energy and member of International Atomic Energy Agency, IAEA Uranium Group, He has attended the 60th Uranium Group meeting at IAEA in Austria in 2025. He has authored more than 50 scientific articles in renowned national and international journals. Prior to his appointment as Director AMD, he has served as Head Planning and Management Services Group AMD Regional Director AMD, Southern Region and Additional Director Operations to AMD. With this vast experience and leadership in the discovery and evaluation of strategic resources, his insights today on exploration of critical and strategic minerals in India way forward will no doubt provide us with a clear perspective on the path ahead. Sir, please.
Good morning. Since the theme of the workshop was strategy and critical minerals, I thought it prudent to align my topic to the workshop. Although this is not the primary mandate of AIM, primary being the exploration and resource application for atomic minerals, mostly uranium and thorium. But as I said in the morning, critical and strategic minerals are part and parcel of a country's future, and AMD has taken the lead in exploring these minerals also. So in the morning, there was a statement from Ceremonial sir that it's a bit confusing what are critical minerals, what are strategic minerals, what are atomic minerals. So this is my understanding of what these terms basically mean. I mean, there are a lot of definitions going around in the internet, in the Ministry of Mines document, and of course, the other countries' documents which define the critical minerals. So what I understand is critical minerals are basically the economic drivers for a country. What you call they are really essential for the economic development of a country. And as of now, there are no substitutes for critical minerals. For example, if you take the example of lithium-ion battery. We are talking about aluminum-ion battery, sodium-ion battery. But so far, there is no commercialization of these products. As of now, it is still the lithium-ion battery which holds the fort as far as the industry goes. So as of now, there is no substitute for lithium. Then another point is critical minerals, their existence, extraction and processing. This is limited to a very few geographical locations in the world. And because of this, there is always a risk of supply chain disruption, as I said, because of the geological scarcity and the complex processing technology that is involved in this critical minerals. And from time to time, the critical mineral list is updated. For example, if you take US, earlier the list was containing 30 minerals, now it has been updated to 50 minerals. So each country has its own set of critical minerals depending on the criticality index. And time to time, they also are dependent on the geopolitical issues that are going on in the world. So this is what we can understand by critical minerals. And if you take a few examples, if you take the example of rare earths, you'll see that the total world reserve of rare earth is just restricted to just 5 countries, more than 90%, 94% of this resource of around 110 million tons rare earth oxide equivalent is restricted to only 5 countries, that is China, Vietnam, Brazil, Russia, and India. And of this, almost 40% is confined to a single country, that is China. And if you come to the processing part of rare earths, 97% of the production is again in 5 countries. Besides China, you have US, you have Australia, you have Madagascar, and Vietnam. And 68% in a single country, China. This is how China is holding the world to a ransom. Next example, if you take of lithium, you see the global distribution of lithium. 56% in just 3 countries. ABC, the lithium triangle as we call it, Argentina, Bolivia, and Chile. And 90% world production of lithium, this is only in 3 countries, Australia, Chile, and China. So this is what I meant by very restricted geographical location. And because of the complex processing technology, again, this processing is also restricted to a very few countries. So this is what makes these rare earths and lithium critical. Now in the Indian context, there was a study by Council for Energy, Environment and Water way back in 2016, where 49 minerals and elements which were used in the Indian manufacturing industry there was a criticality index considered for these 49 minerals. And this chart, as you see, graph, you'll find that it's divided into 4 zones. So the zone 1, as you see, it has the highest economic importance and high supply risk. That is why it becomes most critical. And elements like rare earths, anthem, beryllium, niobium, zirconium, bismuth, graphite, strontium, chromium, all these are placed in zone 1. Then if you come to zone 2, it becomes slightly less in the economic potential importance, but always it is having a higher supply risk. So that is a moderately critical. Similarly, zone 4, if you see on the bottom, this zone 4 here, again, this is with the highest economic importance and low supply risk, but again, that is why it is a moderately critical. So zone 1 becomes most critical for India. And this was the basic risk matrix on which Ministry of Mines started discussing this list of critical minerals. And finally, it came out with a list of 30 critical minerals, of which 24 were included in the part D, the latest schedule that was included in this part 1 of MMDR Act 1957. So as you can see, some of these minerals or elements, they are inputs for the traditional industries, and many are part of parcel of the modern technologies, like for example, mobile phones, EV batteries, solar panels, wind turbines. And as I said, these critical minerals are now a necessity for clean energy. But of course, they were always important for national defense, space research, and atomic energy programs. And why these critical minerals are important for India? As I said, because they are the foundations of modern technology. And as we are going, we have committed to be a net zero country by 2070. So we need a lot of these critical minerals which are being used in solar panels, EV batteries, and of course wind turbines. So these become the foundations of modern technology. And as I said, they are used in the renewable energy technologies, and that is going to help us achieve the goal of 2070 of net zero. And mineral elements like lithium, graphite, cobalt, lithium, and rare earths. Every one of you knows these are the key minerals, the key elements which will drive the future economy of the country. Recently, you must have read the statement by the CEO of NITI Aayog that India has now become the 4th largest economy in the world, overtaking Japan. And very soon, we are going to overtake Germany to become the $5 trillion economy of the world. And of course, self-reliance. Our Honorable Prime Minister talks about Atmanirbharta. So to attain Atmanirbharta in these critical minerals, we need to identify and assess the sources of these critical minerals, whether in our own country or overseas acquisition. Both the routes are open to us. But as of now, India is 100% import dependent on some of these elements. So coming to the term strategic minerals. Strategic, by the very term, you will understand that these are the essential commodities which are used for national security purposes, especially in defense, space sectors, and of course nuclear energy. Export restrictions apply to these because every country wants to restrict the export of these critical or strategic minerals, and that is why they are prone to supply chain disruptions. The difference between critical minerals and strategic minerals is they are fairly available in the global market, but supply is dependent on the prevailing geopolitical scenario. See, for example, before the Ukraine war, the semiconductor industry was flourishing because a lot of the elements, the minerals that were required for the semiconductor industry were coming from Ukraine. But after the war with Russia, suddenly there was a crack in the market, and the supply of these critical minerals stopped for all over the country, all over the world. So again, this is how the geopolitical scenario determines the availability of these minerals in the global market. And of course, there are key components in the formulation of foreign policy. Again, I quote the example of the Ukraine war. See how the various European countries are now rethinking their foreign policies. And of course, the prime example is, of course, the supply of uranium to Tarapur reactors of India. Way back in 1963, many of you must be aware that the US established 2 boiling water reactors at Tarapur on a turnkey basis, and it ensured the uninterrupted supply for these 2 boiling water reactors for a period of 30 years up to 93, the supply of low enriched uranium. But when Buddha's mined for the first time in Pokhran in 1974, peaceful nuclear explosion by India, the US suddenly they stopped the supply of this uranium to India. At that time, India turned to France and even to China and Russia to compensate for the loss from US. And again, subsequently, as you all know, India signed 123 agreement with US, which had earlier stopped the supply of uranium to India. And that is how India could get unhindered supply and can now import uranium from the world market. Being not a part of nuclear suppliers group, or India has signed the NPT, but still India is getting imported uranium. So this is how the foreign policy is governed by strategic minerals. And all strategic minerals are unity critical because, as I said, they are the economic drivers, they are strategic to a nation, but all critical minerals are not strategic. This is what you have the global distribution of uranium. Again, if you see, 95% of identified recoverable uranium resources are confined to just 15 countries. So this is how that export restriction, what I called about the supply chain disruption, again reflects this kind of situation in the world. And rest 5% is distributed in 24 countries. So you can imagine how restricted that supply becomes when a major part of the resource is held by a few countries. Coming to the value chain of critical minerals, you can have a three-step value chain. First, upstream will be the exploration and mining. The midstream becomes the processing, refining, and the metallurgy, the extraction and the beneficiation part. And downstream comes the component manufacturing and clean technology production, and including the material recovery and recycling of the products. So in the Indian context, if you see, we are fairly functional in the upstream segment, where survey and exploration come in, because we have enough resources of rare earths and some other critical minerals, and we have the capability to explore and exploit these resources. However, when it comes to the midstream and the downstream segments, that is where we need efforts to boost the midstream, and of course, this downstream segment where the manufacturing of finished products comes, and the recycling part comes, that really needs strengthening. Because as of now, if you take the example of rare earths, our country has enough resources of rare earths. But the problem lies in the midstream and the downstream segment. If we start exploiting those rare earths, producing new mines with the present existing resource, the problem is who will take that product. There is no downstream industry who will manufacture large-scale rare earth magnets. So once the industry doesn't exist in the country, who is going to take that rare earth which we are going to mine? That is where the problem lies. Next, atomic minerals. As I said earlier in the morning, initially the atomic minerals list, which was defined under Part B of First Schedule of MMDR Act 1957, it had 12 items. Now, because of the reasons I quoted in the morning, the first 6 they have been removed from this list, and they are now part of the critical and strategic minerals schedule, that is Part B, which was later inserted into the MMDR Act 1957. And the present list of atomic minerals, if you see, it goes from 7 to 12. So beryl, lithium, niobium, titanium, tantalum, and zirconium, these have been removed from the list of atomic minerals. As I was referring in the morning, these may be critical for the countries of the world in the last, say, 2 decades. But for the atomic energy program of the country, these minerals were always critical. And for 7 decades, AMD and DA have been exploring and augmenting these so-called atomic or critical minerals. This is the present list of critical and strategic minerals. The Ministry of Mines list does not differentiate between critical and strategic minerals. So these 24 minerals are now kept in the list of strategic and critical minerals. The blue one, if you see, those are the highlighted ones, which were earlier part of atomic minerals. So here, one thing I would like to bring to the notice of the audience, that this list, if you see, it does not contain uranium nor thorium. So is it a fact that uranium and thorium are not critical for our country? Or is it a fact that uranium and thorium are not strategic for our country? Both are critical as well as strategic, but they don't find a mention in this list, merely because this particular list of minerals is open for mineral concessions or mining to private agencies. Whereas, as of now, the nuclear industry is again not privatized. So if you keep those uranium and thorium in this list, it will be open to the private sector. That is the only reason why uranium and thorium don't figure in the list of critical and strategic of India. Now coming to the nuclear power program of India. Most of my colleagues here are well aware of this three-stage nuclear power program. The visionary thinking of Dr. Bhabha at that time, way back in late 1950s, he had that the vision he had at the time, there were very limited identified resources of uranium, but the well-known thorium resources of the country, they were always known to the world as well as India. So he, at that time, he formulated a three-stage program where in the first stage, he said we'll use the natural uranium which is available in the country, and using heavy water, we'll produce electricity. As a waste, plutonium will be generated. This plutonium can be fed to the reactors of the third stage, which will be called fast breeders. And when the plutonium burns in those reactors, the core of the fuel will be surrounded by thorium. Thorium will be transmuted to uranium-233, which is again fissile. And once enough inventory of uranium-233 is built up, we can use that in the third stage. And once we enter into the third stage, that means you are burning thorium. You will not require uranium anymore. The reactors will run on thorium. That is how we had formulated this vision. And at present, we are what we call self-sufficient in stage one. Today, we have mastered the entire fuel cycle of stage one. We can build, we can operate, we can maintain our own reactors today. And second stage, we have just entered, you must have read some time back, that the first fast breeder reactor in the country at Kalpakam is very soon going to be commercialized. And once we enter into the stage two, we will start breeding the fuel. That is why it is called a breeder. It generates more fuel than it takes. That is why it's called a breeder reactor. So now, as of today, if I just give you an example, the nuclear energy mission of India, which was announced in the last budget by the finance minister, it says we have to produce 100 gigawatt by 2047. Today we are producing around 8.8 gigawatt. So if I give you an idea of the resource, what we have with us today, uranium resource, if tomorrow the country has this capacity of building 100 gigawatt, we have enough resources to last for at least 8 to 10 years to run those 100 gigawatt reactors. But mind you, there is a catch. We are presuming that the 100 gigawatt will run in the first stage reactors, and that is not a fact. Till 47, we are going to have stage 2 reactors, as you know, the nuclear energy mission where SMRs are also going to be built. So definitely we will be entering into the stage 2. And once stage 2 starts, as I said, we have breeder reactor, the quantity of uranium required will go down. So that is how we are going to gradually master the second stage. And sometime in the future, probably 30, 40 years from now, once we enter into the third stage, our uranium will not be a critical mineral for us, for the country. That is why I say we have already achieved Atmanirbharta to some extent in these strategic minerals. We are talking about energy transition. So why nuclear power is important? Of course, many times studies have been done. We realize that to achieve this net zero by 2070, we need an optimal mix of renewables and nuclear energy. Renewables may work to an extent, but there are some hard facts that one should realize. If you have to have a base load power, if you have to run industries, then you need nuclear power. And moreover, as you see, nuclear energy has the lowest average life cycle carbon dioxide emissions among the energy technologies. And nuclear power plants have the lowest land requirements and lowest structural material requirements of all low carbon energy sources. If you compare solar, wind, the amount of space you need for the solar panels, the wind turbines, if you compare that with what nuclear power plant needs, the space required is very low. And nuclear power plants are the most reliable source of electricity. They can run 24/7. and they run at a maximum capacity of almost 93% during the year. And they are more reliable in extreme weather events. And of course, uranium is easier to stockpile than natural gas. And nuclear power plants maintain the highest standards of safety, security, and emergency preparedness. There are many redundancies which are there in the nuclear power plants. If one fails, the other comes up, the second fails, the third comes up. So the entire safety mechanism is built in such a way that there is least chance of a failure. And of course, the rate of growth of nuclear energy depends on a number of factors. The speed of innovation in new nuclear technology, that is how I said to you, why we have not still mastered the second stage because of the complex technology. In fact, only China and Russia and India are pursuing their fast breeder program in the world today. And of course, we have certain policies to consider, the waste management, and of course, the market design and financing structure, because you need a lot of investment in the nuclear power sector. You are going to achieve that by say 2070 or 2047 or whatever. And that is why now the government is thinking of privatizing the nuclear industry. Here comes the role of AMD. As I said, the primary mandate is exploration for atomic minerals. And we also carry out pre-feasibility studies, including exploratory mining and mineral beneficiation for atomic minerals. AMD is responsible for approval of mining plans for atomic minerals. And we also take up geological and seismotectonic investigations when the site selection of new nuclear power plants comes up. And besides headquarters at Hyderabad, we have 7 regions, including 3 sectional offices. This is the atomic mineral map of India. During the last 5 years, our leaders and their legacy continues. We have established almost 47 uranium deposits in the country, totaling almost 430,000 tons of uranium. 136 economic heavy mineral deposits, that is these sand mineral deposits, containing almost 1,300 million tons of these sand mineral resources, which include 13 million tons of monazite, which is again the primary resource of light rare earths and thorium in the country today. 7 million tons of light rare earths are locked up in these monazite resources. And we say we don't have rare earth resources. So I think it is a misnomer if we say our country is deficient in rare earths. The problem is if we exploit that, who is going to use it? And of course, it contains about 1.15 million tons of thorium. Once we enter into the third stage, we don't require it anymore. In India's first lithium deposit has been established in Monolith, it's a pegmatite hosted spodumene bearing pegmatite. India's largest hard rock carbonate hosted RE deposit containing more than 1.1 million ton rare earth equivalent established in Inaugural, Gujarat. Gujarat Mineral Development Corporation has already taken up that deposit for mining. And 2 alkali, granite, and rhyolite hosted HRE, heavy rare earth enriched deposits, almost 1.1 lakh ton REO. They've been established in Bhatikada and Dantala and Ceremonial complex, Rajasthan. And there are many good prospects that are coming up. And this figure is likely to go up to 5 lakh or even 10 lakh tons. And prospecting activities we are already carrying out for stockpiling of rare metals, as I said in the very beginning, so-called critical minerals of today. But for us, they were always critical since very beginning. Now, since we are talking about critical elements, let me give you an idea. Earlier, we were mining uranium. And of course, when the copper mines were running in Singhum Shear Zone at Surda and Musabini, we were recovering uranium from their tailings. Now there is a policy which is being formulated by Ministry of Mines, where we are looking for extraction of critical elements from the major ores. So again, as I said, the importance of these critical minerals has been realized by the world only in the last year or so, 2 decades. But DAEMD they had recognized their importance to their program long back. And we have an idea of the tonnage, what lies associated with the major uranium deposits. But the thing was, because no one was interested in taking these elements, we were not exploiting them. If you see the deposit in the Kadapa Basin, the southern and the northern Kadapa Basin, what Saravanan sir was referring to earlier, Besides uranium, we have critical minerals like molybdenum and vanadium associated with it. In North Delhi Fold Belt, Rajasthan deposits, we have molybdenum, vanadium, and RE. In Sengun Copper Belt, we have chromium, molybdenum, nickel, and rare earths. In Bhima Basin, we have vanadium. In Meghalaya, we have selenium, vanadium, and molybdenum. Now, once the policy is finalized by the Ministry of Mines, probably there will be some amendments in the MMDR Act, whereby whenever a miner is mining a major deposit, he will have to extract these associated elements also. And of course, the recovery from tailings is another part. And this I have already explained, the monazite and the RE resources. Okay, my last two slides. What are the government initiatives towards these critical minerals, the national critical mineral mission that the government has announced? See, now for that mission, the government has provided almost 34,000 crores over a period of 2031. So it's almost 5-year period from now. Again, the objective is to secure India's critical mineral supply chain, that is to restrict the supply chain disruption, both by ensuring availability from the domestic sources as well as acquisition of mines in the foreign countries, and strengthening the value chains. I have shown you the value chain, whereby you need to develop exploration, mining, beneficiation, processing, and recycling, especially the midstream and the downstream segments. And in that effort, recently the MMDR Act has been amended, whereby this exploration license has been included for undertaking reconnaissance operations, prospecting operations, for both in respect of 29 critical and deep-secret minerals, which include 26 critical minerals, which is specified in the 7th schedule of the MMDR Act 1957. So this is how the government is now opening up this sector to private participation, thinking in the long term that definitely it will be beneficial to the mineral industry. And if you see the critical components of the National Critical Mineral Mission, as I said, increase domestic critical minerals production, acquire mines abroad, recycle critical minerals, open up trades and markets, and then R&D into critical areas like beneficiation and processing of these critical minerals. Human resource development, because as you all are aware that in our country, mineral industry as such, it is not governed by, say, geologists or miners. So you have to have human resource development, where you have good amount of geologists and earth scientists working in this kind of sectors, and good mining companies coming into this projects. So these are some of the key points of the National Critical Mineral Mission. And the way forward, as I said, exploration. We need extensive exploration in geological critical domains by both the public sectors and the notified private exploration agencies. The government support is coming up. We have established the National Mineral Exploration Trust, which is now awarding the projects to many NPEs. And of course, as I explained, through the provision of exploration license. And now analysis of trace elements has been or will be made mandatory very soon by policy of Ministry of Mines, whereby even in exploration stage and compulsorily in the mining stage, the agencies will have to determine all the elements which are associated with the major minerals. Then acquisition of overseas critical mineral assets, I pointed out. Here, KABEL is a consortium of MECL, NALCO, and HCL, which is already into acquiring these assets. In Catamarca province in Argentina, they have already acquired some lithium blocks. Then coming to the exploitation part, as I said, mining is critical in establishing the resources of these critical minerals. EMDC I already talked about. And in the National Critical Mineral Mission, 100 blocks of critical minerals are to be auctioned by 2031. And the most important part, as I said, the development of flow sheet for recovery of associated critical elements from major mineral ore deposits. That is the need of the hour. What I find that many of our scientific laboratories, scientific labs, be it CSIR, be it defense, or even atomic energy or space, we are working in silos. There is no, a central repository like GSI has created the NGDR, where now everybody is pulling in their resources, pulling in their data, and it is open to all the stakeholders. A similar kind of setup should be there, I think there is provision in the National Critical Mineral of Mission of establishing these centers of excellence. Probably that will take care of this anomaly right now. And then I've talked about recovery from tailings, overburden, and fly ash. Manufacturing and recycling sectors I already talked about. We need to boost up this kind of sectors. The conversion of laboratory scale from private scale to industrial scale that is lacking in our country as of today. We need more startups to come up, take this technology forward. Then separation and individual bearers, which IRA does from monazite sands, but from hard rock, still that technology is not with us. We need that, especially for HREs for producing these rare earth permanent magnets. And production of pure metals like niobium, molybdenum, vanadium, rhenium, because many of these metals, India is totally dependent on their imports. Similarly, recycling. E-waste is a very fast growing industry in India, but we have to now establish the recycling technologies to recycle the waste, the electronic waste for recovery of critical elements like rare earth and lithium. And there are some incentive schemes in the National Critical Mission. And we hope that this kind of policy of the government will bear fruit in very near future. And of course, significant policy reforms, including amendments to Act and which I already talked about, both for onshore and offshore exploration, mining are in the offering. And all this is needed to make India self-reliant in the sectors of strategic and critical minerals. And some of these initiatives have now been taken by the Ministry of Mines. And now it is up to us, all of us, to really dedicate ourselves to make India Atmanirbhar in these critical and strategic minerals. Thank you.
I request a regional outreach, sir.
Sir, myself is Harish from DMD Karnataka. So I just want to know whether EMD will still continue with their exploration programs and other activities with the commodities which have been delisted from Part B.
Yes, of course, I said because the country needs to pool resources. And I said maybe these critical minerals, so-called critical minerals have been removed from the list of atomic minerals. But since over the years, last 7 decades, we have built up a certain kind of expertise. We do not want to leave these because again, these are critical components for atomic energy as well. So in fact, I should say that we have increased the inputs of critical and strategic minerals. And with the resources that we have, we are exploring both the rare earths and especially the rare earths and the lithium and rare metals like uranium, tantalum, beryllium, zirconium. Of course, we have not stepped down and we are not going to step down.
Sir, a small query I have, sir. Sir, like these 6 minerals were always important for us. These were the atomic minerals. Now, these will be mined and taken care by the other agency. So if our department, like nuclear industry, needs these minerals, is there any provision that some, specific privilege will be given to us by supplying these?
No, as of now, there is no provision like that. But of course, there are certain provisions under the MMDR Act whereby some of these mineral commodities can be reserved for government agencies. So that is not an issue at present.
I am Rajesh Turai, BSc Development. Actually, your presentation is very nice, sir. Actually, this AMD is mainly looking for the uranium and thorium. And go for the some other associated elements like the critical vanadium, nickel. These are the analysis also to be carried out. It will be very useful for other departments.
Sir, just like to inform you that we have already implemented just 2 days back. We had a meeting with Ministry of Mines. Then Secretary Mines was also discussing the formulation of policy for this extraction of critical minerals and all that. So I had also informed them that AMDL already implemented this kind of policy, where during our exploration stages, we are analyzing all the associated elements which are listed in MCR. And that MCDR list that associated elements is there. Wherever we are carrying out exploration for uranium, the entire list of associated elements is being now analyzed. And moreover, now we have handed over some geological reports to the state government, for example, for Malapalli Deeper project, and of course this Ceremonial project. So there we have already calculated the tonnages of these particular elements which are associated with uranium. So now, whenever this policy comes into force, the state government will likely ask the mining agency to include those associated elements in their mining plans. That is what is coming into effect. Very soon, I think that will be provision made in the Act amendment. Next amendment.
Another thing is extracting this critical and strategic mineral. The hard rock unit is very, the technology is not at
Definitely, yes. That is why I said,
issues in it.
yeah. That is why I said the midstream needs boosting up.
This we need.
Yeah.
But then we need people for the technology to extract
Definitely. I agree with you 100%.
Because we have the places and annual, there's no issue. You can take the material and we can extract. But the hard rock is extracting the critical is very tough job.
Yeah. Because as I showed you, the China controls almost 80%, 90% of processing of rare earths. I think recently Magnus has become the only company which has gone outside China and established a business industry in Malaysia or something.
I think this is the people in the NCM.
Yeah, I think we are going to establish this centers of excellence. Probably that is going to help us in this particular advance.
Thank you. Thank you.
Request for the director to present the commenter and give appreciation and gratitude. Thank you very much, sir. As always, your lecture was very interesting and it was spoken in very simple words so that all of us understand what you really, whatever messages you wanted to put forth. And you have elaborately defined the critical strategic and atomic minerals and how the foreign policy and the geopolitical issues also define them. And how we are experts in exploration and augmentation, but we lag behind as far as the midstream and the downstream are concerned regarding processing, extraction, manufacturing, and recycling. And we all now know that's how important, strategically important these critical minerals are also. And for all the questions which other audience have asked, all the laboratories, chemistry laboratories have also geared up of AMD for all these to help the exploration geologists with the data they want with respect to the critical and strategic minerals. And we are also undergoing lots of R&D projects with respect to the extraction and the processing of these minerals in a smaller scale. But if anything succeeds, then we'll go to the pilot scale. And that we are making all out efforts for adding resources with respect to critical and strategic minerals. And of course, he also has emphasized upon the 3-stage nuclear power program, which we are aware of. But beautifully, sir, you said that how we become Atmanirbhar, because uranium is the problem. We know that we do not have that rich grade uranium in our country, and that uranium is the problem. And once we expertise in the second and subsequently the third stage, then we do not need uranium anymore to that extent. And that is how we are becoming Atmanirbhar with respect to nuclear power also. And you beautifully mentioned what is the importance, the significance of nuclear power in this entire energy scenario. Thank you so much, sir, for this interesting talk. And now we would go to the next talk, which is by Dr. Krishnamurthy. This is an online presentation, which will take some time. still there with us?
Good noon, and almost it is starting the good afternoon part. Thank you very much. It's just like homecoming for me to come to any function in the Atomic Minerals Directorate. And I think I have seen virtually and even in the virtual mode all my friends, old and new. The new particularly, I must compliment them because I heard many of them during the Singhbum Uranium Province Diamond Jubilee function in the last month. I think it was in the beginning. They all presented excellent presentations on Singhbum by the younger ones. I think all the new millennia group. So again, I would like to again thank my very, very good old friends, and particularly, of course, now Dheeraj Pandey, our present director, has made my job easier, and I will just go through the slides one by one. And I was to say, pass, next. I am not seeing that anyway coming in my screen. We can go to the next one. Next. It's my slide is not moving. I am not a, because the view I am seeing is stuck with my title. Yeah. Now this is my, I don't know what is happening in the screen. Some unverified people are there. Prakash BG. So I would like to dedicate my lecture today to Dr. Gajanan Rajaram Udas G.R. Udas, who has been an outstanding director for our division. And the critical aspect came in, 1974, after the first Pokhran implosion. Dheeraj was telling about the Pokhran, the Tarapur uranium supply being stopped. In fact, other critical thing was we were not having any niobium, and we got 2 tons of niobium from Brazil. And the Atomic Energy Commission asked Dr. Udas, don't we have niobium in this country? Then Dr. Udas, in his old boldness, he said, who said? But give me men, I will give you niobium and tantalum. Then only the special niobium tantalum cell formed with some 15 new recruits, class 1 gazetted at that time. And that is how the criticality of a particular mineral not available can be completely solved. And that is how he managed it. And then that is how he also, having known the Singhbum for 25 years, he said, we can always come back to Singhbum. Let us find out new territory. And that is how in 1974 we had the paradigm shift, locating all the other major uranium, at least indications, Shillong, southern region, the conglomerates, first QPC, and then the Tumalpalli in 1986, and in the Sivaliks. So like that, he only kind of shifted in the sense we have, and we have to be more dynamic in getting it. So that is how he had led us. Next one, please. This is, of course, one of the training programs on rare metals and rare earths, which we had the Geological Society of India and the AMD, because AMD, as some gentleman was asking and Dheeraj was replying, AMD has all these specialties, expertise in these rare metal and rare earths. In fact, we had inherited from GSI the entire unit led by Dr. Khetkar to start the uranium. But then we have developed it almost for the last 75 years, this particular kind of expertise. And it was not available when the government opened it up for all the people. There is no expertise available outside. That's why the Geological Society of India and AMD joined together and started this training program. And we had program in 2015 on hard rocks. From Bengaluru, we went to the carbonatate localities of Tamil Nadu and the rare metal lithium belt at the Marlagalla and Pakkanadu also. So this is how AMD, in liaison with the society, started the training. And Subsequently, we had one at Beach Sands in 2016, and again in 2018 in Jodhpur to cover the carbonatites of Barmer and the Sivana Ring Complex. That's how the AMD's expertise is being slowly passed on to the universities, research students, professors, so that they can teach better this topic and this technical aspect of it. So this was the beginning, and this was particularly so because Philip Hellman from Australia had come, who had been working with the Barmer carbonatites. And he is a Mount Weld specialist. So he gave an excellent lecture. And he gave, in fact, on, churchite. Churchite is nothing but yttrium NH2O. And I remember our then director at that time, Parihar was telling, Saab, in lecture ko to hum logon ko sunna tha. Our boy should have heard this because churchite was never heard and we were not searching. And it is a very, very, very secondary mineral available in the regolithic and other zones. So this is how the training helped a lot of people outside AMD. Next one, please. And this is, of course, this part I need not mention much because Dheeraj had already touched it in a big way. And only to add that, you see, we have, of course, with US-led Mineral Security Partnership, and in 2022, we had the Indo-Australian Joint Critical Mineral Partnership, because, the Chinese were kind of twisting arms on supply of rare earths and other minerals. And competing with Chinese, the mine potential was available in Australia. And that is how this Indo-Australian has come. And I think I'm sure this is going in a big way. Next one, please. This is, of course, again, the objectives. I would only concentrate on why carbonatites? Because our present rare earths are exclusively from the monazites, beach sand monazites with thorium. And thorium is a real challenge to store and keep it stockpiling, because our second stage is only taken up just now, the fast breeder program. So the thorium storage is a challenge. Apart from that, separating rare earths is certainly a big challenge, making it up to the elemental stage, oxides at elemental stage. But the advantage with carbonatite is the monazites and carbonatites are the least thorium bearing among all the monazites available. So the rare earths even, and then monazite is not a mineral which is sought in carbonatites. Carbonatites, pure rare earths like bastnasite, zincite, parisite, pure lanthanum, cerium carbonates are sought. And so if we develop the carbonatite base for rare earths, we have lesser problem with thorium and other radioactive material. Next one, please. This is, of course, the list. And the list, as Dheeraj said, the strategic and critical kind of definitions can vary from country to country depending upon their availability with them and processing technology, all kinds of things. So next one, please. So this is only to show you, the dominance of certain countries in certain elements. You see, like China, particularly rare earths, Australia in lithium and Chile, Brazil in niobium, and South Africa and platinum, and Russia and palladium. These are the most dominant. Brazil produces 80% of the world's niobium. So definitely for certain elements we need to depend upon. And it's again joint action through countries, bilateral collaboration and things like that. Next one, please. This is how it was started early in the new millennia, finding out the, again, supply risk and economic importance. And then, of course, you can see the top of the list is the heavy rare earth elements. And of course, the light, and almost all the elements come in different way, depending upon the availability and the processing capability. Next one, please. This is, of course, again, it was mentioned, it started, the study by our own Indian in this group in 2016. And this is how they have identified the Z1 and Z2 category. And the Z1, you can see the lithium, lanthanum to all the entire rare earths are in the Z1 category. And of course, the yttrium including lithium, beryllium, niobium. Again, lithium is in Z2, but this criticality can vary depending upon this. And this is how we started to really have a grip on the critical and strategic elements. Next one, please. This is then, of course, this is how the government of India, the Ministry of Mines formed, and they identified how much 100% import dependent, 50% import dependent, and things like that. Next one, please. This only gives the list available in the public domain. Next one. Next one. Yeah, this is again to show you how important the rare earths in different mineral industries, in industries, in magnets, in metal alloys, in phosphors, catalysts, and other these things. Why I'm showing this is because the rare earths still are important, and the source, the carbonatites, are good sources. So we need to know where are the existing ones and where are the potential zones for carbonatites in India. And this is the main part of the lecture. Next one, please. Yeah, this is again to show you the different carbonatite places. And they are all over there. And definitely the carbonatite which is dominating in rare earth supply is the Bayan-Obo, the Chinese. And this exercise of mine, this today is also, can we find Bayan-Obo type in India? If there are possibilities, where we have to go. I'll come to that as we go on. Next one, please. Yeah, this is of course the grade part that is available in rare earths from different parts, different sources. You can see the the Bayan-Obo having the highest 17 to 18%. I think that's 20 in the scale. I would say, okay, then the Mountain Pass in California. The Americans had, in fact, the best of the rare earth ores in the world to start with. But the Americans are completely business minded. They said, if somebody else can give, and then the environmental aspects came in and they had to close down Mountain Pass. And in that case, the Bayan-Obo took the lead, and that is how they controlled. And now, of course, after the supply risk, all the Western world have realized that they have to develop new sources. And that is how we will see in the next slide. Next slide, please. See the new places. These are all the ashram in Canada has been found a new one. Bayan-Obo. You see, it is larger than Bayan-Obo. If you put good inputs, you can do. Then this is again in South Africa. Then the Mountain Pass. In India, we do have the Ambadongar and Kamtai coming in that list of good deposits. And in the secondary carbonate, the regolith sources, we have the Tanzania having a great, and Mount Weld in Australia, and Araxá in Brazil. So these are the real top ones, and we need to develop our own good ones and find out something even new or even better. Next one, please. This is, of course, the carbonatite belts of India. The most important ones, of course, which are mineable is, of course, Ambadongar, the first discovery in 1963 by Sukeshwala and Udas. And in fact, I was also seeking those type of carbonatite deposits in the Narmada Valley way back in the 1960s at the University of Sagar. So this is the other one. This is, of course, the Savadu belt. But the important part which we are going to talk today is only Ambadongar and the Barmer in Rajasthan. And where are the other possibilities also we will look into. Next one, please. This is, of course, the geological map of Ambadongar, the PhD thesis of Dr. G.R. Udas, and subsequently by Vilatkar in a big way. Next one, please. This is the kind of a model. How did the magma came from the upper mantle sources, and then how the immiscibility came, and how the rare earths got enriched and all. And this is where the AMD and the GSI. I think it's essentially an AMD drilling part in the southwestern part of the ring complex. This is a ring of about 3 to 4 kilometer dia, and we have only explored a small part, and we'll see how much resources we have. The next one, please. See, the USGS way back in 1998, they have estimated, geological estimate of 105 million tons of ore with 3% REO and 11.6 million tons of fluoride. So this was actually prognostically, they have indicated that this could be a very potential rare earth deposit. Then, of course, the GMDC was working for the fluoride, but somehow even the fluoride with market and other things, they could not process, and they stopped the process by about 2000 or so. Then this is how the inferred rare earth sources by AMD and other people this is the quantity, 140,000 tons. 140,000 tons contain 12% of ore, having been estimated in average grade of 1.16 REO. This is again the AMD group. Subsequently, detailed drilling by AMD up to 500 met depth has proved this much of ore. And this GSI AMD report is the real point. The entire Indian scenario has been explained. Next one, please. Yeah, you see, this is of course the north of Ambadongar. Anyway, the important point is Ambadongar is a major source, and the Gujarat Mineral Development Corporation is in the active mode. In fact, our previous director, Dr. Sinha, I think he is looking after the exploration as well as establishing the mine and other part of it. So the other contiguous area, Ambadongar is a potential proved, but the area to the north of Ambadongar is equally potential, or it probably contains much more than what you have at Ambadongar, because Ambadongar is considered to be a central volcano, or we are seeing the diatreme part of it. But Professor Walker had come. He's a volcanology specialist, world renowned. He had come in 1969 to Sagar, and he was taken around to see the research areas of students. One Dr. Nageshwar Rao was working in this part. I was working further west at Rajpipla. When Professor Walker saw Ambadongar, he said, this is a smaller center. Where is the larger center? And then he said, this part is something like a larger caldera or center, and these all soil covered. So this is how he suggested that this could be a more stronger potential area than Ambadongar. So this need to be looked into. There are available reports, geophysics and other things that need to be taken forward. Next one, please. This is, of course, the Kamtai one, essentially done by the MSPL, Mineral Supplies Limited, Postpet, with their subsidiary Ramgarh Minerals, with Bhushan from GSI. He was the Sivana specialist, and this is part of the late Proterozoic or Neo-Proterozoic activity. A lot of alkaline rocks, of course, Sivana ring, but this is a small carbonatate complex, and which has been really proved, and that is under the consultancy of that Philip Hellman. Next one, please. I'm just probably overshooting my time. So this is again Kamtai. Kamtai is also equally kind of having good resources with higher grades. That is important. You can see estimated individual rare earths computed, but the combined rare earths, it's about 4.9 million tons with good grade. And this is how the higher grade makes it to be a world-class deposit. Next one. I'll quickly go through. These are all the other minor ones where there are some rare earths available, yttrium from the phosphatic rocks at Samchampi, and the Sung Valley, some soils containing rare earth minerals identified Sadiq and his group from GSI. Next one, please. This is, of course, the GSI AMD's kind of activity where all it could be found, and they have identified state-wise the area that could be important. I mean, the larger part, the potential areas in each state where rare earths could be sought. Next one, please. This is, of course, the Tamil Nadu area. Why I am showing this is because we need to identify new potential areas, and this belt is very important because it is very well known. It is known. It is the 1966 discovery at Cervatur or Koratti and the Elamari ring cyanide, and this belt from almost from Salem to Vellore is that Rasimalai where our friend Sarvan was telling, it's somewhere around here. This is Rasimalai, in fact, the Rasimalai cyanides. So this belt is a very potential belt for both carbonatites and cyanide related rare earths. Next one, please. And this is, of course, more in detail, the geological map. And the important part is this pinkish zone, which is all periphery, that is called as epidote hornblende rock. And this is also a phenite zone if we consider this as carbonatite cyanide belt. So this phenite zone needs to be looked more critically for kind of elements which I will show you in the next one. Next one, please. Yeah, this is of course the new find of the in Karnataka, the that belt, I forget the name. This is Gundulpet. See, this Gundulpet is on the almost on the border, on the the Moyar Bhavani shear zone and the Tamil Nadu granulite belt and the Cretan. This is the Cretan mobile belt boundary, this zone, and this zone is important in terms of the possibilities in looking at it. Next one, please. Now, this is, of course, you can skip it. This is only to show how the regolith gets formed, or right, how the carbonatites come from the mantle to the crust and then get weathered, and then they have different zones of mineralizations to look at. Next one, please. See, this is, I was telling, this is how it has been identified: Cretan mobile belt, Cretan mobile belt, and Cretan mobile belt. And this is earlier identified as the Fermer line, what he calls as the Charnockite, non-Charnockite boundary. And this boundary, later by geophysics and other activities, has been shown to be a zone of subduction. Subduction in the sense, this part has been overthrust. That is why you get the higher exhumed granulites. And this is the greenstone granite belt. The importance of this is we will see in the next slide. Next one, please. This is, of course, the well-known plate tectonics model, that where all alkaline and carbonatite rocks can come up. They can come up in the subduction zone part, in the overthrust regions. They can come in the rift like carbonatites. They can come in more cratonic interiors also. So this is only well known. Only has to go with other geophysical domains or knowledge. Next one, please. This is, of course, how the rare earth minerals get formed within the carbonatite, which we need not discuss now for want of time. Next one, please. So this is important because this is where the Bayan Obo comes in, and you see this subduction zone. And this is the Bayan Obo and other complexes. Our point is Bayan Obo type. Can we get? Bayan Obo is essentially an iron ore deposit, like banded iron formations or sedimentary banded formations, something like that, of Proterozoic age. Our point is, can we have any places where we can look this type of deposit? Is there any possibility? So that is how, go to the next slide. So this is again, I will come to that. I'll come to that part. That is how I was telling you the earlier, the zones, different zones, the importance of the phenite zones in the Tamil Nadu province. See, this is how a carbonatite alkaline rock complex phenite is kind of visualized. It has been kind of theoretically modeled based on the available complexes from all over the world. So this is the core part which the indicated minerals. And this is of course the phenite zone. And the phenite zone has things, and much of it is all soil covered. You see, it depends upon the area. So you need to look with this kind of model where to look for what type of, you see the rare earths come here, rare earths also come into the outside part. This is of course the disseminated pyrochlore. So these kind of things have to be looked into critically in any area, depending upon the geological map made and the phenite zone seen. Next one, please. So this is why because I don't know, I started at noon and almost kind of exceeding the time. Essentially, this is only to substantiate substantial reserves of strategic and critical minerals, especially rare earths, fluorine, niobium, barium, strontium, fluorine are available in the Indian carbonated and associated cyanides and phenites, that is hard rock and minor regoliths as at Ambadongar and Kamtai. Potential areas for provinces, additional sources of these SCMs exist in India, that is Gundulpet, of course, which is coming up now, and I think the GSA gentleman is going to speak on that. The other potential is the Elagiri, Sevattur, Samalpatti, Pakkanadu belt. Then the Sung Valley, Meghalaya. In fact, I didn't have much time because both these Barmer and the Sung Valley part has been extensively kind of, researched so as to postulate what kind of deposits by Arhana and his group. I think these publications I have not put, but then it would be in my probably in the lecture, in the write-up. But then this is how greenfield areas contiguous to known belts need to be critically seen. And the Indo-US and Indo-Australian efforts is likely to be strengthening our quest for strategic and minerals, critical minerals. That's all, gentlemen. Thank you very much. I thank, Sibu Varghese for requesting me to get into this act. I am thankful to him as well as all the colleagues of my AMD former friends who had helped me to gather this kind of knowledge. Thank you very much.
Krishnamurthy sir, it was a very elaborate talk, and we really enjoyed.
Sir, we shall be starting the session again. Elaborating upon systematic work undertaken by AMU over the decades, focusing on exploring and evaluating RE resources, especially in hard rock terrains, I invite one of our stalwarts in this field, Shri K.L. Mundra, Additional Director R&D AMD, for a lecture on exploration of rare earth elements in hard rock terrains of India. He will be connecting with us online. Prior to his lecture, I have the honor and privilege to read out his biodata in brief. Shri K.L. Mundra joined the Atomic Minerals Directorate for Exploration and Research AMD on 24th of October 1988 and completed 36 years of dedicated service. Over the course of his remarkable career, he has been primarily involved in the exploration of atomic minerals in general, with particular emphasis on critical elements including lithium, rare metals, and rare earth elements, contributing significantly to the development of these critical resources across diverse geological domains of the country. One of his most noteworthy achievements includes developing India's first and largest hard rock hosted RE deposit at Ambadongar, Gujarat. This vital deposit, now handed over to GMDC Limited, is set to play a crucial role in meeting India's future RE demands. Shri Mundra's pioneering efforts as team leader have also led to the establishment of India's first pegmatite-hosted lithium deposit in Mandagalla area, Mandya district, Karnataka, marking a significant breakthrough in the country's quest for indigenous sources of this essential mineral. Exploration efforts for RE have been intensified by him in Shivana Ring Complex of Rajasthan and Pakkanadu Alkaline Complex in Tamil Nadu. His research and expertise are further exemplified by numerous publications in renowned geological journals which have significantly contributed to the advancing the knowledge and understanding of the geoscientific fraternity. In recognition of his significant contributions, he has been honored with 2 prestigious DA Group Achievement Awards in 2015 and 2020. Presently, Shri Mundra serves as Additional Director Research and Development AMD. Sir, please.
Thank you, Rupa boss. May I have my presentation, please? Thank you. So a very good afternoon to all. I hope I am audible. So first of all, I thank the organizer Sri S.K. Varghese for inviting me to deliver a talk on exploration for rare earth elements in the hard rock terrains of India. So I'll be discussing mainly on the hard rock RE deposits mainly explored by AMD. Before that, on this occasion, I would like to remember Dr. G.R. Udas and Professor Sukeswala for identifying first carbonatite at Ambadongar in 1963 in India. In fact, the carbonatite was known in the world long back, but in India, it was considered to be a danger rock because one of the GSA geologists, he described this carbonatite as igneous limestone about 50 years prior to its discovery. He was suspended from his job that how the limestone can be an igneous rock. So nobody dared to call a rock carbonatite for more than 50 years. It was Dr. G.R. Udas from AMD and Professor Sukeswala who have brought to world map carbonatites in India, and later on we have got some more than 40 carbonatites presently known in India, and many are under progress. Next slide, please. Since my topic is on hard rock deposits, so we can see that global distribution, carbonatites have nearly about 55% of 54% of RE, and other hard rock like alkaline and peralkaline granitic rocks, they are having about 21 to 22%. In addition, we have got some hydrothermal type of deposits in the form of allanite, which constitute about 20%. So near about 90 to 95% of the deposits, they are available in hard rock. The important among them, as have been told by Professor Krishnamurthy also, that by and above Mount Pass, Mount Weld, they are world examples. Ambadongar is added from India in past 1 decade. Similarly, if we talk of alkaline and peralkaline granitite type of rocks, there are many such deposits which are mainly important for HRE, in which Ilimosa, Norakor, Thor Lake, and recently Sivana is added in the list of these deposits. So I'll be discussing mainly on carbonatites and peralkaline type of rocks in India. Next, please. So here again, we can see that the world reserves of RE stand at nearly 130 million tons, out of which carbonatites and placer deposits are the leading source of production, as well as we have got smaller contribution from the ion absorption clay, which are the main source of RE. If we talk of world, you can see that China, Vietnam, Brazil, Russia, and India, these are the 5 major resource. If we see the resource position, these are the 5 major countries where resources are available. And after 2011 Chinese embargo, many countries have started working, and many more deposits are now coming up. Next, please. So these are the newer prospects where current global distribution of RE projects, more than 50 projects are in the advanced stage of working. You can see that majority of them are in South Africa and China and Australian continents, and some of them are in North America as well as in South America also. Next, please. If we talk of top 30 projects in the world, majority of them are in the hard rock and mainly associated with carbonatites. We can see that black font is in all carbonatite type of deposits, and the maroon color is mainly alkaline type of rocks. The important thing here, you can see that carbonatites are mainly having bastnasites, and sometimes they are having monazite and pyrochlore as well. So you see the list, majority of the deposits I have given the total resources, grade as well as HRE percentage. Carbonatite deposits in general have LRE along with niobium, but the HRE percentage is very low. However, the alkaline rocks, they are poor in grade, but they have very high HRE, almost 30 to 50% of HRE. If you see the list, only 3 or 4 deposits are having more than 4 or 5% of RE, that is Mount Pass, Mount Weld, Tomtor, and Bayanobo. These are the 4 major deposits where grade is slightly higher. Otherwise, the grades vary from 1 to 2%, sometimes 3%. Next, please. These are some of the other deposits where also you can see that the alkaline type of rocks are having the grades of 0.7, 0.8. They are not crossing 1% because they are having heavier rare earths. Even the smaller grades are important. So many times the question is asked, what should be the cutoff grade of these carbonatites and alkaline granites? So it all depends upon the mineral value. So if the deposits are associated with alkaline type of rocks where HRE percentage is 30-40%, even the smaller grades are economical. Whereas when they are associated with carbonatites where this is only LRE, so there the grade should be at least 1% or more. Very few deposits are more than 1%, but majority of the deposits are 1%, and our Ambadungar and some of the Indian deposits falls in that category. Next, please. So this is the global tectonics versus RE. I will not describe. Dr. Krishnamurthy has already described this, that these are the various deposits where breccia, granites, carbonatites, anorganic granites, how they occur with respect to global tectonics. Next, please. These are some of the primary endogenic deposits like carbonatite associated and alkaline igneous rock associated. I have already told that some of the deposits of carbonatite, they contain grades up to 0.1 to 10%, whereas the alkaline igneous rocks, they contain low grade 0.5. Very rarely they go up to 5%. And the classical examples are Mount Pass, Bayanobo, carbonatite type, Ambadongar, and some of the other carbonatites are added into it, whereas the alkaline rocks, Ilimosa, Greenland, Kibina, Lovazro, Strange Lake, so many such deposits are there. In that category, Sivana Ring complex of India is now added. In addition, we have got iron RE deposits like IOCG, Olympic Dam is the classical example, which is a low grade, high tonnage deposit, and some of the hydrothermal deposits which mainly contain allanite and other rocks, which are also comes under the hard rock primary endogenic deposits. Next, please. So I'll be talking mainly on 3 areas, that is Ambadongar, Pakanadu, and Sivana, where AMD has done the work in past 1 decade and got a good success, for which resource position was already described by our director. Next, please. These are some of the classical models proposed, where we can see that how the carbonatite, the Sovietic magma is fractionated from iolite and artite. They have all their own finite zones, and in the last stage you can see the radially red lines in the left block. These are the encheritic portion which comes at the last stage. And the right side, it was also described by Dr. Krishnamurthy, that Bayanobo type of deposit. And to some extent, the Ambadongar also falls in this category, where we have iron as well as RE and niobium. Next, please. So some of the key points of carbonatites are, in addition to niobium and LRE, they also contain phosphorus, titanium, barium, copper, zirconium, etc. In addition, they are also enriched in magnesium, strontium, vanadium, thorium, and uranium. And some of the large deposits of niobium, RE, and phosphorus, they form due to supergene enrichment of and concentration in the residual soils. Although the host rock is carbonatite, but in course of millions of years of weathering, they get enriched, as it has happened in case of Araxa Tapera in Brazil and Mount Weld of Australia. And some of the technologies used for exploration of these types of deposits are remote sensing, airborne and ground geophysics, geological / geochemical surveys, and sampling. And the other approach is to assess the residual soils. Like in Samchampi, we have got a lot of these niobium and RE minerals associated with residual soil. If the soil is not developed, we go for subsurface exploration by drilling. Next, please. So I'll just show 1 or 2 slides on how the exploration of these hard rock deposits are done. Next, please. So the remote sensing helps us in identifying the circular features. Mostly these circular features, if they are ring complexes, they indicate carbonatites, and if they indicate the major lineaments, pegmatites and carbonatites are associated with those features like our Dharmapuri schist belt. Next, please. After this preliminary survey, we go for airborne surveys or heliborne surveys, which are very fast and economical, and they help in identifying carbonatites as well as granitic plutons by various means. Like if it is high magnetic and high radiometric, we may infer carbonatite. If we get high radiometric and low magnetic, we may infer granitic plutons. And in fact, the Mount Weld carbonatite of Australia was discovered during interpretation of regional aerogeomagnetic maps, and many such areas. This technology we will be using in many of our areas like Dharmapuri shear zone. We are planning to fly with this, so we can develop that 200 by 30 kilometer long zone in Salem district of Tamil Nadu. Next, please. The other technology used are radiometric survey. In fact, radiometric survey has been very helpful in India, where most of the carbonatite bodies have been discovered with the help of radiometric techniques, because some amount of monazite or alnite is always associated with these type of rock types, and radiometric surveys are of great help. In addition, we also go for pedogeochemical and stream sediment sampling to identify the pathfinder elements like niobium, RE, phosphorus, vanadium, fluorine, strontium, and others to identify the bodies, parent bodies. Next, please. Coming to some of the examples where AMD has worked. This is the Chota Udaipur carbonatite alkaline subprovince, where Dr. Krishnamurthy has also said that in addition to Ambadongar, we have Bakhatgarh, Saidivasan, Fenaimata, and Panwar. There are 5 complexes where we get carbonatite in association with many other associated rocks. Next, please. So Ambadongar, as has been known to everybody, it's about 2 kilometer radius where we have the Sovite as well as carbonatite breccia outer ring, in which the latter anchoritic part, which is marked in red color, which is the richest in RE concentration. The right side shows the detailed geological map where we can see that the Sovite contains the anchoritic plugs, and the central plug has been fully explored by AMD, and the southern plug is under completion. So we'll be soon completing this area. Next, please. So here with we can see that carbonatite breccia, these are some of the field photographs, how the rock types look like. We have Sovite, anchorite, breccia, and phenites. Next, please. And we can see that within a very short span of time, right from survey to exploration, in 5 to 6 years, we have established this ore body at Ambadongar, a very small area, just 600 meter by 300 meter one hillock was explored by detailed drilling at 100 by 100 meter grid. So the red part you can see is the anchoritic part, and the lower one till we drilled up to 550 meter. It's also white. Anchorite is slightly richer in RE. However, the Sovite also contains moderate amount of RE as well as niobium. So this is the area where nearly 1.1 million ton of RE in addition to niobium and other elements have been established. Next, please. And this area has been handed over to Messrs. GMDC, and they are in advanced stage of opening a RE mine in few years. These are some of the RE mineralogy photomicrographs and BSc images. We can see that the minerals are very fine grained. They are multi-mineralic, fine to ultra fine, and they are disseminated in gangue. They have got irregular shape, and they have got also very high heavy iron coating. So pre-concentration by physical beneficiation is difficult, but the ore dressing section of BRC has carried out leachability studies, and they have come up with fairly good leachability of RE along with other elements. Next. Coming to another area, we can see I have clubbed so many slides in in one slide due to paucity of time. You can see that the Dharmapuri schist belt shear zone almost 200 by 30 to 50 kilometer long northeast southwest belt, where Pakkanadu was explored by AMD, and because it was having thorium, the exploration was called off. But since the RE importance has come up in the recent years, we have reopened this area, and exploration is in very advanced stage here. There also we get along with RE, thorium, niobium, vanadium, barium, strontium, magnesium, and a very important element, scandium, is also associated. In addition, the recent surveys by AMD has also indicated Mulakadu and Volakkad, two more areas to be RE bearing, and this area we have proposed for heliborne survey. And I feel that this large area will have at least 10 prospects which are waiting for our exploration input. And you can see the section below that along with pyroxenite, we get lot of carbonatite veins, and they contain lot of barite and monazite, which are giving rise to RE. Of course, this we are having monazite, but it's very low in thorium as compared to monazite, which is available in beach sand. Next, please. Coming to another important area, that is Sivana Ring Complex, which is Badmer district of Rajasthan. AMD has been working there for past 1 decade, and there also we went with some concept of volcanogenic type of uranium deposit. Of course, these are the all paralkaline igneous rocks. It's a neoproterozoic Malani bimodal volcanic caldera, and it contains rhyolites as well as granites, and it contains basalt as well. That's why it's called bimodal volcanism. And here by our surface survey, some 6 major prospects have been identified, which are Batikheda, Fulan, Dantala, Ramania, Nal, and Budiwada. And I am happy to say that this area was initially, it was taken up AMD in many phases, but the present phase was commenced by none other than our CBK Varghese, who is presently Regional Director of Southern Region. And all these anomalies are relocated, and some new are located by him. And later on, RMRE group has taken up these areas for detailed work. And we can see that HRE in all the prospects is in the range of 35 to 40%. And they have the high value commodities like praseodymium, neodymium, dysprosium, terbium. So these are the 4 most important sought after RE elements. They are in very good quantity. In addition, we get a substantial quantity of niobium, zirconium, and hafnium associated with this. So in true sense, these prospects are all having multi-metal deposits, and since it's a silicate ore, it's having a good potential for acid leachability, and a lot of work is being carried out by BRC on leachability aspect also. Next, please. Some of the prospect areas I will tell. Before that, I will want to tell that the control of mineralization in these paralkaline rocks are both litho as well as structure control. Lithologically, they are associated with granitoids and tuff, where we can see that paralkaline nature. They have got azurine rebecite. They have elevated concentration of high field strength elements. And tuffs are there which have underwent hematitization. They are rhyolitic composition, they are paralkaline nature, and they also have azurine as well as rebecite, and they have also elevated concentration of HFSC. It also has the control, structural control, where we can see that arcuate fractures, they are the possible conduits for intrusion of microgranites as ring dikes, and the basin-like bodies like a host of pyroclastic rock materials, subhorizontal formation, mostly in central and western part of SRC, where we get the tufaceous rocks. So these are the control of mineralization here. Next. And some of the, next please. And some of the guides to locate similar paralleline magmatism are, they should have rift or extensional setting. There should be felsic magmatism. It should have paralleline nature, that is the ekpatic index should be more than 1, and presence of azurine and rebecite are the direct evidences. Molar NAK is the per ekpatic index, I have said. It also have the higher gallium by aluminum ratio. They are enriched in HFS elements as well as their enrichment in heavier rare earth elements. So these are some of the guides. We can look for other similar kind of deposits elsewhere in India. Next, please. Some of the prospects I want to show. Before that, you can see the rock types at Dantala. It is rhyolitic tuff. Batikheda, we have the microgranite intruded within basalt. At Nal, we get the rhyolite as well as microgranite within rhyolite and granite. And at Fulan also, we can see the microgranites intruded within the basalt and andesites. Next, please. So these are some of the prospects. The upper figure shows the Dantala, where the tuff occur from surface to almost 40 meter. It's just a coal seam type of ore body we get, and the RE is associated with this tufaceous rocks. It's a near surface deposit. Just by open cast we can see. The lower left photograph is the rhyolitic tuff, whereas the right side we can see the boron is a typical section of Nal area, where more than 22 microgranite dikes are mapped, which are intruded within granite as well as rhyolite, and these are all RE bearing from 0.5 to sometimes even 1 or even 2%, but the average grade goes up to 0.5 or 0.6% RU. Next, please. This is another area which is under current exploration, is the Fulan. Here we can see that microgranite dikes are intruded within rhyolite as well as basalt, and we can see the continuity of these dikes from surface to second level, even third level of exploration is also done. So here also we have established about 1500 meter strike and about 350 meter vertical depth. So this is a coming up area where we are going to establish a another deposit. Next, please. One more area is Romania. Here we are having this mineralization associated with azurine and rebecite bearing pegmatitic granite. So we are having in rhyolitic tuff, we are having RE in microgranites as well as we are having RE in the pegmatitic granite. Here almost 1 kilometer strike length is proved, and up to third level we have established, and you can see the lower left how the rebecite and azurine needles are easily visible, and all these have rendered parallelinity to the rocks, and that ultimately has given rise to RE mineralization. Next, please. So these are some of the petrological studies. We get a mixture of minerals. We get basnasite, xenotime, fluorensite, uranium, titanium complex are the main minerals. But in addition, you can see that zircon, allanite, selenite, chevikinite. There are some more than 50 minerals identified in Sivana, so which makes the mineralogy complex. However, since it's a silicate ore, whole rock leachability has been found to be very good for winning these elements. Next, please. So, in conclusion, I just want to say that I have elaborated only 3 areas: Pakanadu, Ambadongar and Sivana. In addition, our GSA friends, they are working in Samchampi and Gundlapet area. Kamthai was already worked by Messrs. MMPL, and some more areas are now coming up. So although we have the huge resources of RE contained in monazite, but RE resources established in hard rock terrains of carbonatites in past 1 decade, like at Ambadungar and Paralkaline suit of Sivana Ring complex, they are very potential RE resources, as well as the Pakkanadu carbonatite complex, which also shows the low thorium as compared to RE in beach placers. So that is also coming up as a new area, and this is a favorable factor for the extraction of RE. And Pakkanadu is not the only one. The Dharmapuri shear zone hosts so many cyanide bodies, and very little work has been done. So many areas are under exploration, ground as well as heliborne survey, and I am hopeful that many new prospects will come up. So there is a need for integrated exploration for RE as well as associated critical elements in these areas, along with other known similar geological setup across India. Next, please. So I thank you for your patience hearing. This is the Ambadungar deposit, just one hill that contains the 1 million ton deposit of RE. Thank you.
In Tamil Nadu, and the paralkaline granites of the Sivana Ring complex, which underscores the growing importance of these elements in securing the nation's critical mineral supply chain. Now I request for a virtual presentation of the memento to serve. It will be later handed on in kind.
Thank you. Thank you very much.
Moving on, it is my privilege to introduce Sri Rajesh Durai, Director, State Unit, Bangalore Geological Survey of India, as our next speaker. He joined GSI in 2000 and has been serving for 25 years and served in various places of posting like GSI Lucknow, GSI Chennai, GSI Shillong. He has 20 years experience in geological mapping and exploration, particularly in the field of precious metals and critical and strategic metals. Served as faculty in GSI Training Institute for 3 years. His rich experience has resulted into 3 publications, a paper on metamorphic evolution of granulites around Rajapalyam area, Madurai block, southern granulite terrain, Tamil Nadu, and it was published in Pan-African Event India and Antarctica, IGCP 570 GSI, special publication 2008. The next paper was the Surly shear zone and regional scale folding pattern in Madurai block of southern granulite terrain, South India, and was published in the Journal of Earth System Science, Indian Academy of Sciences, 2010. And the third paper was the first report of carbonatite from Gundlupet area, Western Harvard Crescent, Karnataka, Southern India by in Geological Society of India, 2021. He received National Geoscience Award 2022 in the field of mineral discovery and exploration. He has visited Mongolia as a part of the Indian delegation to attend the Mining Week 2024. Visited Somaliland as a part of leader of Indian delegation to explore the mineral exploration activity 2025. With over 20 years of field experience in geological mapping and mineral exploration, his deep technical insights and field knowledge will greatly enrich today's discussions. Sir, may I request you to kindly take the dais and share your expertise to the talk on RE exploration in carbonatite, and the nuclear field. Excellent
Now it will be. Good afternoon all. Thank you very much for the organization opportunity to invite me to this workshop on these topics. I think this last 2 presentations, my previous presenters very nicely discussed about the carbonatite of India. And in this presentation, continuation of the previous presentation, already they have discussed about the carbonatite in the Ambadungar, the carbonates of Tamil Nadu alkaline complex, and Kamta, and this is one of the recent discovery of the carbonatite in the southern part of the Dharwad Craton. I can say this is one of the recent discovery. For that, we received the National Geoscience Award 2022. Yes, the Pandey sir, morning he was discussed about the critical mineral mission. It is very important and present scenario. Yes, the Ministry of Mines is focusing personally in the critical mineral missions. Our GSI is involving and generating the more projects in terms of critical and strategic minerals. At present, GSI has having the more than 50% of the exploration project in the critical and strategic minerals in terms of vanadium, nickel, cobalt, RE, tungstens, like that. So many critical mineral projects we are generating, and so many geological resource bearing reports we are handed over to the state government for actioning. The present Geological Survey of India's State to Karnataka, the annual program of 2025-26, we have taken up around 40 mineral exploration projects. Out of 40, 25 projects are the critical and strategic mineral projects in terms of vanadium, nickel, RE, tungstens. Other than that, precious metals, industrial minerals also we have taken up. So we can see the importance of these critical and strategic minerals in the country. Apart from this, geological mapping, SCM, we can say in the state of Karnataka, GSA, we are taking the geological mapping project. That is also mineral biased projects related to the critical and mineral strategic minerals. So we are entire countries nowadays focusing on the critical minerals. So now my topic is, this is the RE exploration of carbonatite, cyanide complex in Monolith area, Western Darbar Crater. So while during 2020, we will carry out geological mapping, STM mapping. Our officers are found, reported the carbonatite in 2020. Then after that, we are taken immediately the G4 stage investigation. As a 3 scout board we have carried out. So we proved the subsurface continuity of the carbonatites. Then we can subsequently we have taken up the G3 projects, that is 200 meters spacing we are borehole spacing we are carried out, and we are extension of the carbonate we established during 2023. Then the G2 exploration we carried out on the 100 meter spacing, and 45 boreholes we carried out on first series and second series, and third series one of the borehole we carried out side series. So we proved around 200 meter depth subsurface carbonate continue. And this project exploration to 3 years we have taken as an exploration project and completed. The reports are handed over to the recent mining Bengaluru at Bhubaneswar, and it's going for action. Because this is a critical measure, this Ministry of Mines is taking care of that. So now it is coming to next. This is a geological map of area. Geological, you can see here. This is the Bundelpet area. In respect of the all, you can see that nearby this carbonatites, Nickel, Achupura, Tevako, and Sambalpur. These are the eastern part, is mainly a Tamil Nadu Atomic complex. In respect to this is the Bundelpet carbonatites. You can see the southern part of the Darbar. Just west of this Kollega safe zone, and just north of Moya Bhavan safe zone, and west of Sargur safe. Actually, this is place where this Bhavani safe. This is the place you can see this is Bundelpet. East you can see the Brigadier Granite, and south you can see the Diliki. And this is a regional geological setup. The occurrences currently have been reported for the first time from Bundelpet area, Karnataka. The body is located in the junction of two major systems, as I already discussed. Kollega safe zone and east, the Moya safe zone is the south. These carbonates related to the, especially related to the known occurrence of carbonate of south of southern India, it is located 100 kilometers west of Ajipura and Kollega and Karnataka, 150 kilometers west of Oganekal, Tamil Nadu. This is one of the oldest carbonate in India, Oganekal, 2,400 million years for their reports. And these carbonated and the cyanide associated cyanide included the PGC. These are the younger inclusive included in the PGC, which is the post rock, that is the basement rock of the area. You can see the satellite imagery, how it is spatially related. The lies in the structurally significant location bounded by major CS1 and the 3. As I discussed, the eastern side is the beginning of granites, east west Moyas in the south, the Nilgiris is separating from them. This is the Nilgiri. This is the geological map of area. You can see the major rockets here, PGC. PGC is included by the cyanide and carbon. This is the carbonated body, extremely 2.5 kilometers within the suns. These may be the replacement may be the carbonate is the last phase of magmatism after cyanide. So you can see these 2.5 kilometer strike on the carbonate were established by putting the borehole and the surface tension between the trenches and filling. So continuous borehole, particular borehole we did first period and second stage borehole. You will see the all 100 meter spacing and second series of we have completed and one more borehole is there to their level. This is the part of this 40% their level. The carbonate occurs linear band between the cyanide occurs inducing the post rock. Place here of viscous wire flow. Cyanide is a stage of the deep globule. Cyanide is a deep globule.
Excuse me, sir. Sir, your voice is not going online, sir. You can point towards the mic and speak. Very low voice is going.
Okay.
And now,
Okay. Now this is the cyanide body, 3 kilometer cyanide body, maximum width of 500 meters. You can see these are the carbonated, but it is the 2.5 kilometer, 100 meter spacing we carried out the drilling. And these are the second series, the blue color, and then just below that, and around 150 meter and 200 meter second series we carried out, and third series 240 subsurface 2 kilometer depth. So these are the outcrop pattern of the carbonatites. You can see these are the subdued outcrop of carbonate. This is the cyanide body. You can see this is the carbonatites. These are the bands. You can see this is a carbonated outcrop. It's mainly composed of solvate, calcite variety. This is calciocarbonate, solvate variety. Contains mainly of apatite monocyte. These are the monocyte. These yellow colors are monocyte, and these dark color under that is ionites, hematites. Magnetite and hematites are there. You can see these are field photo carbonated and cyanide with RE phases. The field photo carbonated with RE minerals. These are the monocytes. You can visibly, you can naked eye, you can see in the monocytes, the field itself. And these are the apatites, lens. These are the magnetites, and these are the monocytes within the carbonatites. These are the RE phases in the carbonatites, and here you can see the apatite minerals. And UV2 crystals of alanine in the carbonatites. And here is the cyanide. Cyanide also having these RE phases, but coming to the values, the cyanide we have the very less values, 1000 ppm we are getting the RE, but compared to the carbonatites, but we are not concentrating any cyanide for the resource, but we have calculated resource only for carbonatites. And you can see the phenites, the contact between the cyanide and carbonate. Just previous speaker was discussed the phenites. They very clearly indicates the contact metamorphism. Cyanide and carbonate is phenatics, resulting in the formation of sodium amicrol and pyroxenes. These phenatization is also we are observed in the Bilgor subclass. You can see these are the phenates, carbonated, and cyanide is occurs the enclaves within the carbonatites. This is the later. And here you can see the core sample, carbonated and cyanides, the contact metasomatism, phenates. And the cyanides are undergone some sharing folds and you can see here the disseminated grains of monocyte and apatite. These are the core photograph of carbonatites. Within this, you can see the depth level. We are getting the 4 meter, 5 meter, maximum we are getting 30 meter carbonated in the subsurface. We have sampled everything in the 1 meter spacing. And here you can see the carbonated and cyanide Association. Here, these are the cyanides, and these are the typical carbonates, and these are the carbonates, and the substance gold. And some petrographic studies also were carried out in the carbonated and cyanides. You can see the carbonated in the upper types, calcites, and you can see the monocyte here. Monocyte, and these are the alanites within your calcite grains. And these are the cyanides, petrographic studies. Here, typical of petrography of cyanides, mainly a potash feldspar, and some pyroxenes also there because of this pyridization effect. And here it's a potash and plagiarized feldspar. And some petrographic studies, BSc imaging, EPM studies are carried out in this carbonate. You can see the phases of RE bases, basanite, alanite, and monocyte also we are recorded during our EPM studies. These are the BSc images. Here you can see carbonate showing the conversion of carbonate to windstone. These are the metasomatism effect. Carbonate will convert to windstone. The geochemistry of carbonate, you can see this. Based on these chemical analysis, you can say these are the carbonate because this COE value you can see, and SiO2. Actually, normally the carbonate, we have the high strontium value. Actually, strontium also one of the critical minerals listed out in the MOI. We have the very good resource of strontium, but the resource was not, we are not calculated for strontium. Only we are calculated that RE. We are planning to calculate the resource of strontium also because the strontium we are getting maximum 2%, maximum 2 to 2.5% we are getting strontium. High concentration of strontium. Wherever you have the carbonate, you can look for the strontium and barium. But if you have the barium is less, but the strontium is very high. Same, we have HRE is less because this is LRE rich carbonates. HRE is less. And there is no niobium and tantalum. And uranium, thorium is very less. We have the main LRE rich, lanthanum, cerium, and neodymium. These are the, we have plotted the diagrams. These are coming in the calcium carbonate. That is, just as well, this is Soviet variety. We can see strontium how much different. Each sample we have, because I have shown only one sample. Every, it is going up to 2.5% strontium. There is one of the critical elements as listed in the list of ones. These are the magnetic geophysical surveys we carried out. You can see the low magnetic, the carbonate is well within the collaborative with these studies, the carbonated bodies. And here also you can see these carbonate, we have the values, the low values of the carbonated zone magnetic profile. The low magnetic response value compared to the cyanide. Wherever cyanide is the high and whereas in the carbonate is the low magnetic. These are carried out in the geophysical studies. And this is the radiometric study of surveillance we carried out the past anomaly map. Everything is the positive. And now I will show the some surface and subsurface chemical analytic images. Because most of the presentation not reflect in the chemical analysis. Okay, I want to show the chemical analysis of the carbonate, how it is making surface as well as surface. This is RE content. You can see the all. So around this is a limited sample. We have collected more samples because I want to show this around 25 samples or 30 samples we have taken. You can see the carbonate how it is mixed. Lanthanum, cerium, and neodymium. These are LRE rich. And you can see the strontium. It is we are getting the LRE 1%, more or less 1%. We are getting the LRE. And the total RE, it is 1% is getting. The 0.9% is the LRE. The total RE content in the carbonate ranges from 0.59 to 1%. The average is we are getting 0.76. So we have mainly three components as I earlier discussed the cerium. You can see the ranges from 3,000, 4,600. The lanthanum is 1,500 to 2,600. And neodymium, this is one important element in the elements in the LRE, neodymium. 1,500 to 2,400 EP. This is the surface well. We have collected each systematic sample. Every 30 meter we have collected the samples. And we did the trenching. Everything we did, then we established 2.5 km, 2.8 kilometer carbonate. And just this is the subsurface drilling we carried out. This is a two series of first level, this one, and this is 31 the second level series. You can see here the zone, how we are demarcating. These are the zone maximum, we got 30 meter carbonate. You see the value is 0.5%. The average also you can see the 0.5%. And we have covered the metal content. Each metal content also, lanthanum, cerium, neodymium, metal content separately also we calculate. This is ore zone intercept 0.5% of RE cut-off rate. 0.5%, it means 5,000 ppm. These are the one, this is a AG19 board series. It is intersected. And second series we carried out 31. This, all these bands are in this. Total 6 bands we are there, but multiple veins are there in the subsurface. This is cut-off of 31, second series. You see the values. More than 3, you can see this width of the zone. 1.6 by 2.7, 1.19, and the values are more than 5.5 cut-off. The very where the RE rich, highly LRE rich carbon types. And this is coming to the third level series. This bone we did 20, 32, and 44. 3 series we did. This deeper level we did up to 260 meter depth. That is your maximum depth we did the third level series. Here also 0.5% of your RE. These are the values. You can see one of the zone 2 is 23 meter. Zone we got it. It means 23 meter subsurface carbonate only. You see the value is 0.6%. Very high value in the LR. And this is the 32 second series. We have the good width of the zone and the values. And this is the 44 deeper level bones width as well as the values. This resource we have calculated as on the G2 stage, the 0.25% and 0.5%. We have calculated the RE. This is the 11.48 million ton resource, RE resource for calculated 0.25%. And 0.5% cut off, 6.35 billion ton. So like that, lanthanum also you can see. And this coming in the cross section with it. And this is the metal content of RE also we have calculated. Total RE, this is lanthanum, 11,445 lanthanum, only lanthanum, then cerium, then neodymium. Because 3 elements are major elements, we have calculated separate resource for this also and total RE. This both the method we have estimated, one is cross section, another one is LBCs. Longitude. The resource of Bundelkhand area is 11.48 million tons at 0.25%, means 2,500 ppm. The cut-off grade of 0.0548%. And 6.35 million ton of 0.5%. The resource will be more if we are going for the further deeper drilling. Because we did maximum in the second level series. Third level series, we did only one bore. We are going by third level series, the resource will be go beyond that. So this is the distribution pattern. You can see here the 44% of cerium, the LRE. It means LRE is rich cerium, lanthanum, and neodymium. So like that, this also we are calculating, resource also we are calculating. So this is one of the significant mineral discovery in the entire country in the recent time, and is the first and major economic RE prospect in the greenfield area of Karnataka. The new finding of the carbonated associated RE has been appreciated by the geological community of the country, including Geological Society of India. In view of increasing the demand of RE in green minerals in evolution, the major discovery of this RE prospect in Karnataka will go longer by meeting our country RE requirement to a considerable extent. Besides opening a new vista for further geoscientific studies in similar tectonic minerals in southern peninsula for locating more RE rich archaeological. These are the contributors. Thank you so much.
The talk is open for discussions. Any queries, any questions, please?
what is the age of the government, right? So that we are looking is because we are relating more or less the panoply in that is placed. Just like that, we are compared to Paknad, Savapura. Because there are those are panoply 500 to 700. We are also expecting the same. We are given for the age analysis. 80 for that. More or less, it may be.
But the rock forming mineralogy, the RE mineralogy appears to be same to that of the volcanical carbonate. Have you seen the volcanical carbonate? It appears to be same. That is mesoprotein. That is mesoprotein. Yeah, $1,900.
So
It appears to be.
Doreza, you have given a very good presentation. Actually, what are the values of uranium and thorium? Because RE mineral is mainly monazite. Because what is the?
No, actually, that's already I told you. Uranium and thorium, these are very less. 25 ppm only here.
But it is actually surprising. It's a monazite normally contains.
Yeah, also surprised really. Because monazite is there, but in the thorium and uranium, we are not getting any. Because if it is a thorium is more, we can calculate in the monazite dating also. But here also it is very less in the thorium.
Yes, generally in the beach places we get monazite, it contains 8 to 10% THO2, almost 0.3% U3OI. Whereas in the carbonate it goes up to 2% THO2.
Yes.
So in Pakkanadu also area also almost 1.5% THO2 is there. So it is very surprising whether how come the thorium and uranium values are very less in these
Actually, it's not. I am not showing the values, but I got a very good idea. 25 to 50 ppm only you are getting is the uranium and thorium. Plus, so that is the. We are surprised that why this thorium is not compared. Uranium is not. Thorium is why it is. It is showing like that. Including our petrographic and PQM studies, we are not found any thorium in it.
Okay. Thank you.
Congratulate Mr. Durai
Yes, sir.
for this wonderful report for the first time in Gundlupet area. Another one very interesting thing, as far as the geotectonic setting down, this is a turning point of Western Dharwad Katan to Eastern Dharwad Katan. You can see the fabric. You can see that where that turning is taking place, it is oriented in the east-west direction.
I said.
So this perhaps is the first reported carbonatite body in whole of India, which is having the east-west direction. Much of the carbonatites are in the northwest sources. Right? So in this way, that it requires a beautiful structural studies. You have part of that you have already done. You have shown that fabric there. And second thing is, I would like to know that what will be the difference between this particular carbonatite, the Kollegan carbonatite, which has reported much earlier by V. Ramarao from Department of Mines and Geology, long ago. And have they studied on strontium 86, strontium 87 isotopes?
No, that global isotope that several data we are not studying. They are not studying. And whatever you are told, this Bhubaneswar carbonate also we are not compared with that because we are compared with Pakkanara and these things. Bhubaneswar we are not compared because I got the new says that Bhubaneswar is not much monosite. That is dated in the mesoprotein. It is not there is monosite in the carbonate. But here the main thing is monosite, lanthanum and neodymium. Neodymium is another important factor in the RDC. That is one major discovery in this carbonate. Compared to any
Strontium isotope has to be done. Strontium 86, 87 and
that was we are working on the same.
I would like to supplement Pandit sir. Actually, the Pakkanadu carbonatite is the eastern part. You are telling about the Moyar Bhavani shear zones. Yeah, there that your Kundalapet carbonatite is east-west. Whereas the Pakkanadu carbonatite is north of the Moyar Bhavani shear zone. It is mainly within the northeast-southwest Thermopuri shear zone. So that is very, that has to be studied actually.
Correct, exactly. All other carbonatites are because you are Pakkanadu or Yelagiri or whatever the Tamil Nadu.
They are all in the northeast southwest Thermopuri shear zone. Yeah.
Wherever here is related to the Moyar shear zone, that is why we are getting the carbonate in the east-west.
Yes.
The fabric is east-west, where the carbonate is absent.
So there is a need to look in that east-west Moyar Bhavani shear zone for more such type of carbonatites.
Yes,
Thank you so much.
Chance is there. Yes, sir. Please.
I really compliment for that wonderful presentation. In fact, one of your officer has also gave a talk in Geological Society of India last year. My just a clarification, what I wanted is, as Dr. Pandit pointed out, this carbonatite you are getting just along the boundary of the Dharwad crater and the southern granite terrain. That's why the east-west structural fabric, what you are getting there, it's mainly for the SGT.
SGT.
You have that, southern granite.
That
East-west country. Yeah. I was wondering, have you done any work on its petrogenetic aspect?
So petrogenetic aspect because that we did carry out some isotope this one.
That geopolitical the petrogenesis aspect of the carbonatite, because they are mainly LRE which you are telling. So which, and also you said they are Pan-African.
For us, related to a book that will be the Pan-African, but
yeah. So what could be the source for this carbonatite? That's what I just wanted. Perhaps you can get into some literature, and also, as he said, I think Jagdish, we can correlate, some of these southern carbonatites, like that of northwest, southeast trending carbonatites and the east-west trending carbonatite. And come to certain conclusion, what would be the potential trigger for these carbonatites? That's what. So you can have a look at
both. Definitely, sir, we will look into that. We will compare with other carbonatite also.
Yeah.
Correlation of geochemistry as well as the petrogenetic.
Yes.
We will compare that.
Otherwise, it's a wonderful presentation. Thank you.
Further discussions we can have over lunch. So thank you, sir, for the detailed and data-rich presentation on the Kundalapet carbonatite cyanide complex. The integration of geological mapping, drilling, petrophotographic analysis has clearly revealed the potential of the structurally controlled intrusive system. The identification of LRE-rich carbonate bands, high strontium content, and the substantial resource estimates underscore the strategic importance of this complex in India's critical and mineral landscape. Now I request Sri Jagdishan to present a memento in gratitude of his acceptance of our environment. Thank you, sir. We have shifted the next talk in the post-lunch session due to the time paucity with respect to having lunch. And before we disperse for lunch, I request our convener, Sri Jagdishan, to take the dais to acknowledge and thank many who joined online during the course of this workshop.
A very good afternoon to all. So during the course of our workshop, many senior officers of AMD, they have joined online. So I would like to thank all of them. So we are very thankful to Sri Manik Agarwal Sahab, Additional Director Operations 1, P.K. Sarma Sahab, Additional Director Operations 2, heads of different groups, AMD headquarters, and head PMAG and officers of PMAG, They all joined through virtual mode. So I would like to thank all of them. And many senior retired officers also, they have joined online and they are witnessing this workshop. I would like to thank Dr. D.K. Sinha, former Director AMD, Dr. A.K. Chaturvedi, former Additional Director, Dr. A.B. Jayagopal, former Additional Director, Sri D.K. Chaudhary, former Additional Director, Dr. B.S. Bist, former Regional Director, Dr. K.K. Pandey, former Additional Director, Dr. Naveen Goyal, former Head PG Group. They all joined through virtual mode and they witnessed the workshop. We are very thankful to all the senior retired officers who have joined online. And also, I would like to thank K.V. Krishnamurthy, Geological Survey Society of India, who have joined physically with us. And thank you so much, sir. And now we break for lunch, and after lunch we will join for the post-lunch session. Thank you so much.
So we will be again restarting the post-lunch session exactly at 2:30. So please assemble back at 2:30. Thank you.
Mixer.
I hope you all had a
Audio mixer. Audio mixer. Yeah, video.
We reconvene for the afternoon session of this vital workshop and critical minerals, challenges and future prospects. Myself, Dr. Swati Pant, on behalf of AMD Southern Region Bengaluru, want to welcome you back and thank you for your continued engagement. In our pre-lab session, we have already seen how exploration lies at the heart of unlocking the potential of strategic and critical minerals. Whether it's identifying new deposits, leveraging advanced technologies, or understanding complex geological settings. This afternoon, we continue to build on that foundation with sessions that will further explore innovative methods, case studies, and collaborative strategies that will shape the next generation of mineral discovery. I encourage you to stay engaged, ask questions, and share your insights, as these conversations are key to advancing our collective understanding and addressing the challenges. So let's begin the session. It's my extreme privilege to introduce our first speaker of the post-lunch session, which is Sri H.P. Harish. H.P. Harish is Deputy Director Plant, Department of Mines and Geology, Government of Karnataka. Third is an eminent geologist with more than 15 years of experience of holding different responsibilities in the Department of Mines and Geology, Government of Karnataka. He obtained Masters of Science Applied Geology, the gold medalist from University of Mysore in 2004, and joined Department of Mines and Geology, Government of Karnataka in May 2007. Served as Senior Geologist, Technical Cell, Commerce and Industry Secretariat, Vikas Soda, Bangalore, Assistant Secretary Mines up to 2015, where he has made noteworthy contributions as a member of committee in formulation of rules and regulations on minor minerals and stone development. Sir has served as Officer on Special Duty, Principal Secretary to Chief Minister Karnataka up to 2018, followed by serving as Private Secretary to Chairman Karnataka Legislative Council Bengaluru up to 2021, and is presently serving as Deputy Director DMC Karnataka. He is presently engaged in exploration activities in the department, along with upgradation of department laboratory and procurement of advanced instruments. So, sir, with this, I would like to invite you for your lecture on recent developments in regulations and amendments in critical minerals, mining lease, and policy.
You very difficult to draw the attention of audience before the lunch session and after the immediate. But I will try my level best and to give insights on the creative state. With respect to our critical strategy. And I thank dear sir who has made my presentation easy by giving majority of the concepts and introductions done by Ministry of Mines in this regard. So I have very less exposure as a field geologist, but rightly have been given this topic with my exposure towards administrative experiences, especially in training rules and regulations. And my topic is relation development, regulations, and forest limits. Firstly, before starting, I would like to thank the AMD organizing committee of SCM and all other officers for giving me this opportunity to make a presentation on this. So this part is already explained by the sir. I won't repeat. And the basis of identification. Mic volume you all know that in the recent decades, focus on low emission products and focus on renewable energy sources and many technological advancements has led to demand in this critical mineral, and this has led to declaring the critical minerals list by the Ministry of Mines in June 2024. And all these days we were talking about only Mines and Mineral Development Protection Act 1957. Post amendment in 2015 and post emphasis given on critical and strategic minerals. Another legislation that is offshore mineral development regulation act 2002 is also picking up. In the sense, these were all onshore mineral concession related regulations, and these are offshore mineral concession related regulations. And similar to this rules set up mineral option rules, which was placed actually after this amendment of MMDR Act in 2015, many set of new especially mineral option rules 2015, which define the process of granting mineral concessions through auction process, and mineral evidence of mineral content rules it defined what should be the level of mineral content to be established to grant the concessions either into composite license or to mineral mining leases. And then mineral conservation and development rules, post mining grants are concessions are granted. The requirement, statutory requirement to be complied by the mining lease holder or composite license holders are covered under MCDR. And another one is MCR, Mineral Concession Rules 1960 was repealed and termed it as a minerals other than atomic and hydrocarbon minerals concession rules 2016. So basically, these are a few set of rules which define the various aspects of implementing the objectives of the MMDR Amendment Act 2015. So similar to that, Offshore Areas Mineral Development and Regulation Act, under this act, many similar rules of option rules, existence of mineral content rules, MCDR, MCR, all those were put in place very recently. So now, a big way Ministry of Mines is pushing for both offshore and onshore mining. And the main objective of these amendments are to bring in transparency, efficiency, and to enhance the mineral production in the country and harness the rich mineral resources of our country in a faster mode. So, to just highlight brief changes that were brought in place in 2015, which is a major milestone in the mineral regulation aspects are concerned. This is MMDR Amendment Act 2015. Four major changes were brought in. One is grant of mineral concessions through auction process, which was earlier through first come first served basis, and there were some mechanism like recognized permit, prospecting license, and automatic grant of concessions from RP to PL, PL to ML kind of a thing. All those things were discarded, and the existing leases, there was a renewal concept before this amendment, and that was removed, and it was made that all the leases will be considered to be deemed extended for 50 years from the date of grant of original mineral concessions, and they were also given a choice of considering the later dates between 50 years from the original grant, expiry of the last renewal made, and third one is 2020 for non-captive mineral concessions, and 2030 for captive leases. So this was brought in to ensure that there is no disrupt in supply chain of mineral commodities. And later, it is also one more concept called district mineral foundation was introduced. This is basically there will be a contribution by both minor minerals and major mineral concession holders towards this trust from 10% to 30%. That is for the auction regime, leaseholders will be contributing 10% of the royalty, and non-auction route concession holders will be contributing up to 30%. Basically, these funds will be utilized at each of the districts for overall development of mining affected areas, so that we can build the confidence, and we can take the local stakeholders into the stream, and so that a positive approach and positivity of the mining sector develops over a period of time. And this is giving us good fruit nowadays, because all these days they were cursing. If any new project, mining project comes up, the localites used to curse. But now they are very happy that they are getting some funds for their local development, and they are very cooperative towards mining activities. And another initiative was introduction of National Mineral Exploration Trust, and in this trust, the major mineral concession holders will be contributing 2% of the royalty to this trust, and it is constituted at the national level. And this trust is funding for many exploration projects, right from government agencies, and even also private exploration agencies are getting benefit of these NMA funds. And after this NCMM is introduced, the area and scope of this National Mineral Exploration Trust has also got widened. That means to say that even now NMET can fund for exploration projects overseas. So, and NMET is also making financial assistance to organizations like state EMGs, IBM, GSI, whatnot, to build the infrastructure capacity to take up exploration projects and to aid and assist faster exploration activities. And last one is stringent provisions for illegal mining. Now, even drone and drone survey and social distance survey has been mandated for all the mineral concession holders, and even mineral mining surveillance system has been brought in place, where any change direction will be triggered to concerned stakeholders, means like state governments and IBM, and thereby we can regulate illegal mining activities. So I have explained the first milestone. This is a summary of all the key changes that has happened till August 2023. I think it should be 20, yeah, it should be 24. I think. So I explained in what happened in 2015, and in 2016. I've already told its mineral concession rules were brought in place, which defined the eligibility criteria, evaluation criteria, and performance guarantee, upfront payment. Next was milestone is March 2020, where a provision is introduced to auction the expired mining leases. So before expiry of the mining leases only, we can start the auctioning process. And another provision of defining the minimum production limit for such expired mining leases which gets auctioned was prescribed, which is 80% of the average production in the previous 2 years. And there is another provision of vesting orders was introduced. That means the previous lessee is having valid clearances. As you all know, getting a fresh clearances from forest, environmental clearances was taking huge time. So this concept was introduced under Section 8B of the NMDR Act, where all the statutory clearance which were held by previous lessee will get transferred to a new lessee after auction, so that immediately can commence the operations. And initially, it was thought that some 2 years time will be given to the new lessee to get fresh clearances. But later on, it was taken away, and now it is automatic. So any clearances taken by any concession holder will be till the life of the mine. So that was one major change. And in 2021, they brought in another important changes. Like there were a number of Section 10A group applications. That means the applications of concession holders like RP, recognized permit, prospecting license, which were about to get automatic mining lease. But since they were taking a lot of time to reach to the mining stage, Ministry of Mines had given enough time from 2015 to 2021. Later on, it omitted that section itself and saying that we will compensate for the work or investment done by the previous prospecting agencies. And we will put up these blocks for auction at whatever level it is was available based on the data. And so that the new lessee or new concession holder can immediately start from that point and bring up those blocks to mining stage at the earliest. But again, it was stuck in the courts, and very recently, Honorable Supreme Court upheld the constitutional validity of that section, omitting of this section 10, but still it reserves that there are certain cases which requires some consideration. Because some concession holders had come to the stage of notification, grant notification of mining lease. Just because they could not get the statutory clearance, we cannot take away their rights. This was the contention, and that is still pending. Other than that, scrapping of 10A2B is considered valid constitutionally. And initially, there was a reservation of blocks, auction blocks for captive consumption. And they come that they cannot consume 100% to their own captive industries. Then a relaxation was given in 2021 that up to 50% of the production can be sold outside with some additional payment apart from the premium whatever they pay for auction. And the net worth criteria and others were, and the end-use restrictions were also removed in 2021. Then came in 2022 that second schedule, that is royalty provisions were introduced for many of the minerals like glauconite, potash, molybdenum, platinum, group of elements and all. And they also prescribed formula for calculating average sale price for glauconite and potash. And then came this, I think it is only captured, it is June 2024. Where critical minerals were published, and thereby we proceeded with many amendments to critical and strategic mineral related provisions in the NMDR Act and mineral auction rules and other things, where 24 critical and strategic minerals were categorized under Part D and 29 minerals in the 7th schedule. And concept called exploration license for these 7 scheduled minerals, that is 29 minerals, were introduced. It is a reverse auction process where exploration agency will quote some premium, lease premium, which will be paid by the successful bidder of the mining lease. Suppose if an auction exploration license holder quotes some percentage of revenue that he would like to receive from the mining lease, that much percentage of premium will be paid by the successful bidder of the mining lease till the life of the mine or till the exhaustion of that mineral resources. So, and apart from that, Government of India retained the powers to auction mining lease blocks and composite license blocks for this critical and strategic minerals to have a faster and uniform process in allocating these mineral concessions. And even offshore area auction was also introduced during this regime. So, as I already told, also explained that 6 minerals were being studied that will attract the private exploration agency or to bring more expertise from overseas also to speed up or enhance the pace of exploration with respect to these critical and strategic minerals. And exploration license concept is also introduced to bring in exploration companies from overseas also. And Government of India retained the powers to auction this critical and strategic. So these were the minerals. I don't take much time. These have been already explained. Party minerals and scheduled minerals. And coming back to this important concept of exploration license, Ministry of Mines will identify the blocks, the state governments and GSI. And there is also provision for any private person to propose any block which is good for putting up for auction as exploration license. And after that, auction will be methodology I have already explained. There is a reverse auction process, which will be percentage share of the auction premium that will be paid by the future lessee of mining lease. And bidder putting minimum percentage will be considered the preferred bidder for exploration license. And here the capping was kept as 25% of the auction premium. So this will be the ceiling price, and any person wants to participate in exploration license, we can quote equivalent to 95% or below to it. So whoever quotes the lesser premium, he will get the exploration license. And the period for exploration license will be 5 years, which can be extended for another 2 years. And he has to submit the GR within 3 months after completion of the operations. And there is a provision where exploration license holder can relinquish up to 75% of the area which he has got. And maximum area of any person who can hold exploration license is 5,000 square kilometer. And no single exploration license can be granted beyond 1,000 square kilometer. This is the area limit. So he has to relinquish 75% of the area and retain maximum up to 25% area. And he has to give the GR based on the submission of geological report that the block will be put up for auction within 6 months. Timeline is also prescribed by what time these blocks will be put up for auction and to ensure that he gets his revenue back at the earliest rate. And tendering process 1 year is given, and if any government fails to complete complete the auction process within 1 year, you will be compensated with amount equal to 1% of the expenditure or 10 lakh rupees per month, whichever is higher. So you will be assured that you will get back his money even if that block doesn't go for successful auction. And second one is earlier there was a thought that why will exploration license holder will do for a when he has discovered some mineral, he should be right over that. Because all other earlier auction rules were not allowing the exploration agency to participate in the auction of mining lease. Now, this amendment concept, even the exploration agency and their subsidiary companies will also be allowed to participate in the auction process, provided their identity will be disclosed to other bidders to bring in transparency, so that other bidders can assess the credibility of the information and also confidence in this block. And there will be a percentage share for the entire period of 50 years of the mining lease or till exhaustion of the resources. There is another scheme which is introduced by National Mineral Exploration Trust, both for exploration license holders and also for composite license holders. These are all attractive measures taken, and also to compensate the exploration agencies for the losses or the expenditure they incur during the process of exploration. So they have divided into various categories. If you can see, geological mapping and sampling category under EL is entitled to claim the reimbursement up to 50% with a capping of 1.5 crores. And similarly in CL composite license, they can claim up to 1.5 crores. So these various categories up to some 20 crores is you can claim under exploration license. and some 7.5 crores can be claimed under composite license scheme. So there will be a mobilization advance can also be given up to 15% to these agencies if they want to claim. And there is also a mandate that they should share all these exploration data. Now, after introduction of this NGDR, it is compulsory for all exploration agencies in India to upload their exploration data in the NGDR portal. So these are major legislative changes to enhance the critical and strategic mineral exploration and mining ecosystem. And I have spoken about this critical minerals publication and also on exploration license. I will directly come to October 2023 and February 2024, where value of estimate, VR is nothing but value of estimated resource. This is a very crucial point in any of the option, because whatever the resource that has been established in the particular block will be multiplied with the average sale price that will be published by IBM. And that forms the value of estimated resource, and that will be the basis to decide the net worth of any bidder. And also it will be a basis for upfront payment, performance security, security deposit, and others. So all payment related things will end up with VR. So VR is very essential. So calculation of value estimated resource in the absence of average sale price that was being published by IBM is introduced for lithium, where weekly prices of lithium hydroxide and monolith or other appropriate compounds that are being published by London Metal Exchange will be considered as the basis by IBM. And for other minerals, rates published by USGS and other reputable publications multiplied with average reference rate of RBI is will be considered to calculate the value of estimated resources. And December 23, major shift or major changes done with respect to NME, where earlier all notified private exploration agencies have to route through state governments to get the approvals and also to get the funds and all. That has been removed, and they now notified private exploration agencies can directly submit the proposal to NME, and even funds will be directly given to notified private exploration agencies, including the advance mobilization fund upon payment of tax. And next, in January 24 and March 24, mineral auction rules were amended, where capping was reduced for performance security for composite license holders to 250 crores and mining lease holders to 500 crores. Actually, these problems arise because over a period of time, many blocks came up with multi-commodity, where the value of estimated resource of all the minerals are considered was going very high. So there was no participation, there was no interest shown by the bidders. To encourage more bidders to participate in the auction process, this capping was put in place so that there will be more bidders participation. And similarly for exploration license, capping was put up to 1 crore if the area is less than 500 square kilometers, and 2 crores if the area is more than 500 square kilometers. And second schedule, that is royalty rates, are also introduced for rare earth elements and other critical elements. These are a snapshot of these royalty rates and schedule 2 of LODR. So they have different royalty rates for primary source of mineral and also as a byproduct. So won't take much of a time. This has been elaborately explained by Dheeraj sir. This is just a nutshell and breakup on various categories. I think objective 2 has a lot of scope for organizations like AMD and state EMG, GSA and all, wherein we can encash this opportunity and play a pivotal role in enhancing the human resource skill development, setting up a critical minerals processing park, which was elaborated by Mr. Pandey sir. So these are the earmarked budget provision for a period of 6 years from 25-26 to 31. And these are the outputs which Mission looks forward. that about 1,200 exploration, domestic critical exploration projects we envisage after 2031, and foreign critical mineral assets acquisition is targeted up to 50, and recycling of around 4 lakh tons of critical and strategic minerals is expected after spending around 1,600 crores. And patents in critical mineral value chain of 1,000 numbers, and skill development to a tune of 10,000 numbers is expected. And mineral processing for parts of it is envisaged to set up at least 4 numbers of mineral processing parts, and then the 3 center of excellence institutes to be set up, and mineral stockpile of 5 is envisaged to set up over a period of next 6 years. So these are various other components of a national critical mineral mission, and various activities listed under various categories, which include even financial assistance for import duties of certain critical minerals, and incentive schemes for recycling plants and all those things, and capacity building programs. I think since I had asked a question previous, I think this is the area where EMD can look forward, where you can, because certain mineral commodities were limited to only EMD all these days, and now it is open for all other exploration agencies. I think collaborative work with state EMDs and GSIs and other private exploration agencies and overseas exposure programs can be the area of focus or area where EMD can contribute in this success of national conservation. So last is, as you are all aware, getting forest is the biggest task until 2023 amendment. So there is a very cumbersome process. There was no much clarity in getting the clearances proposals process. After 2023, now these exploration and survey activities will be no longer considered as a non-forest. That means it will be part of forest activity. Thereby, a lot of relaxation and the simplification has been done in this process. Now, have just there are some guidelines to this amendment, and they have changed the name from Forest Conservation Act to One Samrakshan Evam Samvardhan Adhiniyam, and after this amendment, now there are several circulars, especially with respect to exploration is concerned. I have focused. 29th November 2023 is the main guidance and circular. And subsequent to that, 19 November 24, 17 December 24, and 17 January 25, and 7th April 25. These are the key circulars exploration is concerned. After these, I didn't get into the individual circulars because it gets confused. So I am just summarizing what is the present status after all these guidelines. Now, what they have done is permissions for all geological mapping, geophysical mapping, and survey and sample collection, including fitting and trenching. Now they are considered through an offline process. So permissions can be taken through an offline process, though MOEF mandates that officer not above the rank of DCF should give the permissions. But in Karnataka, what has happened is immediately after this 29th November 2023 notification came, there was no clarity. It just said the state government can nominate any authorized officer. So with that, our state government had issued authorization to PCCF FC, who was the nodal officer at the state level, as authorized officer to grant the permissions. So subsequent amendments in 17 December 24 and all, it prescribed that not above the rank of DCF, our state government still stick to the old notifications, saying that for better coordination and better overview of all the proposals, still PCFFC, the nodal officer for forest clearance, will be the authorized officer in our state of Karnataka. So that he can monitor and he can direct the ground level staff to get the proposals fast tracked. And on top of it, government of Karnataka has got some mechanism called single window committee, where Additional Chief Secretary of Forest is the chairman of that committee. And this committee sits every 15 days and every 1 month, depending on the agenda, wherein all the officers of Forest Department, Revenue Department, and Mine Geology Department, and stakeholders, be it the mining lease holder or composite license holder or exploration agency, will be called in that meeting. And progress review will be done by ACS Forest. And if any obstacle is there, that it will be resolved and time will be set for each of the stakeholders that by this time, these clearances or proposals should be considered for according to permissions. So, coming back to this second offline mode is, another provision is introduced in January 25, where if any expired mining leases which was having clearances or which were earlier broken up without having the clearances, will be allowed to take up exploration by the state agencies or central government agencies through an offline application. So they can carry out exploration to bring up those blocks for auction. That is the intent. So these are the set of activities that will be considered through an offline process. And these are the activities which are considered through online process through Parivesh portal. You might be aware of it. Now they have introduced Parivesh portal 2.0. And they have created a special category called mining of critical minerals. So if any of the commodities are falling under critical strategic minerals, and if you select that category, priority will be given to those proposals and it will be cleared on fast track basis. And here it was a very cumbersome process of calculating and making payment of compensatory afforestation charges and NPV charges. Now that has been very much relaxed. If there is no tree felling involved, you need not pay any NPV or CA charges. That is, compensatory afforestation charges is exempted, and even NPV is exempted. If there is no tree felling involved, and there was a cumbersome calculation process that 25 boreholes per ton square kilometer was there, and implementing, forest authorities were considering it on a pro rata basis. So now that has been clarified by MOU, saying that you should not decide that, irrespective of the area, irrespective of the boreholes, maximum of 25 boreholes will be allowed to drill with 4-inch dia, and irrespective of the extent, it will be considered depending on the tree felling. If there is no tree felling, you need not pay anything. If there is a tree felling, the NPV rate will be calculated at the rate of 0.1 hectare per borehole, and maximum of 100 trees can be allowed for felling. So this is within the exemption category, and simplified Form C is devised and uploaded in Parivesh portal, and this is all about the online process and offline process in getting the forest. So I will try to put some throw some light on some initiatives taken up by Ministry of Mines to enhance the scope and also to attract exploration agencies to make use of data available in the LGDR portal. As Doris are also telling, there is a portal called National Geoscience Data Repository that we call it as LGDR, which has been launched under the aegis of GSI, wherein now from last 2024-25 field season, all exploration agencies are mandated to upload their exploration data in the prescribed format in this portal. All agencies have been given the credentials where there will be a admin role and also uploader role. So concerned persons who have handled the project will be the uploader, and one person at that agency will be the admin for that approving that data. So there will be a uniformity, there will be a lesser junk data, I can say, while data is uploaded in the portal. And this portal is GIS based portal where you can download any data, and you need not log in or register if you want to just view it. If you want to use the data, then you have to register yourself, and accordingly you will be able to access the data through a login process. and all sorts of data sets, be it geophysical, ground geophysical, geochemical, and geological, all data are available. And another process of digitizing all legacy data of state DMGs and GSA is also underway, and they will also be made available publicly for both the domestic and international clients. And after initiation of this NGDR portal, Ministry of Mines has taken up one initiative under India AI, that is India AI Hackathon, and I must congratulate the AMD team for securing first prize in the last India AI Hackathon. And now second AI Hackathon is on the way, and fortunately the area of interest is falling in Karnataka and Andhra Pradesh. So it is totally 39,000 square kilometer area, and I hope many more technological persons will share their thoughts and methodology. And going forward, this huge database can be best utilized using these modern tools like AI and ML, which will lead to many prospective exploration blocks and mining blocks to come in coming days. So thank you all.
So in that case, thank you so much, sir, for such a great talking update. So it was a post-lunch session and started act, which we all geologists know that is not that interesting a fact, but he made it very interesting and very vivid. Thank you so much for that. So now I request Golden sir to present sir with a memento as a token of our love. Now it's time to introduce our next speaker of the post-lunch session, our very own CDK Vargas sir, Regional Director, AMD Southern Region. The CDK Vargas sir is an eminent exploration geologist with 35 years of experience carrying out exploration for uranium and other atomic minerals, various geological domains in different parts of the country. Sir obtained MSc degree in geology from Mahatma Gandhi University, Kottayam, Kerala in 1987 and joined CMD at Baroda, Gujarat in 1991. Sir has discovered and developed uranium deposits in Sivana Ring complex, which we have already discussed, and made noteworthy contributions to Motive Jahar uranium deposits. Sir implemented and guided an innovative exploration strategy in Sima Basin, which is the richest big uranium deposit in India, Karnataka, and supervised exploration activities of Kumalapalli uranium deposit, Andhra Pradesh, which is the biggest tonnage deposit in India. Shri Vargas sir has been conferred with DA Chief Achievement Award 2018 under awards received for the activity development of Kanchankai uranium deposit in Yadgir district, Karnataka. Sir has published more than 25 scientific articles in renowned national and international journals and conferences. He has served as Deputy Regional Director and is presently serving as Regional Director at AMD Southern Region. So, sir, with this, I cordially invite you to please come on the dais and address about the uranium exploration in Southern Region. The lecture by sir will seek to provide a comprehensive overview of how Southern India is positioned in the broader context of nuclear energy resource development.
Now, directly come to the objective. So this is the, I will speak more of the case studies of exploration for uranium in southern region. So these are the current trends and just objects next question. So coming to in southern region, we are directly dealing with exploration in prolific basins. So we are working with the couple of basins which have got various types of mineralization that is strata bound, granite related, that is nothing but hydrothermal, uncontrolled related. Coming to the strata bound uranium mineralization, as we all know that it hosts the largest uranium deposit, that is it has got a strike length of 160 meter on the surface, and it is hosted by the impure phosphatic dolostone, and it is extending that the mineral sources are identified for about 21 kilometers. So this is the plan of the Tumulapalli uranium group of deposits. It is hosted by the Nampalli dolostone, which has got this sequence starting from massive dolostone in base conglomerate and the uraniferous phosphatic dolostone. In fact, the mineralization is controlled by the phosphate. The dolostone, wherever phosphate are there, and at this particular zone, just below the red shade, we are having the mineralization. The red hashed portions of the resources, reserves identified so far. So we have identified the resource starting from surface up to a depth of 1000 meters. And vertical depth of 1000 meters, and if you see the slope length, it would be for about 4 kilometers. And high load, all two loads are there. High one load is about 3 meters, and footwall is about 1.8 meters. This is the slope of the double section. We can see that the dikes transecting the dolostone mineralization, and here we are not having any displacement. And coming to the control of uranium mineralization, it is a everybody has got a doubt how the mineralization occurs. There are many theories, many discussions on that, and I would like to tell that the mineralization is the host rock is impure dolostone. The uranium minerals identified are fine-grained uraninite and porphyrinite, along with some uranium titanium complexes. Associated minerals, they have pyrite, chalcopyrite, and molybdenite. The nature of the ore body is tabular, strata bound, and control of mineralization, that is phosphate and organic matter. If you see the mineralization, there is a positive correlation of uranium with phosphate. That suggests where phosphate is there, there will be uranium mineralization. But how that mineralization, what is the genesis? That is initial, because I would suggest that the source of uranium would be the seawater containing uranium of about 3 ppb. So initial fixation of uranium by phosphate and organic matter during sedimentation, And it is followed by the diagnostic concentration and the crystallization of the minerals in association with sulfates and organic matter which can reduce. And this shows that reducing environment, say it is a unique thin diagenetic carbonated phosphate uranium mineralization. And coming to the critical minerals, it has got content of association of critical minerals like vanadium, molybdenum, and copper and phosphate also. If we see the distribution of critical minerals, the portion above the high wall, that is upper barren zone, is having higher concentration of critical minerals. So, whereas it shows that the change of redox environment, coming to the granite mineralization, granite hosted mineralization fractures in basement. Mineralization is identified fractures cutting across the basement. We have taken one area that is Katimaya-Kunda along Biyarpalli fracture zone. We are seeing that mineralization is continuous up to 4 series with mineralization and hematization and globalization are zones. We are having two bands of mineralization. This is the longitudinal section below the inline boreholes, and this is the 3D model showing two bands of mineralization. Of course, no values, but continuity of the mineralization is established for 300 meters. And another area where Saroran has told this fractures cutting across, commencing from the basement and cutting across the sediments. As at Abogapalli, some was telling this fractures in Gulchuru sediments, they are all forest covered. But we can see that these fractures are extending to the sediments, and some mineralization is identified by Extra Departmental Barbary working also, and we will be taking up for this area. This area is showing rich uranium mineralization. So this is that what I told that Extra Departmental working which has identified mineralization along this fracture zone. Which are extending from granite to the sediments, and it is identified in the Gulchuru quartzite. So this would be a major thought. These fractures would be future targets for AMD. Then I had earlier told that mineralization is associated with the phosphatic dolostone just below the red shale, but below that also at lower horizon also, that is in the massive dolostones, mineralization is there. But here the content of phosphate is less, but mineralization is richer grade compared to the Tumulapalli group of the deposits. And significantly this has got higher content of copper, nickel, and lead also associated with pyrite as well as copper pyrite. The nature of mineralization is with veins as well as microstylites associated with sulfur. That means it may have a origin of hydrothermal nature, or it can be granite based, what we call as per the latest IAEA classification. So we can see this mineralization associated with copper pyrites and pyrites. So coming to the uranium exploration in Bhima Basin, for which I was also associated for a long time. So Bhima Basin is basically undeformed, but the deformation is along the fault zones that are east-west fault zones. The red dash lines are fault zones identified on the surface. And our work was mainly around the Gogi Kurmara fault zone with the center of the basin. So this is a detailed geological map of Gogi Kanchangai Halkal area. The three largest, richest great deposits, that is Gogi Kanchangai and Halkal. The southern part is the granite, and it is marked by the contact, the basin contact marking is marked by a fault. So we can see that the fault is running along the basement surface contact, but it got splayed west of Kanchangai, and mineralization is around the water basement sediment contact. However, it shifts to the splayed branch. In Kanchangai and Halkan, it is the splayed branch. The fault is having a restful sense of movement also. So this is showing the structural pattern across the various areas. So the western side is the Darshanapur area. We are having a remote fault. Then further east, if we come to the Gogi West, we can see that it is a normal fault. Maybe around the same east-west fault, around the straight fault with the decimal sense. But if we come to west of this Gogi, it is having a very normal nature. So it all depends on the bends in the straight fault, which attributes to the rivers of normal fault nature. And just east of this fault, the normal fault, at Gogi we are having the reverse fault nature along with multiple bands of mineralization. And further east, at about 3 kilometers, at about 300 meters from Gogi deposit, we have got the Kanchangai deposit. It is a reverse fault with a single overload. And further east, we are having the Halkal deposit where a wedge of granite has been pushed into the sediments, and we have got four loads, 2 in the sediments and 2 in the granite. So further east also it is showing typical nature of fault. Here it is a double wedge. Further east there is a tongue-like structure, and further east is like normal fault. So coming to the Gogi deposit, preciated limestone, multiple nodes, and uranite and phosphate, and it is associated with sulfuraceous water and sulfides. This is Kanchangai uranite deposit, further east of Gogi. Only one node, that is horizontal. This is Kanchangai. It has got a strike length of 2.5 kilometers, and this is the Halkal uranium deposit where we are having 4 nodes. The 2 nodes are band 1 and band 2 in limestone, hosted in the preciated limestone, and band 4 and band 3 and band 4 in granite. So it shows the uranium mineralization is localized along the preciated zones in both the limestone and granite. And what about the future targets for Diva Basin? I told that there are some faults, red lines, red dashed lines, but the extensions of those faults from the west as well as east, many are obscured by soil cover of decade scarp. The geophysical data has identified the deep filtering fault. Earlier it was called as deep filtering fault, but now in the west also it is extended based on the geophysical data of AMD as well as DSI. Those areas also would be the future targets for exploration. So this is the faults identified, deep filtering and principally vertical faults. we have got further questions on both sides. We have got employing geophysical surveys to identify fracture faults favorable for uranium mineralization. So another so because presently we are concentrated more only on Gogi Purnagare fault zone. This anti-Achava fault is just north of the Gogi area and it is parallel fault. Then also we are having deformed zones with good low resistivity zones. So similarly, Faradabad fault from the north, that also is a east-west fault with low resistivity zones. So as I told, extensions of the faults below the kind of soil cover would be the purpose of targets. Coming to uranium exploration in Kalaki Basin. In Kalaki Basin, significant mineralization was intercepted earlier, but due to lack of continuity, it was discontinued, and recently we have again taken up this area. And similarly, the earlier mineralization was in the Deshnur area. And now we have taken up both Deshnur and Suldal area where northeast southwest faults are there. So similarly in Suldal area it is similar, but we are having mineralization of the fault contact, faulted contact as well as subhorizontal the sediments. Petrology also shows uranite displacement along with sulfates and along with alterations. So earlier the southern groundlet terrain, it was considered as a uranium free zone. That means it was earlier only we were knowing about rare earth mineralization, especially along these sites. But there are now we consider it as a uranium zone because there are some uranium occurrences identified as graphite and graphite cyanides, and they have to carbonate along the thermogenic shear zone. Regarding this graphite, this minor occurrence of uranium and neodymium was identified in tin cyanide and with graphite and graphite. Several carbonated complex uranium bearing pyrophores are there. So, intrusive uranium deposits. In fact, there are some pan-African granites along this Moyar Bhavani shear zone, that is Ceremonial, Monolith, as well as there are many other pan-African granites which are fertile, and we can see that this Kulambati area in Ceremonial Monolith is mineralized, uranium mineralized, and we are taking up exploration and subsequent exploration this season. It would be promising. We could get some. We could do southern granite terrain also as a uranium province. That is our future target. So similarly, for metasomatite type, we can explore along the high temperature metamorphic zones in Madurai area also. There are some anomalies reported in Madurai also. And considering that regarding this highest and richest deposits, one monument also was inaugurated today. There are efforts by many hands, especially the people from geologists, both as well as Gopi, special congratulations to them to identify of 5 tons each, and special congratulations to the entire team of Southern Region engineering section as well as all other sections who has helped in establishing it within a short span of 1 week. 1 week, both this programs, including the erection of this monolith. It took only 1 week. I thank all of you. Thank you all.
Okay, of course, sir. This one is another speaker, and thank you so much for such an insightful lecture. And the monoliths which we have seen, unveiled, our director sir has unveiled in the morning. Two areas. One is the richest deposit in Bhima Basin, the Halka deposit, and second is the Kumlapalli uranium deposit in the Kadapa Basin. And sir has worked in both the areas. And these two monoliths. So with this now I request Rakesh Mohan sir to please give sir a memento as a token of our love and respect. Thank you. With this, we will break for tea and we will assemble in the hall again at 4:05. Please, after 15 minutes. Thank you. The tea is just outside the auditorium. We'll wait for tea for it. And please. So youngsters seem to be less energetic and our elders are still energetic. So let's wait. Let's take one more session. We take one more. Ladies and gentlemen, now it's my pleasure to introduce our next speaker, Dr. C. Ravikumar, who is Director Geophysics, Remote Sensing and Alien Surveys at the Geological Survey of India, Bengaluru. So Dr. C. Ravikumar sir has obtained MSc degree in Geophysics from Andhra University, Visakhapatnam, and PhD from IIT Dhanbad, and joined RSAS GSI Bangalore in 2010 as geophysicist. Dr. Kumar has served as research assistant at the CWERS Pune Ministry of Jal Shakti and was associated in the field of design seismic parameter studies for various river valley projects, nuclear and thermal power stations across India. Sir has made noteworthy contributions in airborne geophysical survey activities conducted by RSAS GSI Bangalore. Dr. Kumar has authored 22 research papers in the field of airborne geophysics, near-surface geophysics, and seismology, published in renowned national and international journals and conferences. Sir has served as senior geophysicist in GSI, Northeastern Ceylon, and is presently working as superintending geophysicist at RSAS Bangalore since 2017. So with this, sir, I please request you to please come on the dais for your lecture.
Since the morning we are fully loaded in aspects as well as RE and exploration. Now it is slightly shift towards geophysics activities. So I extend my heartfelt thanks for giving me this opportunity. To to share some of the insights about this ambitious national airborne geological modeling program of CES. This is a prestigious and an ambitious project launched by the Ministry of Mines in 2017 with the aim of covering entire India with uniform high resolution airborne geological data sets to cater the exploration activities and narrow down the activities and narrow down the. So, why so relevant to this exploration programs? This airborne. It is a speedy, economic, and systematic coverage in a larger area within a span of shorter period. And we can do the 3D perspective, the depth penetration, as well as the basement configuration things we can show it by using airborne techniques. So I will be dealing with what are the legacy data available with GSI. It is very pertinent and very much useful whenever you are launching any exploration activities. What are the data sets available with us? We can make use of in a better way. We can go for better exploration activities. So this is the GSI, this is airborne geological activities of 7 decades of this one. Legacy data is with us. The first we have initiated with the operation contract activities for these new areas, and followed by with collaboration of the BRGM, the France collaboration we have carried out these new areas, and with collaboration of NRSA, we have launched different programs for Central India and the Northeast and some part of Northeast region. Then with collaboration of NRSA, we have carried out higher to airborne geological data with 5,000 feet and 7,000 feet and higher to data. Now, what is the necessity of again doing this high resolution data sets? Because at the time and again, with the different objectives, we have carried out the different airborne survey activities with different areas. Now, to make it a uniform and with a high resolution, like the Western worlds, they have already completed the entire countries, like Canada, Australia, and even Finland. They have covered entire countries. Similar fashion in India also, we want to generate high resolution airborne geological data set with airborne. So with that aim, again, we will launch this project. So this is our own Keynote aircraft for the past 40 years. We are doing the airborne service with our aircraft. At present, we are doing airborne service with our Keynote aircraft. So previously, we have completed along the west coast, entire west coast we have covered. The land portion of 20 kilometers and offshore 60 kilometers we have covered. In similar fashion, we want to carry out entire east coast with a similar configuration. That is 10 to 20 kilometers on land, offshore 60 to 70 kilometers. So this is with the higher data sets. These are the available data, pyramid data. This is having contribution also. For preparation of old digital pyramid map, we have contributed from Indians. So these are the data sets available with us in that country with a different resolution. So now this NHP projects. Now under phase 1, phase 2, we have launched 21 blocks covering the spanning of this area. So far we have covered 7 blocks. Block 1, 2, 3 months we have already completed. These data sets are available with the India portal. Anybody can view it. So, what is the resolution? Why we are going for this kind of service? Because with NRSA, the higher altitude with the spacing of 4 kilometers, the altitude of some 7,000 feet is the picture of this magnetic situation. Then we have flown with our own Keynote aircraft with line spacing of 500 meters, flight height of 150 meters. These many features we have missed out. Now with the high resolution data with the 300 meters spacing with a flight height of 80 meters, we are gathering with much high resolution data sets. Much more high frequency features, shallow features are much enhanced. We are interested of shallow features. So that way it will gather and will be helpful for mineralization. So similarly, gravity also. The NGRI has published in 1978 illegal map of gravity. Then followed by revised global gravity map of India in 2006 by NGRI and GSA. Now this is the features. Now GSA has launched a new ground geological mapping program with 1 million map. With that, if you see that Brahmaputra, the 10 million map, there was no signature. After doing this high resolution mapping, so well brought by this Brahmaputra. This is the resolution maps. So what we are gathering to this capabilities. What kind of things we can get it? The airport is a rapid and expensive. Inexpensive, though it is a very costly affair. When compared to the larger data sets, this is inexpensive. So what activities can be resolved? This is category, structures, buried depths, 3D kind of orientation. Basically. Directly, we can identify some of the targets like VA, lights, and some other property, capitalism, kind of thing, and the fiber season kind of structures and the manipulation. Based upon this, right. For indirectly, we can go with for identification of and it can be delineated into different aspects like core, forms, and that kind of aspects. This is the broad definition of the in different mineral systems. For geological framework, usually things for diamond, how the framework can be effective for a load board, and this is for how utility of the airborne. How we will for RE. So this is the relevant context. Since the morning onwards, brainstorming session is going on. How geophysics is helpful for identifying this RE text. So as you all know that the known carbonate complex like Ambaradhar, Kamkai, Rajasthan, some part of Sunbali, complex Meghalaya. These are some of the known examples for this carbonate complex. As well as the alkaline and alkaline kind of things, Sivanagari complex kind of thing. These kind of things will be dealt in. I will quickly go through because no many people are going for. So straight away we go for some of the case studies. So how this carbonate complex of Sivanagari complex? These are the typical magnetic resonance. Normally in this latitude, in Indian scenario, it will be southern is higher, northern side is low. But in this carbonate complex, it will be reverse, and reversibility. In that way, we can identify based upon these responses, we can understand certain carbonate complexes. Similarly, this is another extra complex. Similar also, this is a typical response over carbonate complex. This is also another activities. So recently we have published one paper. Similar kind of structure we have identified based upon high altitude data sets. So here similar kind of structure was identified, which is a very crucial. It was lying with the east-west and northeast southwest trending. And some fresh there it is lying significant anomaly, which was very similar kind of nature, which is very much important. Similar resemble on this carbonate complex. It will be diamond. It is below the sediments. So how the response we can demonstrate that the high intensity as well as high sensitivity. So with the same night data, we can use other applications. We can estimate the use of a gradients. This is also a need of the same pyramid data set can be utilized for inverting and for identifying the use of gradients. Then we have attempted integrated geological modeling. How the signature is coming out. Then it is a matrix kind of and high susceptibility. There is a chance of then it was related to genuine money. So similarly, now everybody knows that the thorium rich and monolith sands and RE are exploring and exploited through the lesser deposits. Similarly, we have flown the entire west coast area. There we got this is the mangrove filter or offshore area. Now we have done some exercise how the thorium rich monolith sands and all that. Then significantly, this is the contribution to this offshore data. The southern granite terrain is extending further 20 kilometers into offshore. This is the finding of 299. Then this is the St. Mary's Island, the related of these individual bodies, and another such individual bodies are about 100 kilometer radius. This we have interpreted as the renamed two-path activity. Then these are the structures, how the combination structures are extending into offshore area. The Inaugural pattern structures, these are the individual bodies. And ridges. When compared to the spectrometric aspects, very limited data we know. We know the data. Based upon the limited data sets, we were interpreted. These many thorium rich anomalies were delineated in this west coast. Similar exercise can be done over the east coast in India also. There are already exploration going. Similarly, some more future results can be identified. Then this is for the placement testing areas. Then we are extending this project into under phase 3 category. We want to cover the entire India with the same uniform spacing, even Himalayas also, even Deccan track also. First we have omitted time being, but ministry has insisted that we have to complete the entire India. So, like this Australia, how the aeromedic maps have been generated. So, in NVIDIA also in future, we will be going to generate these kind of maps. So, this is one of the examples. It is the outcome of the black hole. It is a very scanty outcrop, and the entire area is covered by alluvium. We don't know that what kind of basement and below the subsurface information. Then we have done. This is the response of a magnetic data sets. This is the known Ceremonial complex. Since morning onwards, many speakers have then apart from this Ceremonial research, there are another number of structures are brought out by these data sets. I will insights images over the So the PA has identified different blocks, potential blocks. They have given the report, detailed report. These reports are very much available in the media portal. Anybody interested? So we have done one paper. There's a block one data. Or focus terms are in complex. In addition to that, one more structure is concealed structure. Then this is a one completely concealed structure. So this is the main response of this picture. Apart from this ring kind of structure, there is a spectacular magnetic features, linear features for identified. Normally in Rajasthan, tectonic fabric is not a southwest trend. But orthogonal to these many structures, the expo activity has been clearly covered by this magnetic assets. It will be validated. There is kind of potential. So it is abruptly terminated with this ring kind of structures. Then, since it is a covered area, We have attempted the basement kind of thing. The warmer basin is very deep. The basement estimation is from 100 meters to 5 kilometers. Which was very constant with the oil areas. Then similarly, how the magnetic features are going, depth perceptions and all that. These are the subsurface structures from British and to there was some inversion kind of modeling also we have tested. How the structure affected the disposition and the depth continuity. And since that other trend of linear feature, it will be input as a trichome activity. What is that? Third dimension their activity. It extends up to 50 centimeters. It is a good method kind of thing. It needs to be validated. So we try to correlate with Madagascar and Seychelles too far and up to then apart from this new build data sets, we have combined different available data systems. At a glance, the entire tectonic weights and continuity of these things can be viewed based on this magnetic sensors. These are the of the limits and I'm focusing on the region. The known one of the speakers are discussing about Ceremonial. Apart from this, these many new things structures are well delineated to this process. It needs to be validated, stays important from Keynote. So with the detailed interpretation, we brought out this in 5 different structures. Maybe it may not be. So it needs to be validated in just an aspect point of view. It will be studied. So similarly, the linear structure with the next one activity this is our own PSI. So the amount this is exploration. What is conceived? See on that. About this Ceremonial complex. So they got the critical things. As a geography, I have interpreted, I have given demarcated some of the important areas. Based upon the documented also, we have dedicated based upon that, I have interpreted some other room, just for 24 hours. Subsequently, they have built up. With my unbiasedly, I have given some target areas for things. They have also, they got the good results. For this is about one complex. They have also the advancement facility. I will get many inputs. So these are the resources. And ultimately, I will get the alteration kind of zones, which are involving one further. So, another attempt has been done for Kamsai and the Marmon. These are the very important points of view. So, establish known one. This is the known Kamsai, this is the Marmon. What is the tectonic setups and here is the responses in different setups. So, over Kamsai, it is a structurally controlled, which kind of features are there. As Marmon, it is a individual kind of things. We are established. So this is the known Kamsai this is so you see that these are inferred structures. How is the network of living features are forged and within that whereas in modern world, it is its own kind of thing, mathematical element. It was inclusive kind of thing. Then similarly, we have identified some modeling to know that similarly, another, this is very much important. It is very concealed. We don't have any clue, nothing is seen. Such example we have noticed and we are interpreting as we are expecting. IOS kind of mineralization. This is also part of this is the known signature is completely covered by lithium. Don't have any to go outside. So the spectacular magnetic signature is identified. This is magnetic reversal. So normally magnetic reversal we can expect over the extent of ocean with ridge basins. But in continent also a certain extent expect maybe relics of oceanic layers. Right. So normal magnetic anomaly Indian scenario, this is the response. Whereas we are getting magnetic reversals. So here also we have compared that magnetic frequency is covered. Then known geological discussion. We are focusing on mineralization aspects. We have the known geological discussions. Then stoichiometric data also we have weather and we have orbital. These are the important data. These are the depth persistence. Then it was compared with the Olympic dam kind of signatures. Normally in a topology, the gravity signature is variation is not more than 2.5 milligram. At the maximum 2 to 3 milligram variation. Within a span of 10 kilometers, we got the variation of 10 milligram, 10 to 12 milligram variations observed. So definitely the phosphorus was very high density, high susceptibility. So we have compared it. So in foreign countries, this is one of the case studies. How densely they are willing to validate those kind of 90 signatures and all. But in Indian scenarios, one borehole they will launch, no signature, it's not yet giving it to just like that. So that way we are missing out many significant mineralization. So I want to know that how the response is. At least I have reproduced rapid responses. Similarly, these are the rapid responses over Olympic dam. Then similarly, that is wrong. Here also similarly, 10 millimeter variation within a span of 8 kilometers. I have correlated response. If you see that Rajasthan night variation is 2000 ampere variation, whereas Olympic dam is almost then the depth continuity of the signature is going up to 1 kilometer. If at all you want to verify that the signature and the responses, you have to launch the deep secret tokens. But the response is starting from 300 meters. So anybody can want to have a launch over one test program. Single modeling happening. So this is a block 2 or built-in area covering. So here also some of these many blocks have been identified as relatives. These are very much important for launching the exploration. This is the area we are following for my area. These are the most developed activity. These are the responses for below segments also they have been identified the symbolic signatures. That is the below segments. These are the some of the induced bodies also identified. This is also very much important. These are the blocks have been identified. These are the different commodities have been identified. So this is the Mahakoshal area. Here also is a block 3 following Mahakoshal. This is the magnetic response. Here also we got a similar kind of potential structures. That is very pertinent. This is relevant. These many market areas have been delineated based on this block 2. They call different commodities. So this is one structure has been identified in this Mahakosha. This is also very much interesting to see that feasibility of this. So similarly, last year we have flown with our task. This is a Bihar area, Jharkhand and Bihar parts of this one. This completely covered aluminum. But within that also we are getting very important ring kind of structure that is also need to be valued. This is the part of Bihar. So it's the since it is a covered aluminum cover. Or you can have so this is a block code. Block code also very interesting. These are the visual and spectacular features are very brilliant. Because no first time the ceremony data has got fundamental structures. These visual training features are running around 4 to 500 kilometers. It could be what is the nature of these structures, what is the positive sources, when it was formed, these kind of aspects, geological aspects. So it is cutting across all the formalities. Definitely it is a data event. One should maybe the reactivated kind of structure, it has to be validated. These are the structures, these training structures we have inspected. These structures are running for 500 kilometers. In Australia also, these kind of structures are more prevalent. We need to understand. We need to understand the importance. This may be shear kind of structures or dikes. Dikes also, what is the source of these dikes? We are thinking that we have done extensive work also over these kind of structures. But it is not going deeper also. It is lying 500 meters to 2 kilometers at the maximum level. These are the tectonic aspects. So similarly, it is going up to eastern portion also. It is covering up to Odisha also. So similarly, block 8, the southern part of this one is also very high. This is important feature. This is known Kadapa basin. Similarly, the Vindhyan basin also similar kind of big structure was identified. One can correlate both the Purana basins, the Vindhyan basin as well as the Kadapa basin is similar in age. The similar structures we can establish a relation, but it is also considered. These are some of the important target areas have been delineated. This is a recently flown block 6 area. This is falling in Godavari gravel area and some part of road. Here, some have been deleted, but that's the way these are the block areas. Here also the physical training features are more prevalent. One should have any importance of movement. These many target areas have been identified in the 7 road initiative zones. Then I will focus on the engineer portal. How the data sets are available in the engineer portal already. Thank you very much for giving the opportunity.
Thank you, sir, for such an in-depth presentation. But just because of the time, we have to slightly, minimize it. But it was really very enlightening presentation. Thank you very much. Now I quickly request Pujit Bhattacharya sir to please come and present a memento to our keynote speaker, Dr. C. A. Ravi Kumar. Thank you, sir. So now we'll break for tea. I request everybody to please reassemble in 10 minutes. So it's already 4:28, so we'll reassemble at 4:43. Thank you.
Evening and welcome back. So this is the key section, and we'll be starting it with our next speaker. So it's my privilege to welcome Shri J. Dinesh Kannan sir, who is Chief Superintendent of Project South at the Corporation of India. So, I'd like to introduce him with a brief biodata. Shri J. Dinesh Kannan has obtained B.Tech degree in chemical engineering from Southern Engineering College, Inaugural, affiliated to Anna University. He has 16 years of operational and commercial experience in plant and projects involving atmospheric acid and alkaline alkalization. Shri Dinesh Kannan is presently working as the Chief Superintendent for the South Department of Chemical Energy, where he has made the contributions of active involvement in stabilization and commissioning of the blood. So with this, sir, I request you to please give your name. Thank you.
This is how we the mix of boosting levels. Initially, AMP, the mandate of the AMP is to give us the resource and process and the metal is there and it can be reached out or we exploring and make the process with the move it like that say. So we have 3 months. So initially and in 4th October 1967. Subsequently, we have 7 mines in Jharkhand and one in Tabali, and we have got 3 processing plants in two are there in Jharkhand and one is in Tabali. And these are the chronology of how UCL got to and stage where we have our uranium productions and with the establishment of mines and mills. And we have we are now eager to have a JV with the establishment of this Tamil in Tumballi, through which we are expecting to increase our production of uranium concentrate by 1,400 tons to the current UC concentrate. And these you already know what is the results that are available with us in India. And this is the history of how the plant we have the plants at Jalabura. It is the first plant in which we have strong process of uranium with the initial capacity of 1,000 tons per day, and subsequently we have increased the capacity by 1,050 to or 2,500. Now, at present, our license capacity is 2,090, and we are awaiting clearances for commissioning it to 2,500. And these are the other electronic plants and other installations which has been set up in Jalabura. And this is the capacity of SCM. We have commissioned it with 3,000 tons per day, and it is the most economical plant which is running in India, because we are able to process this Bengaluru mines, even though the was much sweeter, but we have around 70 to 80% efficiency there. So we are working on the lowest cost. And the one million ton per day is also waiting for clearances. Subsequently, we will process the 4,500 tons per day in Colombia. And this is the Tungapalli mill, which was commissioned in 2017. We took a lot of time because the technology was available. And the process which was covered was from 470 pm. And when we started mining, we got some leaking ore. So due to that, we couldn't reach the concentration. Due to the concentration, then subsequently with the BRC scientific methodologies system, we could establish now, and we are able to achieve 70% recovery at percent. And we are planning already the Jigan of the be has been given by AMD, and they have submitted into DOD. So we are planning to put a 900 for 10,000 ton per day. And Kannapalli also we are exploring. We are planning to put a 12,000 ton per day as setup at Tungapalli. So we from Andhra itself, we are planning to give around 1,700 metric ton of lithium weight. And this is the mines which is dropping into the smooth of the mines of Jharkhand. And that is connecting Dharwad and Jalwada itself. And these are the main which are being used throughout the mine. And this is the standalone mine which is feeding to enter the mine. And this is the basic process difference. Because the Tunga Jacob is rich in silica, around 62% of the silica. So it is this is the gas which doesn't react much with the acid. So our reagent consumption is very less. But compared to Tungapalli, almost 79 to 83% is carbonate. So when we go with acid process, the consumption of synthetic acid. So we have opted for this carbonate bleaching. In the entire world, there are only 4 or 5 countries which are adopting this and we have demonstrated and we are running it efficiently somehow. And here, what is the basic thing is our unity movement liberation size is 74 micron. So we have to grind it from infinite size to 74 micron so that we can our region can come in contact with the and which can extend down. In acid leaching, the missile grind, that is the grinding 71 micron can be up to 60%, because acid can have 70% has not the penetrating capability, so that it can go to begin the metals also and emitting more. But in further grinding, so here we have to grind into around 85 to 90%. We have to grind so that all this carbonate solution gets in contact with the uranium matrix, that is atomic matrix, and it can only break down uranium when it is in there in the surface. And here in acid flow, what can we do? Once the uranium comes in the solution, we can associate with iron. But it is not possible with alkaline, because already the concentration of total dissolved solids are more. It is due to the presence of iron, which reacts with oxygen carbonate and makes the solution high with dissolved solids. Here you can have around 250 dissolved solid will be there, so it is not suitable for addition. So here we have opted for high precipitation. So initially what the problem we faced was we had a concept level of liquid which is subjecting it for precipitation. So what we have done is we have taken out some of the precipitate and we have dissolved it, and we have started feeding concentrated liquor, that is constant liquor containing 2.5 liter. So that the precipitation efficiency is good and we are in the better position. And here we after recovery of concentrated uranium, we have received the uranium in the form of uranium peroxide, that in all the target units we have established this process because it is the purest form of uranium concentrate, which is produced in the entire world. Either when concern also, either they give you the form of unheated uranium peroxide or uranium or UC. So we are also planning to give, in Tumlapalli also we are planning to give uranium in the form of heat treated uranium peroxide so that our industry doesn't face any problem with processing uranium. So these are the things how we are differing in all the three things. What are the difference and how we are processing here? Everywhere the size reduction is there, and these are the parameters which are present. And we receive over like this, and subsequently we do the three stage of cutting to this. There is some 25 mm particle, which is further down to 74 micron particle size. So this is subject to the what will be. Then there is a size circuit is there, that is hydroxylon. After that, these are the intervals of the mix, and these are the mix. And given 74 micron particle separated size. And these are the dewatering units, because after blending the whatever the solution which we are getting will be in diluted form. So we have to increase the bulk density. For that, we are using different type of dewatering equipments. The only thickener, disc filter, and horizontal vacuum bulk filter. To which we will be able to increase the bulk density up to 80% solid. Then to that, we will be adding some lean liquor, lean uranium liquor, which is generating the bulbs. So these are the three type of leaching equipment which are used in India. One is Pachuca, which is air agitated leaching tanks, and this is the CSTM, that is continuous tank reactor, which is agitated by mechanical means. And this is also both of these are atmospheric leaching, and here it is autoclave leaching, because we have tried the Tumlapalli. If we go for atmospheric leaching, we are able to only reach up to 65%. Now we are able to, with autoclave leaching, we can increase at present we are reaching up to 82%. And we have given task to PRC to check whether further leaching can be done, because in all of the gold, nickel, metals and all the pilot is there, they can go up to 90% leaching. And we have given them job for recovery of moly, and not only moly but through fluid process. Vanity is also there, but we have not done. But we are expecting more, because it can be easily removed by the fermentation process. And these are the internals of autoclave. It is the biggest vessel. It is 720 meter cube, and it has got everything. Internals are about internal 600. And these are the basic reactions in which through which all the tetravalent uranium is H7 uranium. Then it comes from the solution. Then subsequently it is absorbed by the ion exchange testing. Further it is precipitated with the help of hydrogen peroxide to make it as this hydrogen peroxide, uranium peroxide will be further calcined to make it UO3 and H2. That is the heat treated uranium peroxide, which we send to NFC. It will have 92% everywhere. And this is the alkaline group through which we are doing this. Initially, the concept which was developed by BRC, we had initially thought of we had to put both sodium carbonate and bicarbonate. Later, there was excessive generation of bicarbonate, because this is the bicarbonate which is generated, which is essential for to avoid the precipitation of uranium, because here in the initial reaction itself, energy is generated. This has to be neutralized with this, or else after leaching itself, this uranium going to precipitate as a sodium carbonate in leach liquor itself, so we can't recover. And these are the type of filters which we use in plant for removal of the uranium liquor after leaching. And this is the cake which will be disposed in the lined daily one. And here we can see the difference in color. This is for through acid through and this is through alkaline through. This fellow due to the very bad oxide coming. Because oxygen and carbonate has reacted with pyrite would bring this color. And this is one of the indicators that everything has happened effectively. Now the pyrite has not leached out. And after filtration, there will be the 2000 ppm of silt will be there, which has to be further removed, or else it will provide. So that can be removed through this frequent filter. Basically, this is a sunlight, which is volcanic glass, which has got minor pore within it. It is used as a filtering media. There you two separate filter media. One is this filter media. Above which this will be there to give a precipitation. And this is the precipitation. This is the ion exchange which is used in jacket, and this is the precipitation. After this, here also precipitation tiles will be there. And there is a one step concentration rise is there in Jharkhand in the film of exchange. We don't have here, we do direct precipitation. And this is the uranium peroxide which we produce. And this is the sodium carbonate. At present we are producing. Later, after 1 year, we will be converting into Tumlapalli also the same product. And after precipitation, what we do is we wash to remove all the soluble impurities. We atomize it, calcine it to make this concentrate, which is something else and to see. And all the things which is there, we do sand separation for back cleaning mines, and we require maintenance also. And maybe we require maintenance and send it to core watery for heavy cleaning separation. And this is the dairy bond in which we put all our waste, because almost 99% is waste. In sense of still we recover some sand for backing of the mines. In Tumlapalli, it is at present it is not there because we are already doing 89% sand from it. And we after for that we put our tailings in a line, double land structure. That is dam. Beneath this, there is a 1.5 meter imbalance there, which has a permeability of 10 to the power of 9 meters per second. Above 1.5 aluminum sheet, NGV sheet is there to have a double protection. And all the solid settles and only the decayed liquid reports, which is further processed within the plant and recycled. And within the ETP, after the treatment for radium and all the heavy metals, then further we let the when it meets the prescribed limits to the removal. Thank you.
Chris and the very done the completion of the lecture. It was very informative, especially uranium we are exploring. So any metal we are exploring. So what is the next stage? The mining stage and the processing stage. So that is the next step that we have inserted in greater detail. Thank you very much for that. Now this map to please give unmet to our keynote speaker. Please give the image dance. Thank you, ma'am. Thank you, sir. So now we are on the completion of today's workshop. This is the last lecture. And it's my great honor to introduce our final speaker, our very own PB supervisor. So I would like to just tell a brief biodata about our speaker. So he is former in charge of data investigation, Atomic Minerals Directorate for Exploration and Research. Sir is an eminent exploration geologist with 32 years of experience in carrying out exploration.
The project.
And the way he was working, I understood that was always something. That's the kind of so there is an eminent exponential geologist with 22 years of experience in carrying out exploration for uranium and other atomic minerals in various geological domains in different parts of the country. He has obtained MSc degree in geology from Bengaluru University in 1986 and joined AMP at Northern Egypt in July 1987. Sir has been associated with uranium exploration in 4 different geological environments. Their concern was instrumental in locating single-time mineralization in Indian and Kalpuri lavas and associated with apatite magnetite beads in more than 25 locations along the Bush. So, for the first time, conducted hard rock exploration for rare metal and rare earths by core drilling in mineralized pegmatite in Malavella in 2013 and estimated interesting results for uranium, tantalum, beryllium, and lithium, which further led to the continuation of the same till date. So, it was also associated with spectrometeorological investigations for identifying and characterizing uranium and RMRE metals and residual stocks and has been confirmed with Group Achievement Award 2015 by Department of Atomic Energy for exploration carried out in Malavella sector, Madhya district, Karnataka, for establishing RMRE mineral formation. So, it has published 20 scientific articles in renowned national and international. So, with this, I request the sir to please come and deliver his lecture on rare metal exploration in India with a special reference to Sunderland.
Thank you, sir. Good afternoon. I thank our director on the chance for giving this lecture on the new topic. And even after the 5 years of retirement, I will not give forward that I'm very imagine and making good. So, on exploration for this. Sorry, getting the elements. Boron in the called as elements. Why they have been called as elements? Because of the discovery and they were thought to be occurring in this Paris material and they are in different certain process and in recent times they have been much different state. So they are called as rare elements. These are the characteristic properties. They have been grouped into 5. So the rare elements, rare organic elements, first group, very lithium, rubium and cesium, where light elements, where high melting elements, thorium, thorium, where elements are in magnetites, indium and scandium, and disperse elements in mostly in sulfides. There are a list of elements there. So, for the content of ULS for GMP, so uranium, tantalum, beryllium, lithium, cesium were designated as rare metals. So this is the where the position of the elements are shown. So this is the fixed state of uranium and tantalum. So they were being found in so uranium was initially called as uranium and it has been reused as uranium in 1950. So they have a similar valency 3, 4, and 5. Most of the uranium tantalum occurs in pentagonal state. So they are lithophile, cluster abundance, is at a brutally and lithium respectively. That is the significant tantalum maintains at least to 1 ratio in occurrence. They are highly concentrated in the rocks like carbonate, algerites, granites, granite, pegmatites. So they have the character of isomorphous soils, which are diabetic characters. So they minerals occur largely in six isomorphous series. There is the polyamide tantalite, one series. The first one being the cobalt, and the other second one being the tantalite. Polyamide tantalite, pyrophore, nitrolite, glycinite, polyphene, wolframite, permanentite, samostrite, hydrotantalite, and aconite and pyrrolite. There is one more independent mineral that is copper. So you can see the decomposition. So that is why the minerals are called isomorphic solid solution diabatic characters. So they have similar crystal structure and similar chemical formula, and they will substitute very extensively by one another. So these are the
next.
beryllium. So this is the atomized form, and it has very lowest ionic status, that is 0.34. That is the reason why the beryllium is not found in other non-forming minerals. So it will form on the middle of its own when it tends to concentrate in the extremely, fractionated fractions of the metal. So crystal abundance is 3.5 ppm, and they have, aluminum as to some extent as the geophysical analog. Otherwise, there is no geophysical analog for beryllium because of its, very small ionic radius size. So, beryllium accounts about 75% of the total beryllium resources. So these are the different minerals: beryllium, hematite, pentandite, and pentandite, chrysoberyllium, barite, hematite, and pyrite. These are the main minerals. So among us, beryllium is the most abundant mineral that occurs in differentiable hematite granites. It is a lithium. Lithium enjoys another factor. It is the lightest of all elements. So valence is 1, extremely lightweight. So 29 of its crystal abundance, closely associated with soda. So that is why it goes along with the organic elements. So lithophile element concentrates in the last different of the granite complexes. So lithium and carbon. So minerals, there are 6 major minerals. So there is thorium, pyrrolite, graphite, and cobalt. Brines account 66% of the total reserve of lithium. Granite contains about 6%, and stability of the resources. The minerals are standing without so generally, the permanence contains the manifest because but the forms of the mineral will be environmental or storming. Thanks. So this is the it shows the alternatives of bare metals in geological economics. So you can have the details. So these are the applications of in different scientific industries. So what are they handling? So in order to that can use it is the element when that want applications. So you gas turbines might be a reactor. So it has cameras in the laptop and you don't have electronic council, they have a tandem fundings. So these are the other communications. These bare metals are used in size, dynamic systems, cell, angle service, service, and communication system. So they in the nuclear field, these elements of them, etc. are us and steel allies, control rods, fuel tubes, and etc. So this is the communication satellite airways, automobile system, and sites and mainstream. Lithium applications. Extraordinary, because of its extraordinary lightness, lower conductivity, extremely high reaction ability, and abilities to mount the rise with lithium, copper lag. So it's a big 50% of its batteries, and 50% ceramics and glass, good into a person, 5% in medicine, fabrication 4%, almost 4%, metal 50%, in other applications 9%. Right. So because these elements are being called stability and failure. We explained very simple earlier. So because of the high demand, uncertainty supply, and no substitution by any other elements. All the very metals. So highly metal this can be enriched in the regular methods of restoration, pressure, presence of all type, particularly floating, extends the range of restoration temperatures. So the enrichment of all types in the system, the lower the temperature and mixture of mineralization increases. So mineralization suppressed until the last stage, fluids activated and the enriching of pure metals. Metals typically occurs in the highly evolved bonds, both magnetic and hydrothermal purpose. They contribute. So they contribute magnetic is very wicked about the very magnetic hydrothermal range. So they contribute for the mineral very come phase 2 and very system. The relevant mineralization of great economic content are occurring in three major individual rocks. They are chronotypes associated with the alkaline rocks, alkaline to unorganized granites and synovites, and very metal granite pegmatites of LCD. LCD is nothing but lithium, selenium, and tantalum, leading pegmatites. These are the family which is classified by the Peter Setting. So, these LCD type of pegmatites are for the potential area of lithium, tantalum, and beryllium. So these are the different host stars which are different groups of elements. For example, lithium, beryllium, are hosted by magnetic sunlight, organic rocks and layers. Whereas LRE, lighter layers and lesser tantalums are hosted by carbides, organoids and lasers. Heavy layers and lithium are granite, granite and lasers. So uranium, lithium also occur in granite, clay, bauxite, manganese, and brines. Exploration for their metals. Some recognized such as 14. So they are exploring on 4 stages. First stage, identification of host star, evaluation of the host star, and soil and gravels, and recovery of the mineral. Coordinate areas are selected based on information about the survey. And interpretation of survey images and the aim of the photograph. Interpretation of this information. So satellite images and the area of photographs will be in identifying and the integral nature of the granites, the complex nature of the composites. Minimum common will help us in ground locating anomalies. Because most of these are containing, I mean, larger filters, smaller to larger extent of bureaucratic and magnetic growth of carbon is very much high and magnetic growth are actually helpful to by spectrometry. Because treatment is continuing important for exploration. Sampling of sediments and in-situ files is a magnetic determinant to isolate potential area. Isolation of mineralized targets allowing the examination of the granite beast. So various groups for geogram, lighter valence and carbon Carbonatites are the major sources for uranium, lighter valence, phosphorus, chlorine, titanium, rhodium, copper, nickel, etc. Bengaluru, basalt, apatite, fluoride are major sequence. The carbonatites are engaged in manganese, strontium, radium, thorium, and uranium, and integrated multidisciplinary satellite imagery, aerial photograph, airborne dominant spectrometry, to collectively responding, ground locating, and source carbonites, problem under exploration tools. Geological techniques are excellent tools, magnetic and gravity sensing. The conquest of Australia has been identified the electromagnetic survey, Since and remind can also identify those numbers from gravity anomalies. Kilometer space payment sampling is another, as it is said previously, is very important and very cost-effective method for the sampling. So, carbonites has neural tantalum, lithium, lambda, selenium, thorium, lithium, smartphone has carbonite elements. Those sites derived from carbonite are going to contain the transfer minerals. So, again, carbonate both the deposit of British Columbia has been identified by identifying the content of carbonate elements in the 2 to 125 and 60 microxide fractions of the size. So, one because of uranium already so, I would really this. If you take any again, they have another place. Still at other places. So, enrichment is source or large deposits for especially. Second is residual size are enriched. Assessing the residual size and systematically will help us delineating the story again in the movement locations. So, in absence of the residual size of surface exploration, in absence of the size, subsurface exploration is to be carried out. So, major source for uranium and tantalum. Carbonites contain 95.5% of uranium. Where lasers derived from these objects contain 0.20% of uranium, and the lasers which are derived from the granites and pegmatites. These are 61% of the total tantalum. Well, pegmatite contains only 0.1% of uranium, about 39% of the total tantalum resources. So, granite carries only 2.62% of uranium and 0.02% of tantalum. So, diagnostic features of carbonite. These are the three aspects. Increasing, so they have the data of increasing nature. They are as things like forces, like bodies, and rarely volcanic forms. Especially related to major tectonic features, or they are associated or evidence around the major winds and faults only. Technologically, it's a number of on the way, on the basic type functions. Characterization with number. Maybe complete or partial characterization. Sodium and potassium independently observed. So typically, the other typical methodology is appetite parameters global are the typical methodology. Usually, they are enriched in place elements of strontium, barium, zirconium, uranium, phosphorus, chlorine, iron, and thorium. Since the isotopic studies of carbon, oxygen, strontium, neodymium, and lead indicate that they are derivatives. So exploration granites. Fertile granites. See, identification of fertile granite is very important. The rare metal or rare metals type should be a fertile mine. Fertile in the sense, fertile with respect to the incompatible elements. So if you have meditation into the fertile, crystallization pegmatite type. Identification of parallel and parental fertile granites for exploration is an important exploration tool. Different, they are these fertile granites, they differ in the chemistry because they manufacture with respect to the barren or utilized granites. They are present large compounds and rapidly. Significantly greater than 10 square millimeters they are exposed. They are seismic and paragonous in geochemical nature. Aluminum rich minerals are conspicuously present in the form of muscovite, garnet, and chromonite. So many applies are often found in the fertile granites. Including iron, manganese, and calcium, variable K2O by NO ratio. N3 are vitamins of oxide minerals. So they have some index minerals. They contain primary being muscovite. Apatite, cardiovascular, and variable anthem and proceedings. Yellow ones contain plectrophenolide and lithium bearing graphite texture. They are different from the brand in the texture aspects. These liberalized granites, that they contain the constant metals have the graphite texture. So they have sort of muscovite, they have the graphite texture. So basically, this graphite texture is identified in the so increasing classification, the fertile granite from the deeper to the shallow level is as follows. The deeper places is private granite, followed by 2 miles granite, and then that is followed by porcelain muscovite granite, and then pegmatic granite, which has some applied connections into that, and then the oil of bare metal being pegmatites and then higher ilmenite works. So this is a schematic representation now, the fertile granites. So residual granulated granite length, this is how the pegmatites, pegmatites are formed. The residual granite length pinpoints some of the fractures and falls into the roller to form the pegmatite granite. Increasing the fractionation is increasing the distance from the source is a characteristic. Increasing RE, the complexity of internal loading and the extent of formation of the characteristic, physical and external characteristics of the rare metal bearing pegmatites. In increasing distance from the pegmatites contain the following index minerals. Pegmatites closer to the source contain only as the index mineral. As you go further away, it will be very ferropolymer. So you travel further ahead, very narrow. It can be ferropolymer or it can be nanotandamide. And these rich minerals like spodumene, metallite, or levirolite. So the other one is nanotandamide. The first ferropolymer appears as the main migrate for the root source is into nanotandamide. So nanotandamide becomes a challenge elements and produces from here and then distant. So this is the schematic representation how the engagement takes place and the movement also changes the distance of travel of the length from the source granite. The pegmatite sites with the greater economic potential, they are typically distributed over 10 to in the Peters area, unlike being single for or pre-existing rather contacts are low randoms of the both crop. Largely related to food and generally they have the two things. Zoning can be significant or significant. So both part of the upper basis and lower unemployed basis of the above time within the class of the so have very low potassium for lithium, potassium for lithium, low amount of tantalum, and magnesium by lithium vehicles are the indicators for the primary pegmatites. Magnesium by lithium ratio that is consistency. It is the best indicator for the degree of highest tolerance vaccination. And it meant that the formula they metabolism RE sometimes at least 3 times high of the normal granites. So people must go are enriched in and fixing. Garnet becomes enriched in manganese and abundant in chloride. Variants are common forming minerals with the elevated content of RE in fertile granite is often the main proof for the existence or occurrence of bare metal pegmatites in a particular provenance. So, while the drawing came for which is at more than 300 ppm, KYR less than 30, and greater than 100 ppm of Cs are the best indicators for bare metal pegmatites. The abundance of color of minerals and matching the minerals are not preferred for the searching of bare metal minerals. Because these elements are very concentrated at the time of growing mineral formation, so that the residual gain are depleted in the bare metal. The low grade component is an indication of in candle. And the rose component is an indication of cesium in the pegmatites. So these are the classifications. So these papers are modified after Ginsberg of 1977. So he is a genetic environment based on genetic environment. We have divided the pegmatites into 4 classes: abyssal, muscovite, element, and magnetic. So this is another classification. It is based on the pigmentic aspects. He has classified the range metal-bearing pegmatites into LCT, MIL, and NIC. And we say LCT indicates for lithium and tantalum. MIL indicates neobium, lithium, and thorium. So generally, the granites of AI is a into the MIL type of pegmatites. Whereas LCT are the granites, which are not depending on their granites, will result in LCT type of. The other one is Hindu. So you have a geochemical signature from both LCT and MIL. So this is the two-day depiction of stone pegmatite. So hard stone is the center, followed by intermediate zone, then border zone, and the wall zone. So the margins between the wall zone and intermediate zone, none of these bare metal are concentrated. So in many of the mineralized pegmatites, there is a zone called ornamental zone or mesomagnetic zone. So that is called secondary ornamental zone. So that is when generally found in bare metal living pegmatites. So that how to evolve the bare metal living pegmatites, how to evolve the bare metal living pegmatites for their bare metal potentials. Detailed geological mapping has to be carried out. Delineating pegmatites and their gravel zone, systematic bulk gravel sampling and regular intervals, hand planning and storage of bare metal minerals, computation of and delineation of potential bore zones, estimation of reserve, and the effect of bore, and collection of the mineral through gravity concentration techniques. No chemistry is involved in there other separation as far as mathematics are concerned. So coming to the type function, brain matter sources. So the carbon type, the brain matter deposits, it is accompanied in types. Carbon deposits, brain matter deposits, carbonate, posted, secondary deposits. So Inaugural and Mocha out in Canada are the examples of the first type. And Saraxa, Bengaluru in Brazil, Oka in Russia, Russia in Congo are the examples for the second type, that is the secondary deposits. So rare metal deposits in carbon types. So locality, you can see Alexa Tepera, Ceremonial, Oka in Canada, Monolith in Australia, Rima in India, Flora in North India. See what things. So about 80% of global resources are in Brazil. So Alexa owns 464 million tons of uranium, and followed by Tepera, Catalo, and Science Global. Science Global is the largest gold deposit as of date in the world. So that contains 2,887 million tons of gold from gold with 1.18% MD2 by average grade. So these are the red metal and rare deposits in India. So found in both hematite beds, granites, and thaumatites. Major RMB carbonates of India. So it has been spoken very widely right from morning. So in Bengaluru, Ceremonial, Samapatti, Pakanalu, Lokadu, Gujarat, Amritsar, and Rajasthan, Inaugural, Lamsai, Meghalaya, Vasu, and Assam, Samshanti, and Bengaluru and Bengal. So this is the so this is the major dynamic and engagement of farm type bodies. Farm types of technology. So as far as farm types of sovereignty is concerned, farm types occurring in the Tamil Nadu are mostly important. They are only found to contain them. About 35 farm types occur in the world. Identified in Southern India, most of them are rare but minerals of it. And they are in Tamil Nadu, Sevathur, Samapatti, Pakkanadu, Munapadu, and Odmika are the major farm types which carry good concentrations of these minerals and organics. Which shows the development of our bodies. So we are speaking an anthem for the so several conflicts. There was no some of the important characteristics of the conflict. Because identified in 1960, it is one of the alternate conflicts. Along the northeast south of the spending 20 kilometer according to 50 kilometer away to the Atomic Minerals. The fourth conflict is an these are the properties, and the Monolith, quantized, European prototype, apatite, monolith, and chloride are the most famous carbonates. Explored. So this sound data has been explored by AMD. Utilization has been identified over 500 meters strike length and up to 2 meters. Thickness of the work zone 0.5 to 1.5 meters. So then an average we have 0.1% by the slope. World major rare metal bearing carbonates are located in Canada, Australia, and Brazil. This is the where LCD type of carbonates are shown. So they are the major LCD type carbonates where iridium and see, as far as India is concerned, we have 5 locations. One is Rajasthan, Meghalaya, the other one is China, Meghalaya, the other one is the Western Machinery Carbonates, Bengaluru, Meghalaya, carbonates from Canada, They are pure pegmatites of Odisha. These are the most important pegmatite sources and available in India. More potential and economic growth for rare metals, pegmatites of Karnataka. So this is the pegmatite in Karnataka, the most significant emphasis where the rare metal potential is concerned, especially related to the superconductors of the people. And the younger so most prominent pegmatites of the country from Canada are anchored in the Karnataka. The fuel systems on circle group contains significant rare metal information. So majority tantalum rich and spoiled goods, no lithium minerals. So majority of tantalum rich is pegmatites. Majority of them are tantalum rich and spoiled is the no lithium mineral. Whereas the pegmatites of other rare metal regions, there are the mixed either neogen grounded or neogen tantalum equal. And lithium is represented by the mica, lithium mica, that is thorium. Whereas in Karnataka, the pegmatites are tantalum rich and lithium is represented by spodumene, not the lithium. That is the very difference in the pegmatites. This is the Karnataka, here you can see the about something where the pegmatites. So this is the part of the southern Karnataka, where pegmatites are occurring as into the seabed of southern time. So this is the geologic number. Alavarna, Monolith, and where our exploration of this in progress. So here the exploration is both surface and subsurface. So here the nuclearity has been identified. There is one by Atomic Minerals Directorate in 1976-77, by one of our previous directors, Mr. He also identified the mineration, training R&D and from land and. So here, later on, the very he was identified in 1980 and thorium was identified in 1989 by Sri Devi Krishna. So these are the rare metals. So here you can see the occurrence of polymeric analyte and spodumene. Here in this particular the left side you can see spodumene. One has in the right, the other one is second. So it has an encryption between the types. The system same. So there, I mean, they are occurrence in the pegmatites are so the name super started. Islamic arbitration and guidance are very important for they are very significant structure significant beside the pegmatites. Monolith, candidate, catalyte, microlite, very much the major rare metal metals. It is a density type, very density family. Okay. So this I have said. I mean, there have been both exploration means of surface and subsurface nature. First time in the history of AMD, the hardcore, I mean, the hardcore thinking of pegmatites has been carried out in 2013 and still is in progress. This is another system which is more than system. This is the second more resourceful system where I mean, the former catalyte has been figured or collected from the pegmatites. It is second potential of the Monolith. So other importance are they have been shown in the three different places. One is from the space in so these are the pegmatites, the
relatively younger, the oil rest. So pegmatites are the Bengaluru, the pegmatites are belonging to SRF, and there are in the multi-mineral character, and they are mostly uranium, not comparable with the pegmatites of Salah. So this is the chromatic line is also one of the very important pegmatites of Salah. Here, right from 1957, exploration is going on in India. So people have looked at the place technically, and the area has been explored in different methods. So these are the different pegmatites. So pegmatites are found the place mostly outside to the Delos bed of air, including white. They are known for muscovite. And occasionally, Bombay candlelight has been handled from those pegmatites. So these are the right. Thank you.
Expert of bare metals and is not for the subject is with on the stage, so I need not to say anything. I will quickly request another set to stop and send them to provide the notes in the Thank you, sir. Thank you. So with this, the lecture series for today's workshop has come to an end. The perspectives and data presented today have enriched our understanding of the complex challenges and promising opportunities in this critical field. It's clear that the exploration and development of strategic and critical minerals play a vital role in shaping our country's future energy security, technological advancement, and sustainable growth. Now, as we come to the concluding part of our workshop, we now open the floor for feedback. We would like to hear from you your feedback, thoughts, and takeaways from today's session. We would have loved to listen from all the dignitaries present here, but due to the shortage of time, I will invite few dignitaries from different organizations to present and share their views. But I really want to request all the speakers to be very brief, just take 2 to 3 minutes, and please give your valuable feedback. So firstly, I will request from DMD Karnataka, Shri Harish S. sir, to please come and share his feedback.
Yeah, I was taking time and it was very informative and gave all angles of strategic right from exploration the end product from the idea. So it was really informative and we would like to, I personally would like to suggest that few case studies centric presentation of workshop will definitely help and take up for colleagues and I feel. Thanks.
Thank you for your very informative feedback. Now the request from GSI, Shri Rajesh Guraiser, to please share this feedback.
Now we are going to end up the session. Excellent, Aurora, well organized and well planned. I conducted the workshop. I thank all the organizers who involved this workshop, and I also thank the AMD authorities to inviting GSM along with team members to participate in this today workshop. Actually, today the workshop is covered most of the topics, starting from the Ceremonial sir, Tirupati sir, This covered all related to the workshop title. I can say some few of the topics can add regarding this forest guidelines issues are we have nowadays we are facing. I think already touched some of the points. You can go from forest officers, you can call for this kind of workshop to present the amendment, recent amendment. It is one and I think there's some case studies, like what I used to do. And the case studies is very important for the youngsters, those who are recently died and joined in this department are very useful. The case studies, how these exploration techniques are adapted in recent advanced techniques. That is most useful for them. Otherwise, it is one of the very good opportunity to share our views amongst our other stakeholders. And you can pick up some of the right one, we should take some of the collaborative items, which is the DSA along with CMD nowadays. DSA is taking a collaborative item, CGWB, and the VCL and other items. Like now some R&D project tasks we can get, particularly in the CM team, the big learning strategy. Otherwise, it's okay. And coming to the now, one thing I want to discuss the engineer. Rightly, because we are a model influence of the engineer. You have huge data. In fact, going to see the exploration data as soon as the geological data is there. You can, it is one of the opportunity you can go and check and you can grab the data and you can work out the future aspect of it. Otherwise, you general, say, the RE means people are doing only carpeting. It's not like that. You don't look for someone that the government soil is there, regulated soil is there, and now the time now you look for strong carpets. You cannot go a single commodity. But we are going to are unless for it's not like we are unless for all the critical studies in mineral analysis. So then we can strategy and the critical movements. You are analysis. And wherever you are working the exploration project, you can analyze all the strategic and physical matters. That is one of the main first media. Otherwise, today's workshop is very nicely conducted by the thank you all.
So your suggestions will definitely on and will be taken up. Now I request from AMD, sir is already ready. And then sir, please come and share your valuable feedback.
It's a pleasure to be in the city after a long time and moving to the day-long of the strategic and critical challenges and future prospects. A wonderfully organized symposium, a workshop by AMD, which is extremely timely and when India is looking forward for a major breakthrough in R&D activities as well as with the higher economy that India is looking forward. In this direction, I should congratulate AMD for timely organizing this beautiful workshop. Well, this is not the time. I have read an elaborate summary by each individual presenter that they have deliberated through, including those two stalwarts who participated in the petition from outside. I should thank Mr. Ceremonial to give a wonderful thing on the outcome strategies on this what we call as critical of
this our country. Ceremonial in lecture, very nicely summarized and gave a brief insight into the problem of critical matters as well as Dr. Bullet Parker in his talk on the forward in the strategy of single something difference between what is critical mineral and what is strategic mineral. So very, very sensitive issue. And very nicely we brought out the difference between these two is important, although there is a about the terms of minerals. So I should contact with Pandey on this very clear understanding of the subject and who plans to have the approach of these critical minerals in India. Dr. Krishnamurti, of course, a man of alkaline rocks, as I know, started with the Buddhas, and also my guru, because both of us joined together almost. And here, I should mention scientists who contributed to the rare and and other extreme Brahmins are teachable tribes have immensely contributed to the recovery of the resources. Of course, I have made a detailed thing which I don't want to share on this stage at this point of time. Mr. Bhumra emphasized the importance of crystalline rocks and hard rocks for the recovery of and I should congratulate the user for bringing for the first time an express training carbonate, which is for the first time in the Western Harbour Qatar, a carbonated rock has been identified. So towards this, I think it will go on a new chapter into some of the identified that one identified. This is a very, very important thing, and we have that. That will go on the editing chapter in the carbonite in India. So in this way, Mr. Rajesh Gurai and his team needs to be significantly congratulated. I also thank Mr. Harish, who is from the Department of Mines and Geology. Just slightly, it's not fish out of the water, but he talked on the wonderful, so many refinements in the MMDR Act, so that we will all be aware that where exactly and how exactly we have to go through some mineral exploration. Of course, for atomic minerals, you have one this thing what is called the Act by of 1948, which has a certain amount of relaxation on the number of zones that it has to drill and other things. Then Mr. Esther Verghese, of course, in the aeroplane spins, he would go on authoritatively on the uranium dominance in Syria, because on the uranium dominance in southern region, he was working in the Bangladesh department in India as well as the US department in Monolith. And Ravi Kumar, he gave a historical perspective of airborne surveys that have been carried out across the country, and particularly the importance of high resolution airborne
geographical surveys and their significance, which is very, very important. And this should not be restricted to only making a speech on the stage, but it should be translated to action when it comes to replace the program finally. I think in this way we should have a synergy between different organizations. I think the director AMD, Dr. David Pandey, sitting here should take some. That is about we were all doing only in my time only the geographical surveys of BRD. So the next was a very interesting thing and a very crisp summary of how we did uranium leak in proceeding by Dinesh Kannan, where both the two university plants of planting and other uranium deposits of single circle, as well as the comparison between tomorrow alkaline leaching. I would like to give one day the tomorrow alkaline leaching plant because I myself worked there. Then of course, lastly, as a very, very interesting thing, in Tirupati, development is summarized the entire mineralogy, geochemistry, everything, and also its department. I wish Tirupati should be given an opportunity to give one who will just be because that is really important because we have done an intensive work. I know Tirupati very well, and even some of these field experience as well as knowledge is shareable amongst youngsters. So lastly, I should thank again the Director AFU, Mr. Ceremonial, and all my senior colleagues who participated in from outside Dr. Krishnamurthy and other people for inviting me and kindly inviting me to share this workshop and also giving me this opportunity to talk to you. Thank you.
Thank you very much, Pandita. If we look into this auditorium, the younger batch, the main majority is at the back, and the relatively older generation is in the front. But when it comes to energy, I see the reversal. That has listened each and every presentation so vividly, so consciously, and noted feedback for each and every presentation. Thank you so much, sir, for your valuable feedback. So it's really so, as you all know, that our regional director, Sri Cindy K. Vargas, is laying down offers in detail on the occasion of the superannuation. Beyond the achievements and accolades which we already discussed before, what truly sets Vargas apart is the legacy of mentorship and integrity that he leaves. A legacy that will continue to guide and inspire us, especially the youngsters, for years to come. Today, we take this moment to felicitate Sri Cindy K. Vargas for an outstanding career of dedication, leadership, and service. Your contribution, sir, will be remembered with great respect and admiration. Now I request our Jagdishan sir to please accompany Vargas sir and our Director AMD, Sri Neeraj Pandey sir, on the dais for this felicitation ceremony. I request Alpha to please adjust.
Thank you. So, the felicitation as such is not only from southern region, it's from the entire AMD for the excellent contribution. We have been closely associated, we were together in Jaipur, then in southern region, and as I've said in the morning, the entire AMD congratulates for breaking out Sevan deposits. Well, he is the real discoverer of those, like Ceremonial complex, like today, India is hosting one of the very few HRE industry deposits in the world. And of course, nobody can overshadow his contribution in Gita Basin. Perhaps he is the longest serving worker in Gita. Right from the beginning, he has been associated with this basin, and his work has brought out a tremendous scope for work in the next, say, another 10 years. And his works, we want to continue in southern region, that time working together as a team in Alkal deposit, which has Monolith. I think it has the credit should go to Varghese that he has brought out Alkal as the richest great deposit.
So at the end but then maybe when you're doing it on of all. Yeah. That is what we did. Now, they in the form of the beautiful. I'm very aware of this I'm really proud of now I reference to please some of the guys. So also has a book as a director, Melissa.
As my friend, Mr. Varghese is retiring, and he has invited on his house on that day. I would station to attend, that event, and I'm using that opportunity. So, today I want to, it's not, it's about sharing my love with him. Thank you. Very happy, healthy, peaceful, prosperous, post-retirement life, around with this near and beyond.
Vanita, please help sir. Please. Thank you very much for doing so. Only things that so, as we come to the close of investing workshop on strategy and the calendar. I would just like to take a brief moment to reflect on what we have achieved today. Through lectures, insightful discussions, and meaningful exchanges, we have deepened understanding of what vital areas shaping our nation's vision, Atmanirbhar Bharat, and making India initiatives of government of India. Now, with the kind permission of the chair, I now take this opportunity to formally conclude today's workshop. As we conclude, I will quote Dr. David Brooks, one of the renowned exploration geologists, that mineral exploration is not only a science, it's an art driven by curiosity, guided by data, and powered by perseverance. Thank you once again. Have a safe and pleasant evening. Jai Hind.